I've seen Vidhan Sabha building and Kaban Park. Both were fantastic.
Thank you, sir. I hope we were live streaming when we did that. Please, good morning. Please come. Please take your seats. Yes, your table is still there. Yes. Okay, shall we start? I would like to ask someone. I know it's not good form to start with a question first thing in the morning, but since I asked the Bangalore question, I have the right to ask one more question, I think. Can anybody please, in a minute, share what their biggest takeaway was from yesterday? Some good soul, first thing in the morning. Anybody?
Sir, bolenge sir.
Thank you, sir.
मैं अगर बोलूंगा तो it will become a long speech. Yesterday it was very pleasant to discover many aspects on this used water management. To start with, so defining, we all talk about grey water and black water and all. So we made a differentiation, and Chaurasia ji has clarified there is nothing called grey water. It's all mixed grey water or wastewater, right? So that is one thing. And also the focus of the mission, the budgetary allocation, and the timeline that you have set. So the urgency that is there. So that is one aspect that the clock has ticked. So no going back. It has to be fast tracked. Money is there. So fund is not the constraint. So and also the NGT. So looking at the NGT, we also discussed the standards. I also raised some important points on the standards. So if it is for reuse, then what should be the standard? Then the Haryana case study, they explained that irrespective of standard, because of the NGT, they are very restrictive. Therefore, they have to adopt STPs of high-end technology. So that is one aspect. And the session of yours was very interesting at the end, that what you need to achieve all this. You need human resource, you need policy, you need capacity building, you need IC, so on and so forth. So it is not one person or one mission or one state. It has to be, it has to be driven by a group. It has to be community driven. It has to be people driven, and it has to be driven by not only by engineers, also by administrators. And it's a multi, you can say stakeholder group. So that is the biggest takeaway. When fund is not the constraint, then what is needed to accelerate the progress? That is what, in my opinion, is the biggest takeaway.
Wonderful, sir. Thank you so much. You saved so much of my effort. So I will capture that in one sentence. Multi-solution approach to used water management, multi-stakeholder approach for acceleration, and a sense of urgency. These are the three things we take away from yesterday. And now, without much further ado, we start with today's program. I invite my colleague Rajesh Pai to start the first session. I know in the agenda it's a little, so we have swapped sessions. He's my friend, so he didn't mind. Please. Thank you.
Thank you very much. So you all can hear me. I'm using this collar mic. You all can hear me? Yes, great. Thank you very much. So my topic today is application and scaling up decentralized urban wastewater management or used water management. So yesterday, as we all seen that there is one way to manage the wastewater is through a large cluster base or a centralized sewerage system. So which is a sewage sanitation, what we call. And there is also another aspects to it is a non-sewer sanitation. I think what Sasanka just now said is, I think mixed way is the only way. We cannot have only one way because the problems are so big. There are so many issues in relation to the resource availability, the capacities and all those things. So definitely we need to see that what's the best way. And again, yesterday also we discussed, there are so many ways are there, what to provide where, how much in terms of area coverage and all those things. So these are still a challenges, but today what we will do is, we will try to see that the non-sewer sanitation aspects of it, how, if not in a large cluster-based sewer network way, what are the other alternatives? Not in alternatives, maybe in other options along with the large sewer-based options. So I think yesterday this was shown that this is a typical urban landscape all of us see in our respective cities actually, or towns, where we have a core area, what we call maybe an old city area, where the city has started and then it slowly starts growing, correct? Which we normally call it as a core area. Similarly, we have peri-urban areas. So these are actually, we are in Bangalore's core area actually. So the airport, other sides and all kind of in a peri-urban areas, which is developing fast. Every city has this because of different reasons actually. So similarly, we also have a fringe areas. So this is a very common landscape where within the boundary of the city or a town, we have this situation. But definitely we need to see that from the equality point of view, how we satisfy everyone in terms of improved sanitation or sanitation for all. So the general practices of used water management, as yesterday I said, we were talking about black water, gray water, mixed wastewater, all those things, which is generated from different sources like a public toilet, individual households, a settlement, housing colonies, apartment. There are so many different places from where this used water is generated. So normally the existing practice, as you all are aware, is either we handle that through kind of a non-sewer sanitation and through a sewer sanitation. The place we are sitting here, we have a sewer sanitation because it's a core part of the city and it's been connected with the sewer system. Whereas a little bit on outside actually of the city, we have a non-sewer. So under the non-sewer, actually normally wherever there are septic tanks and all, we need to have kind of a fecal sludge management. And at the same time, we also need to see whatever the gray water and black water mixed together. That's what we said. The used water from in the form of black water, we actually, which we take it from the septic tanks or a pit that needs an appropriate fecal sludge management. The other wastewater, which I would not call it as a gray water because yesterday it was made clear, if it is at the source, if you collect it directly at the source, then you would call it as a gray water. But normally it is not the case because we discharge that into the stormwater drain where it is mixed with the black water. So that's the reason it becomes a mixed wastewater. I have mixed it there. That's the reason black water plus gray water, which require a drain-based used water management. And third one, sewer sanitation, as we, again, in this also, there are two types. One is a large cluster-based sewer system, which we call it as normally a centralized system. Other one is a small cluster-based system, which we call it as a decentralized system. So if you see this, actually, normally people categorize these three things, the non-sewer sanitation, two of them, and from the sewer sanitation under decentralized sanitation system. Okay, and the bigger cluster, normally this is called as a centralized management system. Again, there is quite a lot of debate going on what is centralized, decentralized. For example, in Bangalore, we have a decentralized centralized system. There are so many small pockets, but it's not very small. It covers a plenty of square kilometers of area in each of the pocket. In the Bangalore level, if you see that our wastewater is managed by the decentralized system. But if you see one cluster, that itself can qualify under a centralized system because Bangalore is so huge and each pocket is also very huge. Okay, so now let us try to understand a little bit in detail where and all is this been applied. For example, this is a city we talked about the core area. Here, normally we get into a large cluster-based system which tries to cover a core part of the city area and try to bring in all the wastewater through these pipelines If there are flat area, then there is a pumping requirement so that the wastewater is brought to one location. Most of the time, it is located a little bit outside the city where it is treated, and definitely then the reused water can be used for an urban agriculture. So this is one way. And the decentralized sewer network, as I said, mostly try to cover the peri-urban area or maybe a fringe area where again there is a density, but you cannot connect from the core area to that area, the sewer system, because you have to lay a very long pipelines. As you all aware, around 70 to 80% or sometime more, the sewerage system cost actually in the sewerage management project is the pipeline cost. Pipe means not the pipe, the entire process. Yesterday, Devang Bhai is very clearly explained to us. So what I'm trying to say is, if we decentralize, then actually we could reduce some cost because we don't have to transport the wastewater for a longer distance. Similarly, the third one, we also have plenty of pits, septic tanks, which also we need to deal with it actually, because everywhere we cannot go with the pipes. So that's where we will have a kind of a fecal sludge which is treated in a STP. So co-treatment is the way forward. So I think we all from an urban area, actually, wherever there are STPs are there, we should give the first priorities STP as an option for fecal sludge management, fecal sludge treatment, because it's very easy because the facilities are already available within the system so that it can be treated. Even under Swachh Bharat mission, when you are going now with implementing an STP, please consider that your STP also handles the fecal sludge. There is a provision should be given in the design because these are all greenfield project now. So you're planning to do that. So wherever you see there are smaller towns, maybe absolutely there is no possibility for a co-treatment, a kind of an FSTP with the sludge drying bed, a little thing where the sludge is not coming too much. You can also plan for that. For example, one of the town where you will visit tomorrow, Devanahalli, it only has a single pits. There is no septic tank. Almost 90 to 95% is a single pit. So that means whatever water, the black water, whichever comes from the toilet, it gets into the pit and percolated down. And the groundwater table in that place is more than 800 feet, 1000 feet. So groundwater contamination also doesn't occur. And the gray water, what it comes is very, very little actually. So, and the gray water farmers are comfortably stopping there and using that in the farm. So in such cases, if it is a single pit, it also fills faster. So at that time, there may be a necessity of an FSTP. If not, the STPs are available closer. So the last part, again, there are so many water bodies, lakes, rivers in your cities, which actually gets the wastewater through a stormwater drain. But unfortunately, all of us are using now the stormwater drain as a conveyance mechanism to push the water from a household. And all these at the end reaching to these lakes and rivers because these are the low-lying areas. Correct, na? So in many of the places, people have converted the ponds itself as a wastewater treatment system, but please don't do that. So how we can avoid that is intercepting the water before it enters into the treatment facility and diverting that into the treatment facility. Correct? Intercepting, that means before it enters into the water body, provide IND system and divert the water to a respective STP. So that is this one actually, where there are so many options. You will also visit one of the projects site tomorrow where you can see a practical working project. So I'm now going to talk more on the decentralized aspect. That is a small cluster-based decentralized urban, used water management. My colleague Sasanka will talk a little bit about co-treatment, and other colleague PG will talk about interception and diversion. So today's topic is mostly towards that. So these are, as I said, the four things, whatever I explained is the existing practice. So what we should do under now SBM to reach to this water plus? Anything new can be done? No. What I see is these are the four solutions only what we have. For the last 20 years of experience, I see that other than these four, we don't have any other alternatives or other new things what we can add to it in order to ensure the citywide wastewater management. Only thing other than finding a new thing, Only thing what we have to do is integrating all these together. That's the only way forward. Because we cannot dream now something new will come and all such things. Even from the technology point of view also, there are so many technology which is already been established. Only we need to see that what kind of a design changes are required to a context specific situation, rather than dreaming something new comes. No, it will not, because these are all available. And from an approach point of view, these are the 4 approaches. What is in practice will also continue. Only thing is, instead of doing one here, one there, we all need to see that how all these 4 can be integrated together so that we address all the problem of this city. Okay. So now with this, I will, you will see that the centralized network-based system, decentralized, FSM, everything will interception and diversion, all these things. So tomorrow, maybe after 2026, whenever we come and see a city from top, I think this is what we may see actually. And we are hoping for that. Okay, so now I'll get into my topic. I was just trying to set the context till now. So now it is decentralized use water management, what I will talk about. What is this decentralized use water management? It's a simple. It's actually you try to collect the wastewater near to the source or at the source from where the wastewater is generated. Yeah, please. Okay. Can someone help me to take this down? नीचे रख सकते हैं. ಕೆಳಗೆ ಇಡೋದಕ್ಕಾಗುತ್ತಾ? ಕೆಳಗಡೆ ಇಟ್ಬಿಡಿ. वायर हाकि मुझे अभी भी मुश्किल हो रहा है, दिख नहीं रहा. ओके, देन पुश इट दिस साइड प्लीज. ಹಿಡ್ಕೊಳ್ಳಪ್ಪ, ಈ ಕಡೆ ಇಟ್ಕೊಂಡ್ಬಿಟ್ಟು ಆ ಕಡೆ ಮಾಡ್ಬಿಡು. ಇಬ್ರು ಹಿಡ್ಕೊಳ್ಳಿ. ಹಾ, वो ले लेंगे सर तब. तಗೊಂಡ್ಬಿಡಿ. Thank you. Yeah, sorry for this. So what we were saying is decentralized use water management is you try to treat the wastewater or manage the wastewater near to the source, which means you don't have to take the wastewater to kilometers, which would sometimes increase the cost. So that's the reason, especially for the peri-urban areas and all, this is mostly applicable. Second one, it also provides you an opportunity to do a incremental modular approach based on your requirement, rather than providing full-fledged for 20-30 years and all, because decentralized systems are normally provided for a small areas. So which means you can really see till where it can grow. So you can have a better planning approach, rather than in a centralized system, you always try to take that for many years actually. For 20-30 years you plan. Here, you will already know that how big it can grow in future, because the area is limited actually and not unpredictable. So similarly, it is cost effective because, as I said, because we will not have a deeper sewer system, larger pipe, from all those things. If you see that, it would be a little bit cost effective in comparison to the large cluster based system. Similarly, depending on the context, the systems can be designed to enable the local water reuse. It can be very well integrated with the reuse planning. So this should be the way. Even our Water Plus, what it says is at least 20% of the treated water should be reused. So this also gives you a great opportunity. Just to tell you that in Bangalore, actually we have a water supply network in the core area. Outskirts we don't have. So most of the high-rise apartments, they are reusing the water with a high quality of treatment. Big developers, because there is no option. The water is 1,000 feet below. And there is no river, nothing. All the lakes are contaminated. We get a water from 120 kilometers far. and we don't have that much of water because the city is growing fast. So people are reusing it. So more than the law or something like that, it has become a necessity. This will be the same in all the other places also in the future, so that we start it now itself. So this SBM really says that actually at this point of time. And if you talk about the decentralized system alone, like from 2002 onwards, basically in this range, 2002 to 2006, it slowly started this approach. Before that, either we used to talk about the centralized large cluster-based system, or we used to have a on-site system only. There was no in between. So this approach has started. CPHO manual also started recognizing that they have put in, and from there it is started. And as on today, more than 20,000 small scale treatment plants are available, and Bangalore being the hub for that. In Bangalore, there are plenty of them are available, but there are also issues with that, which also I would like to discuss. So I think this is a little bit a difference between the centralized and decentralized in terms of the planning approach. If you see the cost, because you are planning to cover the entire big city, so the cost sometimes is a factor. This is all you are telling now. A scale of construction also very huge. O&M cost also, because it's a large system. And then risk due to system failure. This is one of the things, because if it if it fails, one pump station fails, the entire area gets an issue, actually, risk. Whereas it's an opposite in the decentralized system. Yeah, so this is the only little difference. If you can see the picture there, you are taking all the wastewater to one location, whereas in the other one, you see, you try to deal that at a single household level, at the colony level, at an apartment level. In fact, I think this Hotel Lalit also has a decentralized system, I think, actually, where they are treating all our wastewater, which is generated, treated, and then reused back into the landscape, actually. Yeah, this is an advantage of decentralized system. I said this already, a great opportunity for the resource recovery. And as I said, less vulnerability due to smaller scale, the risk, whatever I mentioned in the previous slide, a great opportunity for reuse. So quite a lot of the treated water has been used for a landscaping purpose here, actually, which means that much of a fresh water requirement also reduces. So I think this provides that opportunity. And of course, as I said, incremental approach is also possible. And mostly the beauty of it is actually it provides an opportunity for pollution abatements in these ponds, because I think this is also the way forward for a smaller towns, where the drain wastewater, which is flowing in the drain, you can stop it, you can treat there itself and put the water into the lake or the river, actually. So the components, normally whenever we talk about the decentralized used water management, the simplified sewer system is the system what we talk for the sewer system. The difference between the normal conventional and the simplified sewer system in terms of design parameters and all does not vary much, but in the conventional sewer system, which is in the public domain, we try to put the sewer system below the road, because it cannot go into anybody's private property. So because it has to be put below the road, it has to go deeper to take the vehicular load, and the slope, because it has to go for a longer distance and all. Whereas in the decentralized system, as it is sometime within the smaller area, where you can get the consensus of the community which is using this facility, and try to put the pipelines behind the colony, behind the household, or on the side, or on the footpath. All those things are possible. This way, actually, it minimizes some kind of a cost, actually. So that's where there are two types of system normally people are using. One is a small bore sewer system, which is called as a settled sewer system, which means wherever there are already septic tanks are available, there actually the solids from the household are settled, and only the clear water goes out. Whereas in a shallow sewer system, as I said, we try to put the pipelines just around on the side or at the back of the house, so that you don't have to go deeper. So it also has plus and minus, actually. So, but this is people normally use it whenever they do the decentralized system, actually. So similarly, from the technology point of view, I'll not detail it out. Chaurasia sir will talk about that in detail about each of the technology, but just to tell you that wide range of treatment technologies are available in a packaged form. Either it can be nature-based, or it can be a conventional, which means electromechanical based system. So these are some of the technologies which is widely used for such decentralized approaches. Actually, on the top you can see the decentralized the electromechanical system, and at the bottom you can see the nature-based system. So right from the community soak pit, DWATs, constructed wetland pond system, again based on either it can be at a household level, it can be at a small community level, or it can be at a larger cluster level. So see what applies where, and then you can propose that. So again, this is again, as I said, at the end of the treatment, definitely you will get, these are the treatment products as well as a byproduct. Direct treatment product is the treated used water, whereas the byproducts are sludge as well as a biogas. So there is also possibility that you can use that for different purposes. There are many cases available where all the threes have been used at the source itself actually. So inclusive sanitation, whenever we talk about, it's not only about the collection and treatment, integrating reuse aspect also within it. I think henceforth, whenever we think about any kind of a treatment, not only from the treatment point of view, but also from the reuse point of view, it has to be integrated, or else actually, as I said, we are wasting a big resource there. So these are potential fields of application where this is possible. I would see decentralized used water management is possible in a served area as well as an unserved area. Served area means where already the sewer systems are available. Within that also, for example, this is the case. This area is covered with the centralized sewer system, but still they have it. Why? Because they wanted to use the water. So similarly, for an unserved areas, you see a new development area where actually the pipelines are not there. You can apply that. Low-lying areas, most of the time in the centralized sewer system location, because it's low, small pump needs to be provided. So that's the reason they leave it out actually. So in such places, you can plan for such system. Slum areas, again, this has been left out because of issues with whether it has been notified, unnotified. There is a possibility to use this. And of course, a reuse requirement, as I said, in the lake to maintain the water balance. Of course, and then at the outskirts of the city, always there is an urban agriculture is possible. There also you can use it. This is mainly in an unserved areas, whereas in the served areas, as I said, sometimes it helps also. Quite a lot of wastewater is generated from this facility now, Ashoka Hotel. Maybe the sewer system outside maybe is not designed to take care of that, for example. So then this will help to reduce the quantity as well as quality also of wastewater, which may be discharged into that, because water has been reused here also. So that is one system in the served areas. And second is, as I said, avoids the pumping. For example, there may be many areas where pumping is required. Instead of a pump station, from that area, you can put a simple wastewater treatment facility, because pumping is one of the very cost-intensive process actually in the wastewater conveyance. And then on-site reuse requirement, already I have said, as well as rejuvenation of water bodies and water balance. It's very important aspect. There's a big story in that, because in the time, I will not tell that when you visit tomorrow, one of the site, Mahadevpura project site, you will also get the story of it actually. So ultimately, as I said, these are the places where you can use it, which again, I will not detail it out at a household level, at the lake level, everywhere it's possible actually. So other thing is scaling up. Why these decentralized systems are not getting scaled up? Because yeah, it's been recognized by the institution, government, everybody, that it's a need, it's one of the solution, but it's not been rapidly scaled up. There are some issues with that. I think I little bit wanted to go through that also. This very important enabling factors to scale it up is, one is I see that availability of informed choice material, because nowadays what happens is anybody wants to do it. The mindset for the designs are in a bigger thing actually, like people try to design it as the same way as what we design it for a larger cluster based system. And the technology what they use it also, sometimes it is so hi-fi, which may not be required for that particular context. So this is one of the issue actually. At the same time, appropriate finance for implementation. As on date, most of the finance comes only from the private sector for this. Of course, there are government schemes are available, but I think mostly now it is private sector driven thing. Then involving key stakeholder partnership. These all I'll cover in the next slides. So all this being said, of course, developing and regularly updating the knowledge and skills. One of the biggest problem what I have seen is till date, I think there is no accurate database which talks about how many decentralized systems are available in India. Whereas I think CPHO, CPCB, they have a good database of a centralized sewer system, which is managed by the utilities. But decentralized system, nobody is aware about it. It's very important that we have a database for that so that we know what's happening actually. Yeah, over. So cost, if you see also, sometimes these are the cost around, I have taken for 1,000 population with 100 KLD. It would cost in this range if you provide the pipelines, treatment and O&M cost. And from the funding opportunities, these are some of the institution, either dedicated sanitation programs or from various ministries or maybe from the private sector who can fund and who are funding the decentralized system. So Sang, 3 more slides. Yeah, these are the key stakeholders. Again, all of us are aware for planning, for operation, for regulation and for policy. For everything, for every section, we have a clear stakeholders. Only thing is, we only lack sometimes with the regulation, monitoring and permits actually. This is where we definitely have to see that how this system can be well monitored, well regulated, well documented so that it becomes sustainable. So quite a lot of programs are available nowadays actually from the initiatives, the policy initiatives from the government. Like in many, actually Bangalore also, more than certain square meter of a construction area, they say that you need to have your own treatment system. More than certain cubic meter of wastewater, they say that you need to have your own treatment system. So similar policies have to come. So many states and cities started adopting this. I think we should also see that how all the states can also adopt this so that the burden of a centralized system also comes down. Yeah, so these are some of the existing management and governance issues. I think very important. As I said, one is a lack of recognition. People still think that it's a possibility, but when it comes to an implementation, they don't really see how this can come on ground actually. There is an efforts required there. Very, very important is, which I've seen personally in Bangalore, this crucial system startup and handover phase. The developer builds all the facilities and he runs it. What kind of a technology he uses it, how he manages it, the know-how is only with him actually, or her. So once this system, actually the developer's job is over, once it has to be handed over to the welfare association, resident welfare association, it's been just said, oh, please take over. So there is no systematic transfer of how it works, what all has to be done, what kind of the capacities the operators need. This has been not done. So that's the reason the moment the resident welfare association takes, they will identify at that point of time, oh, this is very expensive, this is very complicated, and sometimes they simply do not operate, they switch it off. So that's what is happening actually. Rest I said actually, so I'll not. And one more very important aspect is this sludge management. You know that even wastewater treatment system, either a centralized or big or a small, produces also a good amount of sludge, which needs to be handled. In a centralized system, we have a sludge drying facility actually, or a sludge dewatering facility in terms of mechanical or maybe nature-based. The similar thing is also required for decentralized system. As on date, they really don't know what to do with that. So this is also one of the biggest problem. And the last is actually the O&M personnel. This I said, the operator, whomever they choose actually, their understanding of how system works is very, very limited actually. They have been asked only to switch it on and switch it off. How it works, what it does, they are not aware about it. So this also is one of the very important aspect. Yeah, these are some of the possible measures. What I said for the issues, whatever I have said in the beginning, licensing vendor, having a good quality of informed choice material. Then incentives. I think this is definitely government has to think about it. Giving an incentives to these people in terms of reduction in property tax, development taxes, water tariff and all. Because like how when you provide the solar-based system, when you can sell, you get the money. But there is no incentive here actually. So it's like we see that you are a polluter, you have to pay for it. But in the beginning, at least if we can incentivize people who are doing it, that would also give a motivation for the people to set up this. Yeah, then standardized procedure for technology as well as its implementation. And setting up the sludge management facility somehow. So we are now anyhow, we are planning an STP, co-treatment is still possible in that. And the market development. And the biggest problem is this discharge standards. As discharge standards, we are really asking for a very stringent standard. Sometimes it is very difficult for these people to maintain it actually. So that's where most of the time these people try to not operate this facility all the time. They try to keep it off only when once in a month or once in a year, when the pollution control board comes to see their system, at that time they will switch it on. So this is also an issue. Yeah, I think this is the last slide. Again, the key summary, as I said, once again, I say that the ownership of used water management from this decentralized used water management gives an opportunity to transfer the responsibility from government to really to the polluters. So instead of the service provider, government can become a regulator actually. Yeah, that is one. Second one is, of course, it complements the conventional sewerage system as well as an on-site system. So that's really a great opportunity. And then, of course, the reuse aspects, it really create a local water cycling loops and reduce the stress on the water sources. So I think with this, with this summary, I really wanted to say that definitely, I think this is one of the solution. Definitely, when you plan this as one of the solutions, see that the regulatory aspects, governance aspect, monitoring, documentation, all this comes together also, so that we have a very good database, we have a good monitoring mechanism, and at the same time, the reuse also should be very well integrated. Somehow, for an agriculture purpose or for a construction purpose, I don't know, there are many opportunities are there, technology is also available. Let us not have one stringent standard for everything actually. It should be reused based standard. I think we should think in that way. Thank you very much. And if you have any questions, you can ask. If not, Sasanka is already flagging. Yeah, please, sir. Sir, sorry, I gave that. I'm extremely sorry. Yes.
Excellent presentation. In a morning, it cannot be better than that. I think, and you also people might have really realized the way he has presented that what is going to be solution. Two things are very important. Whether it is a technology selection, there are also different options are available for different areas. This I am telling, if proper plan is prepared, cost of implementation will come down. Right now, all these things have been, let us say, हम जिसको हिंदी में बोलते हैं बदनाम है इसलिए कि ड्यू डिलीजेंस और एप्लीकेशन ऑफ माइंड इन प्लानिंग हम नहीं करते हैं। एक साथ पूरे को लेके सीवर कर दो, चाहे वो एक भी घर हो, तो पॉलिसी में तो इफ आई एम वेरी लेविश एंड हैविंग लॉट ऑफ मनी, उसके लिए तो ठीक है, ईच एंड एवरीबॉडी, एंड इट इज ए प्राइड टैग एंड अदर। लेकिन जिस लेवल पे वी आर ग्रोइंग, इन दैट केस proper planning is required, and he very clearly mentioned that there are only 4 options available. Out of those 4 options, where what is suitable you have to plan as per treatment is considered. Similarly, in case of sewer network or sewage collection also, there are 3-4 options. If larger, go for conventional. If in small area, simplified sewer, small bore sewer, this things is done, and this is not a let us say static, it is dynamic. Over 10 years, if population has grown, things are developing fast, that can again go in conventional, and other thing will be switched over, which are new area. So if 2 things are kept in mind in planning stage itself, these things are very, very affordable and very, very doable. Somehow that level of, let us say, focus and other thing has been missing on centralized and state level. Now right time has come. And like we are seeing example of solid waste management, where everybody involved and every city is working as a innovation bed, I am very confident this is also going to happen the way he has very clearly mentioned. So 2 things regarding this coverage, whether network and whether treatment, and these things will drastically bring your not only capex, but OPEX also, and best quality of sanitation facility you people will be provided to your people at affordable rate. That is 2 things I compliment for that. 1-2 point I would like to add, especially centralized versus decentralized. We also examine these things, and even Rohit Chandri is here. He worked some point of time. Me, Rohit ji, and Satish, all these people we discussed with these studies. Some 300 plants were studied here in Bengaluru and other places also. So as far as capital cost was coming, we found that whether you go by decentralized or go by centralized, capital cost almost remaining same. Because in centralized, the pipe network cost, STP cost is less. In decentralized treatment plant cost is more, network cost is there. But this become only cost thing. But when it comes for feasibility, in larger, you have to go centralized only. In smaller, this is a more feasible thing. But another thing is there. When it comes for operation, maintenance, and control, centralized has better control and it can be used as an industrialized one. Decentralized, that level up, so many actors are there, control is not there. But then how to start? One go centralized, we cannot start, we know cost, random, everything. So start has to be done in many cases as a complement to centralized, in decentralized manner only. And this will help in another way, that right now, if you see, enough capacity is not there. If we start in 4,800 town, let us say we are doing robust sanitation through sewer network and these things, capacity is not there, and whoever contractors and other people are there, they will be doubling their rate. Another thing, again, cost will go up and become unaffordable. So what is way out? Less skilled are those people who are working, or even those things where it is affordable. Let all small contractor, small people also come in the field over the time, and as a complement in the sideline, let them also work. That will give you a competitive costing, and things will be done in a mission mode in a given time. And once this system is there, the more city grow, centralized will keep on swelling, and decentralized will again start coming in outer area and other. So this may be one way where we have to plan, and this is doable. The way he mentioned very clearly that strategy is required, plan is required, and vision is required, how I'm going to do and how I'm going to swell over the time. एक पॉइंट इसमें और मैं आपको ये जोड़ना चाह रहा था कि modern time में, as he mentioned, Devanhalli, you are going to see also that 90% houses are still lying on single pit. That let us discourage it. That is not a thing to even so, I find, because it is not only a matter that 600, 800 feet the groundwater table is there. It has nothing to do. Over the year, it is going to be discharged in only few meter, few feet, and that get clogged, spore gets clogged, even though water pollution body may not be polluted. And over the time, then incidents of a little bit waterlogging, not proper functioning, mosquito and other thing will come, and population is growing itself. So that is fine till we don't have anything, no money and things. We are very beginning may starting, but we want to begin with somewhere in villages, we are doing single pit, that is fine. When we are slightly going to double pit and even septic tank, then we are going for sewer thing. These things should be kept in mind and do. These sort of things. And if we are capable, altogether eradicate that. We don't want to put here weather ground. We have not studied how many flora, fauna, all these things are there, and this ecosystem is based on all those things. So those crude practice we have to avoid to the extent possible. But to begin with, jahan pe aise villages hai ya there is no other facility, that is another thing to begin with. This is what I wanted to work. I compliment. Thank you.
Yes, sir, please.
You rightly mentioned about the community. You have a lot of STPs in the communities.
Correct.
For example, in the apartments or in gated communities.
Correct.
And you have also mentioned that they, just keep it on when the pollution control would visit them. This issue is always, prevalent in all the cities, I believe, be it Delhi or Bangalore or be it in Bhubaneswar or elsewhere.
True.
And in my opinion, the issue is that the package treatment that they are adopting, the market is highly unregulated. The technology is also not standardized. Nobody knows what is there. What comes in and what goes out, what is there inside, nobody knows. And you have also pointed out the issue of slush coming out from that. So I will request CPHU to come up with some standardized documents, so that, because when India grows, when the cities grows, you will find a lot of these gated communities. So you will not have single houses, you will have multi-story apartments or houses like that.
Correct.
So we talk about centralized system, decentralized system, that is fine. But when we talk of gated communities or apartments, I think CPHU has not yet standardized or some manuals or something. It has not come up. So my request to you, Dr. Chaurasia, is that थोड़ा काम करना जरूरी है. Thank you.
Anybody else? Sir, please, sir.
Information just share
Yes.
करना है.
Yeah.
Abhi whatever, even in single our rural villages also, whatever single pit, even if we are making, we since have not done any structural study, so we keep on doing it, rather than on the surface, let it go for the very time being. But we have not done in a scientific study, and it is not guided. But the places where this has been studied thoroughly, like US EPA and other places, they tell even that soak pit and other, it dependent on land and other thing. And the single plot where one soak pit should be there, that is 0.8 acre per lot. Matlab these things, even in Malaysia, that is very neighbor to us, 35 square meter, that matlab soakage area and other should be there. So properly do that. So as a ad hoc thing, when we are beginning, it is fine. If we really want to do that also, let it be do in a proper scientific manner after studying pros, cons and other. That we are not doing. So this is message I wanted to share with you. Thank you.
Yes. Yes.
Just one point to add, actually, under EIA, you already have some guidelines.
For which ones?
EIA,
EIA, okay.
Environmental Impact Assessment.
Yeah.
Actually, you already have a guidelines. I guess if your build-up area is more than 20,000 square meters, then eventually you have to go for this kind of small scales and decentralized plans. That's
Yeah.
it. Thank you.
Yeah. Many states have this already, actually, and the cities also. In Bangalore also has. Bangalore has a zero discharge policy also at one point of time, which really did not work because more than 20 to 30% of the water one cannot really use. It is for, as far as my understanding, it was for Bangalore. Rohit, you have, yes, it's for Bangalore, right? Karnataka, okay. Yeah. Correct. Okay. Yeah.
Just one,
Sir, please. Sir. Okay.
as you proceed ahead,
Yes.
this is a meeting for cities which are less than 1 lakh population.
Correct, sir.
So it will be better that we kind of relate with them. 20,000 square meters. They see the sake of decentralization for whatever picture you have painted for Bangalore, where you have a huge core area and huge non-core areas where these things are there. But in case of a small town which has got a population of 1 lakh, you got around 20-25 square kilometers of area. And people are spread out in small pockets, and there is nothing called RWAs out there. Everybody is dependent on the government. So when you say that who takes over the responsibility, and you say that responsibility shifts to the polluters and government becomes the regulator, then who are these people who will become the owners of these establishments? Can you just, I don't know.
No, I think this is always the question, sir, actually. See, that's what I said. As on date, decentralized systems are governed by the private sector only. So as in the government, this one, we are saying that it also has to be, and you, as you rightly said that, especially for the smaller towns, maybe there are no RWAs or maybe a gated communities when it has to go. Definitely the government has to find a mechanism whether they would like to handle this. Because, for example, BWSSB is here, who is handling the entire sewage. But to what extent they are involved in monitoring or maybe supporting these decentralized systems, whichever is coming, that is also not clear. There is no clarity between. So somehow I think these are the discussion points that we need to have it and see that how this can be done. Then only this can be scaled up, sir, actually.
Yes.
Yeah. Sasank, you wanted to say something? Anybody else? Yes, sir, please.
Good morning. Thanks for your detailed presentation. Sir, I have 2 points. One, you have come up with a reuse. What exactly is a reuse you mean to say? That is one question, sir. And second question, in our state, we have almost nearing 3 digits STPs, but most of the STPs are under utilization and also functioning is not as desired. What is the solution for that?
So for the first,
Creating a new asset, we are very good.
Yeah.
Okay, but when we create an asset, we have to maintain it. But now the challenge for us is how to maintain the existing already constructed STPs.
Yeah, I think the first one I'll answer. The second one I would request sir to answer. Yeah, the first one is basically the reuse in terms of, see, we talked about treated water, which is a main product of the treatment, and then the byproduct, which means the sludge, which can turn into a biosolids, and then the biogas in case if there is an anaerobic digestion which is happening there. Yes. Correct. Correct. That is one way. That is a safe disposal. Reuse means for an agriculture, for landscaping, for construction, for road cleaning. Okay. Correct, sir. Correct.
And a landscaping. But a city of population where the 20,000 to 30,000, 40,000, definitely it is not possible.
No,
Even in Bangalore, sir, we are treating 135 ml of territory treated water, but we are unable to sell about 20 to 30 mld. Why should we have to spend so much of money for treating a tertiary water when there is no demand? Suppose if you go to Tamil Nadu and Gujarat or Singapore, you have plenty of used water demand, but Karnataka is not in a water-based industry. So if you put a mandatory condition that I have to do 20%, practically it is not possible. Because when there is no demand for tertiary treated water, who will take the secondary treated water?
yeah, sir, sir. I said that that's the reason the discharge standards, whatever technology you implement, it has to be based on the discharge or the reuse standards actually. For example, if you want to go for an agriculture, you treat it to an extent that. No, I'm not talking about Bangalore. You're talking about the smaller towns. Smaller towns is covered with quite a lot of an agricultural area where presently the fresh water is being used. So instead of that, if you use this, the nutrient what you get in that, and at the same time, the requirement of water can be compensated. So the stress on the fresh water would reduce. That's what I was trying to say actually. Sir, please add some.
Yeah, very rightly mentioned. There are various ways of reuse. It is not only we have to see from centralized angle where we have to go tertiary and only industry is using, and rather from apart from safe disposal, your one query was if we are regenerating or recharging some of the pond or lake where it is being used for recreational, that also comes under that category, but not that after routine we are treating and disposing, that thing we are not considering. So various ways are there, that is fine. One thing you mentioned, Uspe, I want to react to that lot of capacity is created and other things are done. For that solution, what he is mentioning, and very clearly he has brought out ki proper planning should be done. That one thing has been mentioning, only we projected some population for 30 years and then we said that we are not sure whether sewer network is there or not, whether house connections are there or not. Capacity is there, but flow is not coming. That has been one reason. To take care of such type of shortcomings, which often drain out a lot of resources from the ULBs. In this Swachh Bharat Mission 2, what we have done, you do only for the present population or even less than 70% of present population. You utilize fully, again come we will provide that fund. Lekin we will not allow that something hypothetically you present for 30 years, we don't know, create infrastructure, then there is no connection for assured flow and it is running even half of the capacity, and when it's 30 years expired, even it is not able to reach that capacity and entire asset lying unutilized. So these are the path breaking things we are doing, and here also it is very much required. I would mention that before that, draw to analogy from solid waste. All solid waste plants earlier before the Swachh Bharat Mission, they were very much including this CND waste, including dry waste, wet waste, सबको लेके centralized बना देते थे, प्रोजेक्ट करके और बड़ा हो, आगे फंड मिलेगा कि नहीं, I don't know. अपनी सिटी के लिए बड़ा बना दो, हमारा प्रोजेक्ट बड़ा होना चाहिए। नन ऑफ देम प्लांट वर्क एफिशिएंटली बिकॉज ऑफ ओएंडम एंड अदर। इस तरह का वेस्टेज नहीं करना है। लेट अस स्टार्ट जितना हम कर सके, इंक्रीमेंटली इंक्रीज, एंड आई टेल एंड आई एश्योर that now it is priority of not only central government but state and ULB also. People have also become aware funding will not be problem for this sector. It will come from here or there. So let us have patience and do in a rational manner where maximum benefit we can get. Thank you.
Thank you. Sir, just last one. What I got the data was more than 4 lakh hectares of agricultural land is surrounding the class 2 towns, class 3 towns. So enough opportunities are there. But as you rightly said, the treatment system also should be at the end, the discharge standard we need to define also based on the reuse requirement. If we put it flat, then always it's an issue. Yes, we need to move. I think maybe
Sir,
you can also.
I have one question. Yeah.
Please.
Yeah. For a hilly region, usually the STP is located at the low-lying areas. After treating the gray water and the black water to use for the city, it has to pump up again, which is not cost effective.
Yes.
And at the same time, like if we dispose to the streams, like we can say that it is a kind of reuse. Shall we say that it is a kind of reuse? If we dispose the the after treating, or at the same time, like for the cultivation purpose, all the cultivation is done near the stream, near the rivers. The thing is that they could easily get the water from the rivers. Like to use for the cultivation also, it is not a, we can say that it is not benefit. The thing is that they can take easily from the rivers. To pump up to the city, it's not profitable or it's not cost effective.
No.
Can you give any suggestion or comments on that?
I will do one thing. I will just finish 3 examples from Maharashtra in which we have done the 3 experiments. One is at Aurangabad, where the municipal water is treated and given to the farmers growing society. And there it is a World Bank aided project, number 1. Number 2, Chandrapur Municipal Corporation is selling the treated water to all the developmental works which are happening in Chandrapur, which is hardly a 4 lakh population now. And third, of course, is the Nagpur Municipal Corporation example, where 70 crore rupees are earned every year by the municipal corporation by selling the treated water to the National Thermal Power Plant. Thank you.
Let's have this example for your Mizoram. So exactly the same example has come to us recently from Leh. They wanted the treated water. They got a 3 MLD treatment plant existing, and they are pumping water from there. That was their plan. They'll pump it up 90 meters and use for landscaping and forestation. And we responded, you got a perennial river running next to you called Indus, which is a huge river. If you want, you take the water from upstream, do all your forestry from the, from the fresh water, and leave this treated water for the nature, and it will go down towards Kashmir and get treated. It's very logical. And whatever you're saying is exactly what we have instructed them, that this is not how you plan. Any engineer can understand. It's not a cost of just because we are saying reuse. The reuse has to be done in the upstream, like against the gravity. That is absolutely, even the demand. And the worst part was some of the renowned private consultants. Pardon? So they have been advocating. So these kind of so-called, I'll use the word foolish, solutions are not what we expect out of any of the states. Very well pointed out, and this is not how it would be. You use this water downstream, if possible, for agriculture before it enters the water body, if possible, under gravity, but never go for pumping for such.
So can we please move on?
Yeah, I think
very late.
Yes.
I know there are many.
Sir, I think we will take this discussion after this. Yes, sir, please, quickly. Okay.
That reforms incentives in the guidelines. For that reason, I'm stressing, please mention what exactly the reuse. That's it. Thank you.
That's a very good suggestion.
Very good suggestion. We'll take it, sir.
Thank you.
Yeah, please, Sasank. I think you can start.
Okay, that was intense. And very, a lot of back and forth happened. Can we take a deep breath? One deep breath, please. And then we will get into more shit. So
Sorry, I'm not supposed to use that word, I guess.
No, abhi to we have taken the after you are.
No, no, sir.
starting-
Breathe, breath, not, not a breakfast.
No, 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 no. Yes.
Extensive discussion happened.
Yes, yeah, we'll have to forego breaks now. So anyway, thank you, Rajesh, for setting the context. There are, 3 or 4 approaches that he counted. I was also trying to say yesterday. Yesterday, we discussed sewerage in detail. Today, we are doing the other, solution approaches in a little more detail, right? So you saw the decentralized approach, which is the first one. I'm going to talk about fecal sludge management now. So we have discussed enough that you have now got a grasp of where fecal sludge management is required. We use the word unserved areas to provide fecal sludge management in, right? And there are many such unserved areas. Rajesh has said the context. This is typical. It need not be representative of your city or town. So where you approach, how you implement fecal sludge is up to you, the way you plan in your city. Fecal sludge management, if you want to tell the story in one picture, this is the picture. Just take a look at it for 3-4 seconds. That story of fecal sludge management is in this picture. Your pit or septic tank is full. You call somebody, they come to your house, you pay them money, they take your waste, and then they don't know what to do with it. They are providing us great service. Its society is being served, but unfortunately, they don't know what to do with the waste. So the people end up doing this. It's not their fault. It's not their fault, but unfortunately, this is what is happening. So managing this properly is what is fecal sludge management. And if you want the more formal definition, this is the picture which shows the more formal definition of fecal sludge management. We have built toilets. There are containment units or on-site systems, OSS, that's what we call them. And then somebody is emptying. Hopefully it goes to a treatment plant. Very soon we will have a lot in the country, so this might come true. And then there is reuse happening from the water as well as the solids that come out. So that is the formal definition of fecal sludge management, doing this safely and doing this in such a way that public health and environmental risks are mitigated, right? That is what it is. Now, some definitions, I'm not sure if it's necessary, but the matter that is retained in an on-site system is what is fecal sludge, to put it in a very mild and simple way without getting into all the science and all that. So whatever is left, that is fecal sludge. There is in a septic tank something that flows out, we all know, and that we call effluent, supernatant. Many words are there for that. That is what is. What are the typical OSS in urban India? This is a very risky statement I'm making, typical. There is nothing typical about OSS in India. If you go to Rajasthan, there is a queen, there is a septic tank which has partitions vertically also, and I mean in the sense laterally also and longitudinally also. If you come to a different place, you will see a completely different system. If you go across India, the number of varieties of OSS are only limited by the creativity of the mason that has built them. Yeah. So there is no such thing as a typical one, but just for discussion's sake, we have given them these names. Septic tank, how it works, I will not get into that. You know very well. Water comes in, solids settle. After the solids settle, water leaves, right? The retention time, the time that water spends in that septic tank is critical. Because of that retention time, solids and importantly pathogens also get trapped within the septic tank. I think that's enough said about septic tanks. But what I want to really point out about septic tanks is when they fill up, when they need to be desludged, when it reaches that point where sludge starts to flow out, you will not get a signal as a user. Do you recognize that? As a toilet user, you don't know. You're blissfully unaware how much sludge is there in your septic tank. So a septic tank does not give a signal when it needs to be maintained. And that is why we request you, implore you, have some sort of a awareness of, let us do this periodically. Let us do IEC in our communities to say, please desludge your septic tanks periodically. We don't need to do scheduling from our side. At least let's first build the awareness that people should take ownership of their septic tanks and do it periodically. What is the periodicity? Next question. So if you have built a standard septic tank, 3 years, but nobody has built standard septic tank, they are all Olympic size swimming pools that they're built. So maybe 5 years, 6 years, 7 years. Can you please do a survey in your town and find out what is the average size of septic tanks in your town? And then let us calculate what is the right desludging frequency. Otherwise, what happens? You are carrying water, not sludge. You are carrying only light sewage water. Sludge is at the bottom. If the septic tank is very big and you desludge it much sooner than it is supposed to be desludged, you will have little sludge and lot of wastewater, which is a needless thing to desludge, right? So that is why appropriate interval of desludging depends on the size of the septic tank. Okay, that's about septic tanks. That picture shows what happens, but I guess we all know about that. Then comes single pits, which Chaurasia sir is saying we should probably not encourage, or we should retrofit and get rid of them. But till we do that, we should know how to deal with them. Best part about single pits is when they fill up, you can't use the toilet. Trust me, you don't want a toilet like that. You put water, it will keep coming out. Right? Very hard. Otherwise, from the access hole, it starts leaking. So it makes a mess. Right? The mess is good because at least you know that it's full. Unlike in a septic tank. The only good thing about a single pit is it gives you a signal. I am full, I need maintenance.
Regarding dislodging of septic tank, if it is not full, like is it required to dislodge in a 5 year? It will go to school, I think.
Yes. What do we mean by a septic tank is full? A septic tank is full when sludge reaches that level. Right? Septic tank is full in 40 days. Satish explained yesterday, sir. Yeah, sir also explained yesterday. From day 1 to when the tank fills, it's only 40, 50, 60. Even if you build an Olympic-sized swimming pool, 3 months max. You do the calculation, it is very simple. Right?
My practical experience, I have constructed, I am using septic tank in my house. We don't observe it from outside. It don't get full. I have occupied my house for more than 20 years. Only after 12 years, we can know from outside that it is full. That is also due to the blockage in the shock pit. If there is no blockage in the shock pit, I don't think so. It will be full. Like you were mentioning 5 years. Is it required to do?
Yeah.
Is it mandatory? Yeah.
So this is a very important question. Please understand the question very well. Right? Sir has a so-called septic tank.
But he is staying in Azol.
Sir.
He is staying in Azol. You won't be having a Olympic size septic tank. You
I
are
understand.
having a very normal size septic tank.
No, I will be.
Sir, may I answer?
My own stock.
Then
I have my own stock.
the septic, how big is your septic tank?
It will be 8 feet into 3 feet, and the depth will be 5.
5 meters and 1 meter.
2.4 into
2 1 and 1.5. He's got a 3 cubic. Why is it not big?
Do you have a soak pit also, sir? So the supernatant is going into the soak pit?
Yeah.
Soak pit is not choking?
How many people are there at home?
8 people.
Wow.
Okay.
So then next
Sir,
we need to look into it. Yeah.
Either your soak pit is so good that whatever solids are going from your septic tank to soak pit are also getting digested. Right? That is good luck. Fantastic stuff.
Okay, let's discuss, I think, Susan, more.
Yeah,
Yeah.
good bacteria.
You have some very good bacteria in Mizoram, which are doing their job.
I think so. I think so, like almost 50% of the Aizawl people are like me only. They hardly clean. Unless it is food, they don't go for dislodging. Therefore, like I don't think so. The dislodging will occur in every 5 years for all the household. Is it this prescription is what to say a technical prescription, or is there any mandatory requirements to clean every 5 years? That's my question.
Yes. And the answer to that question, very simple answer, sir. Because the septic tank doesn't give you a signal, you don't know how much sludge is there in it. That is why we recommend, based on experience, a certain interval. The 5 years is just a recommendation. Like I said, based on the size of the septic tank, you figure out how long you should wait and then do IEC. Now, underlying assumption behind what I said is that there is no soak pit, because most of the countries are unlike nice places like Mizoram and Aizawl do not have soak pits. They have septic tanks which overflow into the stormwater drain. In your case, because you have a soak pit, you have a signaling system. If the soak pit chokes, you know that something is wrong. Then you will anyway desludge, right? So my mistake, if there is a soak pit, you will get a signal from septic tank also, because soak pit chokes. But if the soak pit chokes, the cost of doing that, fixing the soak pit, is not trivial. So, and the effort required is also not trivial. So you do not want to wait till the soak pit chokes before you empty your septic tank. In your case, sir, like I said, you have great bacteria doing the work for you, so we're good, no problem.
Just बोलेंगे या मैं एक बार यस इसमें एक चीज जो आपने पॉइंट रेज किया दैट इज वेरी इंपॉर्टेंट initially somehow let us say technical wings or technical jo organizations hain, they were not deep into it. I will say they were doing conventional this sewage management and other, and when this thing comes scheduled dislodging and other things, so even without doing proper research and where it is required based on some of the academic document and other, people went on that do dislodging. But as you rightly mentioned, scheduled dislodging need to be read as a need-based dislodging. Unless you do that, you are wasting money, and that is infeasible, let us say, proposition. That is one thing. Second, as and when need arises, there are two-way signal. One signal that comes if, let us say, septic tank is somewhat full, another, so that whatever the influent is coming, it will not be getting enough, let us say, space for settling, or many times whatever effluent is there, it may also be having some fecal matter particulates, fresh fecal matter particulates, some digested after 1 day, 2 days, that is fine. But if it is a full and let us say solid content has come up, then it will come, that will somehow create problem. If soak pit is there, that is also likely to be choked. If it goes in drain, there also it appears and give a ugly sight. Otherwise, over the time, even in drain it is flowing, that will also get digested, like all these effluents are getting. So if as a, let us say, as a very conscious हम कह सकते हैं citizen towards sanitation, if on 5 years, 6 years, if it is being done, it is good. But many cases में 10 years, 20 years, it is not being done. It is not a signal of not being very good. Only thing, it is somehow reducing pollution, what is going out of your house, septic tank and other. And I will say this is next level of sanitation. First, everybody should have this sort of, I will say, proper sanitary system like septic tank, another, that is first requirement. Need-based dislodging and another second stage. After that, periodic things, so that it also septic tank perform well and things should not go, that is a third stage. But here in this case, somehow we jump with third stage, do scheduled dislodging, create another thing, so that thing now it is settling out. Isko abhi baat karne ki zarurat nahi hai. Your point is well taken. Do not do scheduled dislodging, do need-based dislodging. I think that is even sufficient to manage at this point of time. Thank you.
Just So इसमें again now because a lot of engineers are also sitting here, I thought some engineer will rise and say कि क्यों, why this design, entire thing is there. There's a IS 2470 part 1. IS 2470 part 1 states that every person releases certain solids into the septic tank, and that after digestion is 0.00071 cubic meter per person per day will be deposited. One person deposits 0.00071 cubic meter of solids into your septic tank after digestion. Maybe once the solids get into a septic tank, volume will be high, but after digestion, this will be remaining. This is that inert matter, and this starts accumulating in the septic tank. So once the IS code says that this is your size of septic tank for one family, it has to be 1.125 cubic meter septic tank is there. That in after around 6 months becomes half full. And that's after 6 months, it was supposed to be emptied, because once the septic tank becomes half full, that means there's a short circuiting of water because niche solids have deposited. So now short circuiting will take place. So proper deposition is not taking place. So that was why it was decided that there should be periodic desludging at 6 months if the design was 1.1125 cubic meter. But because we were told our sizes are 2.5 cubic meter, so we did not want to get into that, this thing. So decision was taken that we should have a 3-year desludging cycle. Now it is now being told to us they are 10 meter cube, they are clumping size. I don't know how people afford that. And we are thinking we are a poor country, 10 cubic meter of a structure, which is, 10 cubic meter of, if it's a RCC structure, would be costing you at least 2 lakh rupees. And if it is underground, then even more. So, but if that is how it is happening, then definitely desludging will not be required for that periodicity. If you have got a 3 years, 3 cubic meters, this thing, maybe instead of 1 year, it should have been maybe 3 cubic meter. Like we said, we designed for 2.5 for 3 years. There should have been a reason for your septic tank to be cleaned after 3 years or so, because you use a standard, or you could say optimal size septic tank. Now coming to soak pit. Soak pit has got nothing to do with your desludging this thing, because sludge is deposited out here inside this. However, if short circuiting is taking place, then that means that whatever should have been deposited in the septic tank gets into the soak pit. And if that gets into soak pit and blocks its pores, then there is a transfer of backflow, and that is what would happen. But theoretically, this is how this entire exercise is there, that 0.00071 cubic meter per person per day, and that is IS code of 1972.
Yes, sir.
Thank you. The only other reason why I can think of that you might proactively want to because you tend to accumulate this scum layer at the top, and that also hardens very much. So after 15 years, when we opened septic tanks, what we have seen is you can stand on the scum layer. You need a crowbar to break it. It gets so hard that desludging becomes very difficult. So my sincere recommendation is, if you have such good system working so smoothly, at least do some monitoring once in a while, so that you don't get into this problem of having to do a huge amount of very difficult O&M later. So but otherwise your system seems to be working great. Thank you. So single pit, like I said, when it fills, it gives a signal. You go, you desludge, and then you can start using it again, right? That is basic. Again, single pits, like sir said, I know of many single pits which have been desludged only once in my lifetime. So that's like 20 years or more of filling period, right? Because soil structures are like that, water is, whatever, leaching out. However, when you talk to desludging operators, they will tell you very clearly, after about 8 or 9 years, the solids at the bottom get really hard. And slowly it becomes more and more difficult to desludge a single pit if it is, you're trying to do it very late. And then you have to pour water, you have to mix, a lot of unpleasant things have to be done. Only for that reason, to avoid the manual intervention, we are recommending 5 years, otherwise 5 to 6 years. It depends on your area. Ask the desludging operator in your area. They are the experts. Single pit में कितने साल के बाद गाढ़ा हो जाता है, कितना पानी डाल के कितना उसमें मगजमारी करना पड़ता है, पूछ लीजिए, पता चल जाएगा. And then you take a call based on that. Just 2 years before that, if you do, it will be a smooth operation without manual intervention.
But we recommend that wherever it is available, we are ready to give funding. States are also giving funding. Please identify and encourage them to get it converted. This is what we recommend.
Sir, since dislodging is a capital investment issue for anybody who is having the septic tank. So why can't we go for analyzing the sludge characteristics before we come to the conclusion that it really requires to be emptied and treated?
Sir, desludging costs, the truck comes and it sucks out.
Yeah.
That is desludging, right?
Yeah.
That costs about 1,000, between 700 to 3,000, 3,500 in Shimla, because trucks go from Chandigarh, far away places.
Well, it involves cost.
Yeah, so it's a cost.
Yeah.
Now it might cost you that much to analyze the characteristics of the sludge in a laboratory. So it might be simpler just to get it desludged. Because the other thing is that you also have to use the toilet. If it is full, especially in a single pit, you don't have the luxury of doing all those things. It's an emergency. It's full.
I mean, we could obviate the confusion that arises whether it is the time ripe to go for dislodging or not.
When it is full, you don't have a choice, right?
That's
okay. Sure. No slides to click on, so we are good.
What happened?
Yeah. So those are the two major types of on-site systems. But there is a third type, may not be very prevalent. It's called a holding tank. It's just a tank in which sewage fills up. These are now coming into prevalence in small apartments. You have, stilts and 3 floors, or, smaller apartments. They don't have the porosity. There's not enough, because too much density is more. The water is not going. Septic tank overflow. They have to build a very big septic tank. It is expensive, and cities are not allowing the overflow outside because it's a lot of water coming out. So they are doing what we call as holding tanks. Can you? Yeah. Now, holding tanks have to be desludged very frequently. Maybe once a week, once a month, depending on the size. They just hold water. So we have seen this in many places. This is a new emerging thing, right? That the waste contained in a holding tank is not necessarily fecal sludge, because it is fresh wastewater, both in terms of its strength as well as its characteristics. It resembles sewage much more than fecal sludge. But because it is carried on wheels, carried in a truck, we have to deal with it as part of the larger ecosystem of fecal sludge. Keep that in mind. The other thing that I would like to point out is small STPs. So if you have a general hospital in a small town, the institutions and schools and stuff, they have small STPs. If they do, there also sludge comes and they don't know what to do with it most of the time, like Rajesh pointed out. That is also probably a candidate for carrying in trucks and bringing to a place where you need to deal with it, right? So that is the landscape of where the waste is coming from. Now moving to how the waste is collected. This is a typical process. You call, a truck comes, right? Then starts a lot of different difficult things happen. You have to first identify where your septic tank is. Sometimes it's not very obvious where it is. It's under the road, under the house. So you find it, right? You can see there, it's next to the door. So you have to break up that place, put a pipe inside, and then what happens is once you start sucking it out, the pipe starts choking. Because we have I have seen a sari come out of a septic tank. So, but sanitary pads, diapers, many other things have emerged magically out of septic tanks. So this choking problem is there. Now, what is the solution? Lot of IEC. We need to make people aware that toilet is not waste basket. No, so don't put things in your toilet which you would rightly put in a waste basket. That is something I implore you to do. because it is inhuman. When a pipe chokes, to clean it is, next to manual scavenging only, right? Now, physical access. Many times we go there for desludging. Like I said, we don't know what we are going to face. A lot of these tanks, that tank doesn't have an access hole. So you have to break open the slab. It's a septic tank. It's a septic tank, but there's no access hole. So you have to break open the slab, and that is not cost effective at all, both for the family and for the person doing it. On the right side, on the right side, if you see, that toilet is on top of the containment unit. So there is no access at all. The only way you can reach the containment unit is through the P-trap of the toilet. So you have to break many things to be able to desludge. So these are issues. Again, in a town, we did this kind of analysis. So you see 39% of septic tanks, in this case, single pits, were behind the house. So you have to take the pipe through the house. There is no way to go around. Through the house, you have to take the pipe, which is a unnecessary public health hazard for doing something you're trying to do for a public health cause, right? So the location of these pits, there is a lot of IEC that needs to happen around where to build your toilet containment units. And this IEC is not simply just about telling people, it's also about including in your city building construction permit plans in that space. A lot needs to be done to make sure that somebody brings a plan to you for approval for a new house. You tell them, why is your septic tank here? How will you get it cleaned, etc., etc. And redo the plan in such a way that these sort of things are taken care of. So a whole regulatory package needs to be built around on-site system units, on-site sanitation units, sorry. Yeah. So a few costs, typical costs are around 1,000-1,200. We've already covered this. Now for poor households, this can be a burden. So one of the things that we recommend you to do is to regulate tariffs for desludging. So in your town, you can say for those who can afford it is this much, for those who cannot afford it is slightly less. So those sort of things we encourage. Now getting into actual desludging, that's the equipment. I will not go into this. I'm sure all of you have seen these kind of trucks running around on the streets. But these things also have specifications. And these specifications have to be respected. Please, when you are doing your tenders and procurement, there is a detailed set of specifications available here on our website also in a QA manual. So please look these up and you will get some information from that. Now, how do you know how much fecal sludge is generated? Because this is the key question in terms of sizing and how you do that. There are three methods. You can take a CPHO formula, sir, just told the formula, Rohit sir, 0.0007 something. I have written a different number here, but you can check the number. Multiplied with population, you get a number. That is the most basic thumb rule method. The second method is, like I said, do a survey, find out the average size or the sizes prevalent, and then you can multiply with that how much volume comes. That's also a simple method. The third method I found is the most effective. Go to the desludging operators, interview them. How many loads do you do in a day? How many you do in a month? When do you do peak? When is business booming? When is business flat? You ask them a number of questions. The answer they give gives you a very good sense of what is the actual generation rate, actual collection rate, right? Between the three methods, if one method is not superior to the other, do all three methods or at least two methods and make sure your number is tallying, right? If you do that, you get a reasonably good number. That is for estimation of trucks. I am not going to go into this. It is a very basic mathematical calculation. It is quite straightforward. So that brings us back to what do we do with the waste? We know what kind of OSS there is, what are the challenges there are. Desludging, trucks. Now comes back to the problem that we started with. After you collected, where do you throw it? What do you do? Typically what happens is farmers like this waste. So they say, come to my farm and put it only in the summer. not in the monsoon period. Summer period, because water is less, they'll say, come and put it. But then the issue with that is, of course, the farmers are exposed to pathogen, which they don't realize. Also, within 15 days of putting the waste there, you will see weeds growing like anything. So you have to again do de-weeding. So a lot of issues are there. And anyway, it's not a good public health practice. Other thing is putting in the water body. All of those things are the simplest method, like Rajesh said earlier, and Chaurasia also said, directly dispose into a STP. This is from Chennai. Many places in Tamil Nadu, our partners are also working there, have adopted this method. If you have an STP, come there and dispose, right? Just directly dispose the sludge there. Near Delhi, if you want to see, Ghaziabad is doing this very, very nicely. They have a very good system for bringing sludge into the STPs and doing that. Many STPs in UP are doing this. So you can learn from UP state. There are about 20, 30 STPs which are doing this, big cities, right? However, when it comes to Swachh Bharat Mission, because our towns will be below the 1 lakh population, our STPs which are upcoming will be small, right? Because they are small, if you add concentrated fecal sludge into them directly, it is not a good thing. So, and also because you are planning for these STPs now, they are not already built. It's a good thing to plan for both of these together. If you are going to do co-treatment in your new STPs that are coming up in smaller towns, please plan ahead of time. You will save a lot of cost. You will actually get an FSTP free if you plan the STP properly. Almost free. I should say almost free. Yeah. There are a couple of things I will talk about that. So again, direct discharge of fecal sludge into the STP. But in Puri, they do solid liquid separation and then they put the liquid into the STP. So those are the two methods. You can have an STP. If you have an existing STP, you can go there and directly put the fecal sludge into the STP and let it happen. That is one method. It is called direct addition. The second method is with pre-treatment. What is happening in Puri? You don't directly put the fecal sludge into the STP. You hold it, separate the solid and the liquid, only put the liquid into the STP because that liquid is actually like wastewater. It can
under SBM1, we have already constructed FSTP.
okay.
So, population less than 1,000.
We'll come to those.
So there is a FSTP in every.
Which state are you from, sir? Which state, sir?
Madhya Pradesh.
Madhya Pradesh, yes. So we'll in
and we have almost 160 FSTPs ranging from 3 to 10 KLDs.
Okay, sure.
So you are talking about the city population more than 1 lakh. So in SBM2, since we are working on population less than 1 lakh, so let us.
Sure. We will also talk about FSTPs in the coming slides, right? What I'm saying is, if you have an existing STP, the simplest thing to do is to make sure that FS goes there. That is a no-brainer because an existing STP is already ready to accept fecal sludge with certain minor changes that can be made, right? What those changes are, etc., will not go into today. It's too detailed. The second practice is if your existing STP doesn't have sufficient capacity to handle all the fecal sludge, you can separate solid and liquid through a simple process, put the liquid into the STP. That will also solve the problem. So before you build a new FSTP, you utilize your existing STP capacity fully. That is the first message when it comes to treatment, right?
But sir, if we are doing first process, like putting fecal sludge directly into the STP, you need to have an equalization time. Yes. Because you'll be loading BOD.
So yes, there are a lot of concentration, high concentration, oxygen demand increases. There are many effects of directly putting, right? you have to take care of all of those. There is a very detailed manual on co-treatment, that we will share with you, that will help you to understand when you should do directly putting, when it is safe, when it is, and what precautions are to be taken, and when it is not safe to do that, and you should actually separate the solid and liquid and put only the liquid. Yeah, is that fair? We will share a booklet with you, a full detailed one, so that
few of the STPs are without equalization. Might be 25% of our STP are.
Why would it make that without any?
Earlier, this was built without equalization tank also. Equalization tank was not taken in the design of the STP. Later on, when we are upgrading our STPs, we are putting
Those STPs were designed for peak.
yeah, those were designed for peak.
Sir, there may be a pump station before, na?
Yeah, there's
the pump station is there. From there it is. Inflow is defined by the pump. The main pumping station, from there it is sucked. That itself acts as equalization tank. It is not a gravity flow directly. It's a levelized flow from the pump.
Mr. Rajesh, I will just give a clarification.
Yeah, please, sir, please.
So what we are doing in Puri? No, Kal,
Yeah, I think please.
yesterday चौरासिया जी एक slide दिखा रहे थे पुरी का कोड ट्रीटमेंट के बारे में. So what we are doing in Puri, so that will clarify all these issues. So what we have realized, all your COD that you measure, it is mostly coming from the sludge only, and those sludge are already digested. There is no need to further mineralize them. Putting in the anaerobic reactor, then usko फिर mineralize करो, फिर treat करो. There is no need because already it has been digested. So what we did in our normal FSTPs, we have a sedimentation tank. We remove the sludge. The sludge goes to the drying bed. Liquid goes to the DWARS treatment system. But in STP, that Puri STP you saw, so we have the same settling tank. So we remove the sludge. So there is no need to further treat in a pond or a ASP process because it will not be digested. Right? They are all dead cells. So remove them. So all your COD is vanished. 99% of COD that you want to treat is gone. So that remaining 1% that effluent or the liquid effluent can be fed into the STP. We are feeding into it. The beauty of Puri STP is that we had all the system. We had the leachate, we had the sludge drying bed, the sump was there, the sludge drying bed was there as part of STP, and the pumping arrangement was there. Only we built the ramp where the truck has to go and the settling tank. So that is very cheap. And that is how it was linked to the STP. So there is no need of any equalization tank. There is no need of anything. See that we built the settling tank. So it is a sedimentation. We remove the sludge and the effluent is going to the leachate sump. It was there as part of the sludge drying bed leachate sump. Yes. That is a 15 MLT aerated lagoon process. Almost. Yes. So it is क्या है? It is a उसका detention है 4 days. So 4 days detention, then it hardly matters. So all those peaks, diurnal variation is taken care of. Of course, if you have a variation of, see, if you talk of MLD, this scaled is nothing. Right? If you get this amount, it will be nothing.
So maybe Haryana has also got these old aeration lagoons which are without equalization tank, but the modern plants are all with the equalization. Okay. But like he said, in the older design, you don't have to bother for this variation. You can just dump it.
Sir, I think let's have more closer this discussion later, because in the interest of time, already we are 1 hour behind schedule. Because please.
Okay. So thank you for the example, sir. That's exactly what I was saying. What Mohapatra sir just said. If you have an existing STP, the minor modification, very simple. In the case where you are doing direct addition, if you see this simple graph, depending on how much excess capacity you have available on the vertical side, your ability to put fecal sludge, is that much in percentage. So at the max, you are seeing 3.6 in a certain 3.6% in a certain technology. I don't want to go too deep into this in the interest of time. But the point is your ability to add fecal sludge directly to an STP is in the 3% range, 1 to 3% range. Just keep that in mind. Beyond that, if you have to add 1 to 3% of remaining capacity, right? Unutilized capacity of your STP. If you want to add more than that, then you are better off following this process. We're not saying, yeah, same thing.
Percent of a MLD thing means, once you, because the fecal septage is coming in KLDs, huge quantity of fecal septage can be added in the STP. Even in case you're, I would just, venture out to say that if you got a 30% spare capacity in your STP, and STPs can take on the entire load of the entire fecal septage of your whatever is the remaining portion, even if your STP is only catering for 50% as that was being planned for our. What I'm exactly trying to say is under the SBM 2.0, हाँ, क्या चीज का?
हाँ, वो नहीं आएगा. Yes.
मतलब it is just impossible until unless you are importing from some other city.
Yes, yes.
Until unless you are importing from some other city, the situation will never come. So never be afraid of putting your fecal septage in their STP. There, that, मतलब I can tell you from CPHO का जो भी चोरसे सब.
Yes, yes. एक चीज जो चीफ साहब ने बोला उसको हम लोग एक क्लियर ये करना चाहते हैं. जो सीवेज होता है उसमें नॉर्मल सॉलिड कंटेस्ट जो हुआ है 1% के आसपास, 1.25% के करीब होता है. जो कैरेक्टरिस्टिक सेप्टिक टैंक से लिया गया सेप्टेज है उसमें 3 से 4%, अधिकतम 5% होता है. हम जब सीवेज ले रहे हैं तो वो एमएलडी में होता है, मतलब केएलडी के 1000 ज्यादा. उसमें इनको डायरेक्ट भी कहीं भी 1 टैंकर 2 टैंकर डालें, एब्सोल्युटली कोई चिंता की बात नहीं है. गड़बड़ी कहाँ होता है कि जैसे सिंगल पिट से लेके एक्सकेवेट करके वेरी थिक उसको भी ले जाके डाल दिया, किसी का कोई मलबा है वो भी लाके डाल दिया. ऐसी चीजों में वी हैव टू डू. दूसरी चीज कैपेसिटी के बारे में जो ये जो चार्ट दिया है ये एक अलग कंटेक्स्ट में डिजाइन है. इससे बहुत ज्यादा सिंपल तरीके से हम लोग अभी लेकर के आए हैं. जैसे महापात्रा जी ने बोला कितना भी उनको आने दीजिए फिकल स्लज, 1 ट्रक 2 ट्रक 20 ट्रक डजंट मैटर. जो आपका सिंपल स्लज ड्राइंग बेड है एक, उसके ऊपर आप उसको लेकर के डालिए. सॉलिड वहीं पे रिटेन होगा, वो जल्दी भरने वाला नहीं है क्योंकि 3% 5% इट विल टेक मंथ्स टू फिल. जो लिक्विड है छोटा मोटा हो तो इट कैन गो इन सोक पिट और प्लांटेड ग्रेवल फिल्टर. उस प्लांट में जब ज्यादा है उसको पंप करके इनलेट में डालिए. इवन हम बता रहे हैं 1000 मतलब केएलडी करने के लिए आपको कम से कम 3 के हिसाब से देखें तो 300 ट्रक चाहिए. इतना तक को भी वो ले लेगा, मतलब इतनी कैपेसिटी है. तो कैपेसिटी वाइज इनमें कहीं कुछ सोचने की भी जरूरत नहीं है. डायरेक्ट भी आप डाल सकते हैं जब सोर्स रिलायबल हो, नहीं तो पहले कहीं पे एक स्लज ड्राइंग बेड में डाल के लिक्विड ज्यादा हो तो डालिए, नहीं हो तो सोक पिट में करके फिनिश कर दीजिए. इट इज सो सिंपल.
Now, that was about existing STPs or the new STPs that you are proposing to build, right? Now, in the new STPs, like sir said, if you want to do solid liquid separation, that's the simple method. That's a drying bed. That's how it works. You put sludge on top. Sludge, the solids remain, water percolates and comes out from a pipe at the bottom, right? There is a variation of that which is called an unplanted drying bed, which needs to be evacuated once in 15 days, 20 days, depending on the design. So this is that it works the same way, except its retention capacity is less. So you need to remove the solids from the top of the sludge in every 15, 20 days, depending on the drying period, right? I'm going a little fast, sorry, but all of this is available in literature, so it's not very complex. Now, there is another way of separating solids and liquids. Your formal STPs tend to have this kind of systems. They rely on what you call belt press or those sorts of devices, right? We recommend that for fecal sludge. This is where the recommendation is coming for new STPs also. If it's a slightly larger STP in MLD's capacity, please adopt a volute press because this will serve for both sewage sludge as well as fecal sludge. And it will do the solid liquid separation very effectively at very low energy. Try and adopt this for your new STPs. This is the integration that we are seeking from you in your specifications when you go for new STPs. If you can do it with drying beds, nothing like it, because there is no energy cost for drying beds, right? I'm not saying one over the other. I'm just giving you options. Now, oh, sorry. Yeah. So this is the thing that I wanted to discuss. You see the one at the top, that is co-treatment. Fecal sludge is coming in. There is something happening, solid liquid separation. Solids go to drying, dewatering, etc. And the liquid goes to a existing STP, right? That is co-treatment in the most simplest form. The drying and dewatering, if it is already part of the STP, there's even nothing to do. That is what Mohapatra sir just described, right? At the bottom is a proper FSTP, what you call a standalone FSTP. Fecal sludge is coming, you do solid liquid separation, solid goes to drying and dewatering. Again, the same type of systems that we are talking about. The liquid goes to a miniature STP. It's a small STP which is part of the FSTP. So bottom line is, every FSTP has an STP. Every STP already has an FSTP. These are just words used to describe systems for us to identify them. In effect, the processes are similar and the modules, the hardware is also reasonably similar. There is no need to confuse these things, right? The names came about because different people started working in the systems. Now, a typical FSTP costs about 250 rupees to 300 rupees per capita, and the O&M cost is also reasonable, right? If you have to do a standalone FSTP, those are the things. Why would you do a standalone FSTP, right? You take care of everything in an existing STP. There are only exceptional circumstances where you might need a standalone FSTP, unless you have already done. Those are anyway completed cases. Now, when you have a lot of single pits and the only thing that is flowing through your open drain is a simple, non-black water. Let's not again create a new word. Then there is very little flow, especially in places in Karnataka. The whole state of Karnataka more or less is like that. We have seen in many places the flow is very little. So you can take care of it in a very simple way. And that is why FSTPs make sense. That is one. Second, if you are doing nature-based systems, simple nature-based systems, wherever your BODs are very low in your open drains, nature-based systems, constructed wetlands, directly putting sludge into them is not possible. In those circumstances, you would probably want to create at least a solid liquid separation device, either at that location or an FSTP in a separate location. So there are circumstances where you might have to create FSTPs. Be aware of that. As a default practice, try to do it in an existing STP or a new upcoming STP that you are creating, right? Now, what happens to the two things that come out? Biosolids come out and treated water comes out. For biosolids, unfortunately, we don't have any, standards in India, and that is one thing we would like to flag, that we should have some sort of standards in India for biosolids so that reuse can be promoted, right? Lot of FSTPs are getting backed up with this solids material and evacuation is required. If you have standards, then they will be used. So that is, right now, WHO standards, US EPA standards, these are very stringent, difficult to meet. We need to evolve our own understanding of standards. These are the components of FSM that we have covered. Please take a minute to look through this. You need behavior change. That's what I said right up top. Good behaviors about using your toilets properly, emptying your OSS properly. Regulatory functions we've discussed, licensing of operators, giving tariff structures so that poor people can also afford, right? Do not dispose in uncontrolled manner. Very basic regulation required. So like that, there is a whole set of things that need to be done. Fecal sludge management is not infrastructure, just like sewerage management. It is a service. A city is responsible to provide sanitation as a service to its citizens, not build infrastructure. And to make it a service, you need to do all the other things that come with the hardware. And a lot of these things can be done without having to wait for the infrastructure to come up in the case of fecal sludge. That is something you need to keep in mind. Yesterday, Rohit sir was talking about Safai Mitra Suraksha. It's a concept which can be very well applied to fecal sludge management. Please take all of the things that he discussed yesterday and apply it in your town from tomorrow. This is something in used water management you can start from tomorrow and build momentum around what you're doing, right? Now, I want to sign off with this. Again, very important. It's a little dated map, but a very, very critical map for a country like India. The percentage of organic carbon in our soils is depleting. This organic carbon in the soil helps to retain water, and that helps prevent drought. It improves the ability of the soil to yield produce. This is very, very important. This organic carbon comes from only 3 sources. One is your plant-based source, means your compost. Second is animal excreta, and third is human excreta. All these organic sources have to go back to soil. If that happens, our soils will remain healthy. Our country's food security is assured. It's a very simple concept. Don't think of organic waste streams in separate streams. All organic waste has the same benefits. Organic carbon, nitrogen, phosphorus, etc., all needs to go back to soil. That is why, and if I may say so, fecal sludge is the purest form of organic shit you will get. So that is that. And then, of course, the water security, I don't need to speak about this, you know very well. Although recent news from the Ministry of Water Resources is more encouraging in terms of groundwater levels, it still remains a problem. Thank you so very much.
I think we're already delayed for the tea actually. Let's quickly go and grab the tea and you can come back here actually. Yeah, please. Get those papers.
Shall we finish off this and then go for tea?
So
Just tell me. Yeah. Break karega to yes, 10 minutes.
So before we break for tea, I just have 2 announcements.
No, my
When you
concern is
step
people will leave.
outside, sir, one
Some people
second,
might
sir.
leave.
Yeah.
No, no, nobody should take this. Where are these? No. I think you're not, so I agree with you.
Yes, if somebody need to use washroom or even they want to take tea, they can take and come here, because one session we are getting late and he has to go. So we will require half an hour. After that, we will do regular this tea break. But if anybody in urgency, they can do. But please bear with us for 15, 20, 30 minutes because of engagement, right? Okay.
Finish it off.
I think Praveen left. So I think we will try to serve you the tea here itself. No? 11:30 is already done now. So 12 o'clock. Okay. So we will delay the lunch maybe a little bit then later so that, yeah. Okay. So we will start with this. Yeah.
Yeah. Am I audible with this mic? Can you hear me?
Sir, maybe you can put it somewhere.
Am I audible? Is this better? Hello? Where is that? No, I think it's Hello?
Yes,
Am I audible? Is it?
Yes.
Ritesh? Okay. Okay, very good morning to all of you. You've been seeing Rajesh and Sashanka for the last couple of days. I'm a new face, so let me quickly introduce myself. My name is Ganapati. I used to head CDD Society till recently, but now I'm an advisor to CDD Society for the last 1.5 years. I'm independent consultant. I also work with a lot of CSR foundations, the World Bank, and so on. That's a brief introduction. Before I start, I really want to compliment
CPHEO and the Ministry of Urban Affairs for an excellent SBM 2.0 policy. And for the first time, I was very excited to read it because a whole lot of good vision and good approach is embedded in the policy, particularly this whole approach of trying to reach everyone, a citywide inclusive sanitation through a multi-solution kind of framework. And Rajesh has explained that very well in the morning, the mixed solutions approach or the multi-solution approach, that one size doesn't fit all. So you need various kinds of systems to sort of meet all the requirements of the town. And in that, of course, interception and diversion of drains, which I'm going to talk about, is an important component. One slight deviation, because there was a lot of discussion on this, I just wanted to add my personal point of view there. There was a talk about centralized and decentralized and how you distinguish, and Bangalore could claim that it has a centralized as well as a decentralized system and so on. I just thought I'll give a personal point of view here. I look at decentralized systems as those that does not require any kind of pumping to convey the waste. So anytime it's purely gravity based, which is usually possible only in small kind of areas. So that can be termed decentralized, and wherever you involve a lot of pumping stations and others, they are more like centralized systems. Another way to look at it, which is how I personally look at it, any kind of sub 1 MLD scale, I call it decentralized, and above 1 MLD is typically more like a centralized scheme. Anyway, that's just an aside from previous discussions. Let me move on to this presentation straight away. Yeah. So in my view, and I think all of you will agree with me, that even though it's not desirable that used water is flowing in the stormwater drains were not originally conceived or designed to actually take wastewater. In our country, because of our specific context, used water.
This goes front.
Yeah. No, the pointer is which one? Okay. Used water will continue to flow in our drains. For how long, we don't know, but we are hoping that with all the Swachh Bharat as well as Amrit missions being executed, less and less of used water will flow in our stormwater drains. But we cannot rule out that for the foreseeable future, it will continue to flow in our drains. Clearly, there is a public health risk, vector breeding being the most obvious kind of visual thing, but also some kind of water contamination could also happen. Surface water contamination, which is an environmental risk and often can translate back into a public health risk. And then the last aspect is it just affects the overall cleanliness of the town, the look, the feel, the smell, and all of that contributes to what Swachhata can be called as. So it's pretty important that we continue to, so the used water in the drains need to be managed. It's a reality, however we say, how much we might believe that it should not be there. Some of this has been covered, but I'll just go through it fast. You have, when you talk of used water flow in the drains, it's pretty important to understand two things: quality of used water flow in the drains and quantity of used water flow in the drains, which I represent by capital Q for quality and small q for quantity. And when you talk of quality, basically, it all depends on what's the composition that is flowing in the drain. In the first case, it's a low strength because black water is not involved, and it's only gray water in the form of bathing water or kitchen water or wash water, laundry water, and stuff like that flows finally directly into the drains in many cases. In case 2, there could be some kind of septic tank overflow, which is put into the drain, which we talked about. In case 3, there is no septic tank, there's nothing, and this is not common. It is usually there in only informal settlements, slum settlements, where the toilets themselves are located sometimes right above the drains, or the pipes are directly connected from the toilet to the drains with not even a holding facility or a containment facility. And we do see those kind of things when houses are located on the sides of the drain. The pipes are directly let into the drain. And that's when the water flowing in the drain will almost take the character of sewage and will have the same BOD and other characteristics of sewage. So based on that, you can say low strength, medium strength, high strength wastewater can flow in your drains. And unless you do the testing of water in your drains, you will not know exactly what it is. But most cases would be low strength or moderate strength. The high strength cases are not very common. And in my view, how you manage used water in our drains will depend on both the quality and the quantity of water that is actually flowing in the drain in the dry season. Remember, drains will carry your, in the dry season, wastewater flows. In the wet season, which is the rainy season or the monsoon season, will carry both wastewater and stormwater. So when given that the management strategy would vary depending on the quantity and quality, what else are the key drivers of the overall management approach? And let's say we need to have an objective for why we are managing this. Let's say the major objective is to mitigate pollution in the terminating water body, which could be a lake or a stream or a river, and also possibly facilitate some kind of local reuse. This drain water can be tapped and possibly reused in some way. So these could be the objectives of why we are treating this used water in drains. And I already highlighted what are the key drivers. One is the quality, the other is quantity of used water that is flowing in the drains. The nature of the drain is also an important consideration. You could have, let's say, overall size of the drain itself, the cross section of the drain, the shape of the drain, whether it's lined, whether it's unlined, whether it's covered, whether it's uncovered, what's the right of way of the drain. All of those things would matter in how you think about managing it. Then the nature of wet season flows, which is in the during monsoons, what kind of water, how much water comes in this drain would also matter, because you cannot completely ignore that while designing your interception and diversion system. Then the other thing is the overall levels, the slopes, the overall hydraulic characteristics of the drain, which also to a certain degree the town and catchment hydrology, in terms of quantum of monsoon water that's generated and so on, which would have been the factors that would have gone into the design of the drain itself. But we need to understand the hydraulics quite well before looking at the kind of interception system that we design. Then the downstream characteristics, saying where does this drain go and join, what is the level of pollution that's added to it downstream, where it's terminated and so on. All that would influence how we think about the management strategy. So the summary point here is, given that there are so many factors, the management of used water drains is not something that we can try to standardize and say, here are 2 ways to do it or 3 ways to do it. It is quite contextual from whatever experience I have had in this field. Every site, every drain has to be analyzed for its uniqueness or peculiarity and its context. And then we need to come up with the overall management approach. Then we have additional challenges to consider. There is solid waste. This is one of the biggest issues in management of used water in drains. And this is very peculiar to India. And in my view, liquid waste management is 50% solid waste management. If you can get solid waste out of liquid waste, then liquid waste can, by and large, to a great extent, manage itself. And we just need to aid that process. It's because of solid waste that we have a larger problem. But as we solve the solid waste problem in the country, it's likely that our liquid waste problem will also automatically get solved partially. But when you talk of designing systems today, handling solid waste is the topmost issue to figure out in the drains, especially in the I&D of drains. Then you have industrial effluents also sometimes coming that can affect the kind of treatment process you'll have to think about and so on. Encroachments, silt and weed growth, and all of this is also happening. These are just additional factors we need to keep in mind. 2 broad approaches. One is what might call inline treatment, which is people try to treat it in the right of way of the drain itself, which is along the drain. And the other is intercept and divert, which is what we are talking about more. And today we'll focus more on intercept and divert. And it is possible to conceive inline kind of treatment systems when you have wide drains, because then the wide drains are designed to take high monsoon flow, but during the dry season, only a portion of the drain is utilized. So you may have normal areas left which are unutilized in the drain itself. And because of that, you may want to use that real estate, because you don't have alternate areas, to try and conceive some kind of a engineered kind of simple inline treatment system. But in my view, it is, I've just put a number there, just out of experience, that when your drains are wider than 6 meters and carrying very low strength wastewater, possibly inline treatment can be thought of, but more often than not in an Indian context, intercept and divert is a more common scenario, because our drains are not wide, they are narrow, our dry season flows are not small, and our monsoon season flows are quite high. Now, all of this makes interception and diversion as the more common phenomenon that you will find. And when you say intercept and divert, again, there are 2 possibilities. You can intercept and divert to just an abutting location or a nearby site, or you can intercept and divert and pump it far away and make that also some kind of a centralized kind of arrangement where multiple drains are intercepted, brought to the same STP and so on. But I am more in favor of a decentralized I&D scheme where you treat and either you locally reuse for some purpose or the other, or put it back into the drain, and it sort of augments the environment flow, but in a more cleaner way. You would have removed the solid waste, the silt, all the sludge and all of that, and put more clean water back into the drain or directly into the water body. So we'll talk a little more about the intercept and divert kind of schemes. I mean, these are just some additional pictures just showing. So when you have a wide drain, you could think about inline treatment, but inline treatment, in my view, practically happens on its own. You do nothing, you will still find the kind of plants that normally will naturally grow and naturally start treating it. And so by and large, there's a natural inline treatment that emerges as a ecosystem in itself. Whereas in intercept and divert, you need to really do a little more of engineering. And the diversion structure becomes the most important part of the design. And therefore, we need to look at it more seriously. Tomorrow, you'll be visiting a site, you'll get some idea on that. So key design considerations. I think, as I said, screening of solid waste is the most important aspect of interception and diversion schemes. It is the most difficult thing to design, the most difficult thing to plan, and the ongoing O&M of that is going to be a pretty critical aspect of the system design. Then finding land for the interception and diversion site near the drain generally will be possible, but depending on the size and scale of the plant you want to set up, that much area of land you will have to locate near the water body or the drain. And then you will have to figure out whether the site is above the drain, in which case, how will you lift that water to go to the site? There may be a little bit of pumping needed for that, which is not as part of the process, but just to lift the water if the STP site is at a higher elevation than your interception point. Whereas the more logical thing to explore would be if you can have the site downstream, which is at a lower level, so you intercept upstream and then transport it by gravity downstream, and then you will not probably use energy. So that's the other consideration in design: topography of the site, the location of the STP site, and so on. Then the I&D structure should be capable of withstanding wet season flows, because it's the same channel. So when you divert, your structure should be such that it not only screens solid waste, but it should also let monsoon water flow. And the less, let's say, the more robust this system, the less maintenance it will require, the less frequent breakdowns you will have, and so on. So designing this whole diversion structure, which is capable of handling the wet season flow, becomes an important part of the design. You can see some pictures there where this is, the bottom one is in Rajasthan, in a place called Karoli. It is not yet built, but we designed a system, CDD, and that was a river Bhadravati. So the town was all emptying into Bhadravati. So multiple points were tapped. Multiple inlet into the river was tapped and then transported to a central place in a length of about half a kilometer. And then it was being pumped to a centralized location. So the I&D structure capable of withstanding wet season flows, and the output that you want to achieve, the quality target, will determine the kind of treatment process. So that depends really on the regulation in terms of what your local regulations say about disposal post-treatment. Or if you're going to reuse it, then whatever is the reuse application you're talking about, those standards or those requirements will determine the output quality, which will in turn determine the treatment process. So the input quality of the wastewater and the output quality you require will essentially determine the nature of treatment process. And then finally, I think when you talk of treatment processes, I think one needs to try and imagine as much as possible a very robust, cost-effective, simple and easy to operate kind of treatment process. I'm not going to talk much about treatment process, because once you intercept and divert and you're able to convey it safely to an STP, then the rest of it is like a typical STP treatment process. It will vary because this might be low strength, medium strength wastewater and not very high strength wastewater. So you can simplify the STP treatment process in order to accommodate a drain flow, which is normally not very high BOD. And because it's already flowing in the drain for about, let's say, typically at least a few hours or a day, then it would already got treated a bit in the form of some settlement, self-cleansing and all that would have happened. So usually you don't get very high strength wastewater in the drains.
This is a project in, so I've just said what I want to say. I'm just going to show you some examples to close my conversation because it was a 20-minute thing, so I didn't get into too much detail. So this is a 8 lakes project in Coimbatore in which CDD worked in 2017 to 19, and now various things are getting built. So this is an interception diversion system that you can see, and then somewhere about few hundred meters, maybe 300 to 400 meters, you have the treatment plant, and then you have a large lake. And so after intercepting, diverting, and it gets treated through wetlands, it's being released into the lake. And there are few lakes in which this is already built and the systems have just started operating. This was part of the Coimbatore Smart Cities project, where out of the 800 crore budget, nearly 500 crores was allocated for rejuvenating 8 lakes, 9 lakes actually. Later on, one more lake was added, and 9 lakes in Coimbatore, of which about 20% of that budget is being used for wastewater and water management aspects. The remaining large sum of money is actually being used for placemaking, which is the bigger component of the project. But the treatment of water, both in terms of dry season flows and managing the floods and wet season flows, forms the remaining component of this 8 lakes project. Then we have, yeah, this is not built, it's only a plan, but this was the river Bhadravati that I was talking about. The town is on the side of the river. There were about 6 or 7 inlets into the river directly. So we created a system, and a lot of hydraulic analysis was needed because different outfalls were coming at different levels. And we had to strike a balance, figure out which outfalls to collect. And then finally, all the outfalls were tapped and collected such that wet season flows will go directly into the river, but dry season flow will get intercepted, diverted to some kind of a point where from where it is pumped. Because in this case, the river was at a very low level. The STP site was at a higher level. So you have to bring it to a point from where you'll pump it into a STP. The STP could be a nature-based kind of STP, or it could be a decentralized, typical DWATS kind of system, or it could be a mechanized aerobic kind of system. It doesn't matter. It all depends on the considerations which you will be talking about in the next session, I think. This is a project I had the good fortune to be involved, and I sort of headed this project. It was implemented through, it was CSR funding, completed in 2019, successfully operating for about 3.5 years now. And tomorrow, I think this visit is planned because it's in Bangalore. And this is the interception structure that we built. And I mean, I don't, again, not talking too much about this project, but if you have questions, we can take it at that time. This is the core screen, the initial screening that takes place. And then down that, there is some kind of a silt and grid chamber from which there is a box screen, which is through which a gated arrangement is there to control the quantity of water that's let into the STP. And then it goes into, so this is the kind of solid waste accumulation that happens. I don't have a picture of monsoon flows, but the monsoon flows would typically overflow and go straight into the entry point. The culvert that you see there is the entrance to the lake. This is the diversion channel, which is 2-stage screening, the finer screens. And then it goes into a, so this is a covered channel that you're seeing. Then it goes into a sedimentation tank, where some more settling happens, low retention sedimentation tank. Then it goes into an equalization tank that side at the bottom, and it is pumped because again, the lake into which the water was to be let out is at a higher level than the inlet. The full tank level of the lake was little higher than the inlet. So water had to be pumped. So we thought we'll pump it before it enters the DWATS treatment. So this is a 1 million liters per day scheme, which taps from one inlet and pumps into the lake. And this is the DWATS plant that has been built there. And through gabions and constructed wetlands, we let the water into the lake, which is also just on the other side of the bund. And this was later on replaced with more like a vertical filter followed by a constructed wetland. You'll see both there actually, because the floating wetlands were difficult to maintain and the government didn't want that to be directly in the lake. So we have a sedimentation pond in which we have now built the revised tertiary. So this is almost like a tertiary treatment stage after which it enters the lake. And it's a very simple arrangement where it's quite robust. We have almost zero maintenance personnel there. During COVID, for example, with just a camera, we were watching and observing everything. There's nobody at site. And once in a week or so, somebody should clean the solid waste from the screens. And that's it. We have not desludged it at all. There was some desludging we had to do in the initial stages because to get while the plant was becoming operational. But after that, there has not been any requirement. So this is practically running on its own without too much supervision. So that's the snapshot of Mahadevpura. Sorry. So I think this was the biggest innovation I consider in this project was the design of the diversion structure itself, taking into account all the hydraulics of from where the water is coming, and we had to do it in an economical way. So we actually used an earthen channel with just pitching, stone pitching, and so on. And then we had to do profile correction for the incoming thing, so you get a little drop and so on and so forth. So, and we had to do all this work while water was flowing in the drain, while there was already flow. So the whole construction process also involved quite a bit of planning and challenge. And it's been working well. Tomorrow you'll see it and you'll get a good idea. Flow, so this treatment plant is 1 MLD, sir. The flow in the channel is close to in the range of 3 to 4 MLD. But it is varying now with more and more sewerage schemes coming in the catchment. We expect the flow will probably reduce over time. So in conclusions, I think the interception and diversion schemes are quite important in the overall scheme of used water management. And in my view, at least for another 2 decades, we'll have to address this because there's going to be used water of various quality flowing in our drains. Inline treatment in drains is quite challenging because of high monsoon flows and lack of enough right-of-way in the drains. Designing I&D structure, the interception and diversion structure is the most important part of the design. And it's very, very contextual. It is difficult to give standard designs for that, but that's another conclusion. And the treatment process itself should be kept simple. And output quality standards, I've said need to be relaxed because today there's confusion on whether you have to meet the 10 BOD target. And once you start putting that kind of target, treatment process becomes expensive. Finally, you're releasing it back into a water body or releasing it back into the drain. Again, it's getting polluted downstream and so on. So maybe you can look at 20 BOD or maybe even 30 BOD. Possibly it'll keep the overall cost low in the system. So that's the summary of my presentation. Thank you.
Thank you, sir.
Thank you very much. This is one important component, and most of the cities in having population less than 1 lakh category, they are going to do as a immediate measure. One thing he told very important, that such type of treatment system do not require that much robustness which we do, because flowing through the drain, it already most of the BOD is dissipated and that is reduced. So even simple solution like constructed wetland or even your waste stabilization pond, they will also give good result. There are variety of things I will be speaking. So this is good thing that how you can do that I&D system. It is fully aligned with SBM, whatever the guidelines we have made, and we are going to advocate. And plus, regarding treatment he made, it is simple and doable. So with this, I thank you very much. It was a very, very, I think, useful and helpful presentation.
Thank you, sir.
Thank you. Anybody has any questions for Mr. Ganapathy?
Just to give an idea of cost, I think you asked me to speak about cost. So, this Mahadevpura project you'll visit tomorrow, which was funded by CSR for 1 million MLD capacity. That's again approximately, you can treat a little more also. It was about 2 crores total cost, of which the upstream structures and all would have costed about close to 10 to 15% of the cost. The tertiary treatment was another 10 to 15%. So 60% of the cost was the secondary treatment.
So 10 to 15% is an I&D system, and then the treatment actually, it depends on what you select actually. Okay. Yeah, please.
Correct. Correct. It's very close by. It is 100 meters, I mean 50 meters. Yeah. There's not much network cost. We are in fact taking it through a box channel kind of thing. Yeah, only 50 meters. Is larger schemes with a lot more length of pipes. Just a minute, sir.
Okay.
So for the I&D system, which we have been projected under SBM 2.0, what we expect that our town has got a certain periphery. depending on its density and the population. So it was that's the planning figures was that in case you got a town which has got a population of say 1 lakh, you will have a density of 4,000. That means your area is around 25 square kilometers. So typically, if it's a circular thing or a squarish thing, you will have a perimeter of 20 kilometers. So if perimeter in 95% of towns will be sloping in a certain direction. So what we were expecting that one side of this, this square or the 1/4 of the circle, which is the lowest point, that is the point where all the drains major drains at least would be coming. And so that you may have around 5 to 6 kilometers length of this IND system for a 1 lakh population, because everything costs. So if you plan, no, I'll make a moat around my town and I'll have a huge infrastructure for just collecting all the drains, even the minor drains, then that is illogical. So what is supposed to be, that is our expectation, that most of the towns will have a small 5 to 6 kilometers in case you got a population of 1 lakh. If you got a smaller town, then your area reduces and then your length of IND also reduces. So if it's for a 1 lakh town, say around 6 kilometers of length of a open channel, or a part could be even a sewer kind of a thing. There could be a scenario where you may have pumping. You will try at least to design so as the pumping is minimized, but maybe one odd pumping would also be there. And secondly is that because this will be close to a water body, the depth of this excavation will be low. So the cost per se of this kind of a network which will be creating will not be a very, very major limiting factor for your design, but that is the expectation.
Thank you. Yes, sir, please.
Sir, what is the precautions we have to take while proposing this IND? And second one is whether this is a intermittent solution or permanent solution.
Well, second part, can you do whether it is a
Intermittent solution or a permanent solution?
okay, yeah.
Temporary
Precautions. So I'll answer the second one. See, I personally think it is an intermittent solution, because eventually when your catchments have sewer networks or decentralized sewer networks and so on, less and less of dry season flow should come into the drain. They should get, in a sense, intercepted near the households, and the network should take it to an STP before it falls into the drain. So therefore, but I do see this intermittent period could be another 20 years. And therefore, you cannot ignore 20 years, and therefore you have to, yeah.
Rightly, what he mentioned intermittent, it appears, but actually under SBM, what we are planning, make a plan in such a way that later on this will become part of integrated one. So more and more sewer network comes and flow through drain will reduce, but it will be flowing towards the same, because we are siting these STPs along natural gradient. So it will always be, as a designer, easier that even if sewer network is coming, that will go to the plant. So it is immediate intervention as a larger part of overall robust system, right?
Yeah, good point. I think what Chaurasia Saab is saying is that the STP can still be utilized. If water stops flowing in the drain, it will come in some trunk sewer finally, and the trunk sewer can go to the same STP. So the STP infrastructure will not get wasted. The interception diversion systems may have to be given up, but even they can still act as good solid waste screens, and some of those things can still be utilized.
Any more?
What precautions, I mean, while proposing this is what you're asking. No, I think one is, I put it as challenge. I think one is you need to find land for the treatment plant if you're looking at a nearby system. So near the drain, you'll have to find that land. In terms of precaution, I would say solid waste, and how do you handle solid waste? How do you design the interception structure to handle solid waste? That's the only challenge.
I would like to add, the wet weather flow is also can become one of the biggest challenge. For that, they have an overflow system actually. Whatever amount which is supposed to go into the STP, that is regulated. So the moment it becomes more, it will overflow.
Correct.
Yeah.
So the monsoon flows, the solid waste, and the interception structure should take care of all that. So precautions as in what are the important challenges in design or considerations in design, I would say. Yeah.
Sir, drains passing through industrial towns.
Yeah.
Some industrial waste is put in the drains, and they have different characteristics at different times.
Correct.
Like in our Panipat town, we see there are lots of dyeing units. So water of different colors is coming, flowing in the drains.
So there, what kind of
That's a
treatment
tough
we should go
one
in?
because whether it's our STP or whether it's our drains, once you have unpredictable toxic effluent coming in it, then it's quite difficult to figure that out. You have to work more at stopping that kind of thing from coming.
Or we
into
can go in for CETPs.
Yeah, you could. If the entire drain is carrying mainly toxic effluent, you'll have to first test your effluent. Based on it, you have to design the STP. The STP may become a CETP instead of an STP.
And sir,
there's nothing else that can be done.
It's more point of, see, he's talking from the IND. IND may be the same. It's while selecting the technology, what technology you need to
We have to
select.
take
I
care
think
of.
Chaurasia sir will talk about it later actually. What is the next question?
And second is about bioremediation in the drains.
Yeah.
Some people are coming that they put some enzymes.
Yes.
And that enhance the treatment by microorganisms.
Yeah.
So is that successful? You will explain it.
Yeah.
in your-
Okay.
Thank you.
So I'll
Thank you.
leave that question.
Okay, I think if more questions, I think
One last, maybe.
one last, yes, for you.
So my question is, for a state like Goa, since we are on the coastal line, there is a reverse tidal effect wherein the
Yes.
drains, the water enters the drains, and even if you intercept the drain, the water again overflows and goes in the sea. So what can be done for that? And second is, since the land is very costly on the coastal belt, we don't get land to set up a STP. So what are the other ways the drains can be intercepted?
That's a very difficult question, sir. Please.
Yeah. No, I mean, if you're talking about backflow in the drains during monsoon, with the water levels rising and so on, that's a challenge. See, I would expect that much of that will be in the primary drain, which is the last part, which is almost like a river, which will go and join the sea. You will rarely intercept the river. You will not design these schemes. You'll have to design these in the secondary drains that come and join this. So little upstream, you'll have to go further upstream and tap and intercept at the secondary drain level. Because in the primary drain, many times you can't even touch it because it's a river. You can't intercept, you can't put any structure there. So you come to the secondary drains or tertiary drains and intercept ahead, where the elevations are likely to be higher and backflow may not happen.
Yeah, I think these are all more context specific. We can talk actually about this and find a solution because there is no ready-made solution for this. Yeah, I think with this, thank you very much for this patient hearing for a very long time. I hope that sessions were interesting and useful for you. I think now we will quickly break for a tea. Before that, yes. Before that, we will have a small, yes, this token of appreciation. Yes, please, the photographer. एक minute, sir. एक photo लेंगे. Can somebody take from our team the photo, please? Our photographer has gone maybe near to the exhibition place. Praveen, sir, एक बार फिर, sir, please. Thank you, sir. Yes. Thank you. Thank you very much, sir. Thank you, Vijay, sir. Praveen, you have an announcement, please.
Thank you,
Sorry for giving.
Ganapati sir. So it's 12:15 now. We have half an hour for tea break. We'll be back by 12:45. But two important things to note. One is when you step out for tea, you will see stalls that are set outside. So these stalls are not meant to be, I mean, you can of course visit and speak to them and interact during your tea break, but please limit it to 11:45 so that you're back. We have dedicated time for exhibition and for interaction with the stalls during lunch and a little after lunch. But right now, so just come back here by 11:45. That is number one. Sorry, 12:45. I'm so sorry. It's 12:45. The second point, during this, whenever you find time, you will find 4 sheets of paper. It's the same paper. It is arranged, your names are arranged in the alphabetical order of your states. So it is easy for you to find. It has, to the extreme right, you will see a column which has numbers. That basically says it should match the number on your ID card. If it doesn't, not a problem, just strike it and write it. But it basically says which batch you will go along for tomorrow's field visit. So we have 3 batches, 3 separate buses. So to know which bus you will be boarding, you will have to check the number on the sheet. And if any of you do not find your names, please come to the registration desk after the, during lunch or anytime, or you can contact me. I'm here. If you don't find your names. Thank you so much. You can step out for tea.
Slightly we are running behind the schedule, so as quickly it is possible, because such a good gathering, we have to utilize each and every minute. So please, as quickly you can come, we will start that. Thank you.
Okay, now kindly settle down, please. Please settle down. And anybody who is outside still, andar aa jaiye. Okay, we are almost say around so maybe 1.5 hours behind schedule. Ek second, this is a slightly important session which we'll be having. Slightly, all of them have been very important, but this is where we want to listen from the states. After whatever has been painted during the last 2 days, you may have learned something, but there would be some doubts in your mind in what has been happening in your states, whether no, it's a two-way street. If something good has been happening in your state, if you can let us know, maybe others can learn from it and can take it to their own states. On the other hand, in case there is some doubt which is lingering with you, that too needs to be pointed out. So now opportunities will be given to each state. You will come here, speak for around 5 minutes. One of your reps can come here or all of you can come here. There is a set of 4 questions which will be floated on the screen. And you just tend to speak about those 4 questions, how your states are conducting those, you could say, exercises. And from that, we'll come to know about the processes being followed by you. In case somebody wants to put a counter question, maybe you will be able to reply. Or basically, it's a two-way learning process. So now, without waiting any longer, I'll request Shashank or
yes, yes, sir. We would like to invite Mr. Rajivji from BWSSB, Chief Engineer. So they will share their experience on what they're doing. So everyone kindly please settle down. We'll start now.
Namaskar and good afternoon to all. So I am Rajiv KN, Chief Engineer representing BWSSB. I am given the topic of the reuse facilities, what we have carried out in BWSSB from last almost 1.5 decades. Okay. So next slide. Slides change.
Sir,
yeah,
it's here. You can take this. This is to go front.
Yeah.
This is good to go back.
Yeah, BWSSB is one of the organization exclusively formed as a board during 1964, first among all the water utility board. And from there onwards, we are serving the Bengaloreans. Earlier, our scope was only 245 kilometers. After that, it has extended to, we added with another 330 square kilometers during 2000. Thereafter, again 2007, we have added with 110 villages covering 225 square kilometers. Totally, Bangalore is now called as service area is 800 square kilometers. We have our mandates also. And BWSSB is the one of the organization wherein we are having the master plan, strategic master plan for the year 2050. Based on that, we have the vision also, we have the mission also. It has been implemented in BWSSB from the year 2018 onwards. And all our projects we are taking up based on the master plan in a planned manner. So now, as per the BWSSB is concerned, it is a radial development happened. The green areas which we are seeing is the 110 villages, where it is not the village, it is the urban area only, with the haphazard development has happened in this area. And now the water supply pipelines, sewerage pipelines are being laid in this area very recently under the government grants and loans. And STPs are constructed by JICA funded projects. JICA is continuously assisting BWSSB by providing the soft loans based on our performance and operational skills. We are making use of those things, and we have several STPs and other issues. Bangalore is not a blessed city in terms of the water, it seems, as per the water is considered, because Bangalore is not near to any of the river. The river Kaveri, which is the perennial and the important river of Karnataka, is flowing almost 100 kilometers away from Bangalore, having an elevation difference of 500 meters, that is a frictional and the static also. So we are pumping the water right from Kaveri river to an extent of 100 kilometers and 500 meter elevation continuously 24/7. Whatever the revenue BWSSB is getting, out of that 80% we are going to pay it for the electricity charges. That's what the water is very, very, very precious for BWSSB. That made BWSSB to think of reuse of the water in several ways. How best we can reuse the water. As on today, we are pumping almost 19 TMC of water to Bangalore city. Along with that, another 10 TMC of capital investment is going on that will be commissioned during 2023 March onwards. So totally 29 TMC of water. It is to an extent of 2,275 MLD of water being served to the Bangaloreans, having a population of 1.4. It is going to be 1.4 crores. It is expected to be increased to 2 crores during 2045 to 50. So we have a lot of challenges. It has to be countered. In that way, we are given more emphasis on the reused water. In that scale, by 2000, almost 2008 onwards, we have taken up major projects in reuse sector. So as on today, we are supplying almost 1,455 MLD of water only from the Kaveri source. That is why the total water supply, public and other private bore wells are also there. That will add up another 400. The total supply will be 1,855, out of which 80% is converted as the sewage. So we have the capacity of 1,525 MLD treatment plants in and around Bangalore. MLDs of 1,525 MLD capacity treatment plants we have in Bangalore. We have almost 37 number of treatment plants, out of which 7 are tertiary treatment water plants. So we are going, as I already told, we are going to use for irrigation purpose, aquifer and recharge, industrial process, and non-potable water also. We are going to use the reused water. And we wanted to reduce the burden on the fresh water by doing this. So that's what we are given more emphasis on, the reusing of water. What are all the BWSSB is undertaken under reuse water is tertiary treated water from 40 MLD tertiary treatment plant, Devanalli being supplied to KIADB industrial area. Industrial area is taking the water from our one of the 40 MLD treated, tertiary treated water. Tertiary treated water from Yelahanka, 10 MLD, is being supplied to Karnataka, Kempegowda International Airport, from where you are all the way come from the airport. There the greenery you have seen, they are using our tertiary treated water. Indian Air Force, BEL, Railway Factory and ITC are all taking our, we are selling the water from the Yelahanka treatment plant. And tertiary treated water, Kabban Park, very near to this, we have a Kabban Park. Kabban Park is having 4 MLD tertiary treated plant, wherein we are supplying tertiary treated plant to Raj Bhavan, Vidhan Sauda, High Court, Golf Course and Kabban Park itself. During the summer sunny days, they are taking the water from the tertiary treated plant located in Kabban Park area itself. Then 1.5 MLD for Lal Bagh we are supplying, and 15 MLD from Jakkur being supplied to Karnataka Power Corporation Limited, gas-based power plant at Yelahanka. And added to this, from 2019 onwards, we are supplying 380 MLD secondary treated water from KNC Valley to the Kolar district for filling the lakes. 125 numbers of lakes are being filled by this water for their irrigation purpose. We are giving the water at our outlet, and minor irrigation department has laid the pipeline and pump house to transfer the water. Earlier, this Kolar district was a Don Pond area. Now it is enriched with greenery, and they are now moving towards horticulture and floriculture industry in Kolar and other surrounding areas. This is one of the highest treated reused water project in Asia, because to the quantity of 400 MLD in single stretch, nowhere we can see this type of improvements. The people of Kolar and surrounding areas are also very happy with that. And another one is 40 MLD Raja Canal and 90 MLD Hebbal STP. We are supplying the water to 150 MLD to the Chikballapur district. It is also one of the adjacent districts located. So another project is going to come in future. That project is around Anekal and Kanakpura area, wherein they have also wanted to take our water. So by doing all these projects, almost 400 lakes in and outside the Bangalore is going to be filled up with tertiary, secondary treated water to an extent as per the NGT norms. NGT is also very much happy with the work BWSSB has taken up, so that the reuse of water to the greater extent has been achieved in BWSSB in cooperation and with the guidance of Government of Karnataka. So you can see the Narsapura, earlier the lake was like this, and greater it was during 2018, it is filled up with it is a dry lake. Now it has been converted as a greenery. So the green lake we are seeing, all the bore wells in that area has been filled up with our water, and bore well yield is also you can able to see from 2018 onwards. Similarly, we are having Agaram Lake in the same downstream side.
Excuse me, sir. Just how much time does it take?
So
I
she
think
has shown me 2 minutes.
she has already shown.
Yeah.
Thank you. Thank you.
The interruption will
I'm so
distract.
sorry. I had a question actually. I wanted to ask you a question.
Yeah, at the end you can ask, sir. Thank you. So bore well also we can able to show you, and digged well also we can see, sir, how the wells are recharged because of this irrigation projects. It is one of the Lal Bagh TTP tertiary treatment plant, and out of the reuse through the sludge, it is also one sort of a reuse only, sludge reuse. We are generating power to an extent of 750 kilowatt per hour will be generated. Power will be generated, and same will be utilized for our maintenance of the O&M of the equipments in KNC Valley project. Similarly, we have 60 MLD tertiary treatment plant. It is going to serve the water to Arvind Mills and other areas. And not only giving the water, we have mandates also It is also, we are selling the water to a net rate of 10 rupees per kiloliter for secondary treated water and 15 rupees per kiloliter for the tertiary treated water. And we are supplying the water to there, and we are having exclusive tankers colored with different one. It is a tertiary or secondary treated water. We are going to use this type of tankers. Anybody can hire. And we made a mandate in giving the NOC to the big builders, wherein they should take the water, treated water for their construction and curing purpose. Otherwise, we are not going to issue the NOC to the high-rise buildings. So these are all mandates. And also BWSSB has implemented the private, any commercial buildings having more than 200 square kilometers, 200 square meters, or for 20 flats and above should build their own STP, and they should use their water for their own purpose. So future plans also we are having. We are, as per the master plan, we are having these many plans. In future, we are going to assess the orientation of BWSSB during this time. So these all will help BWSSB will have a sustained development in cooperation with the other government agencies also. Thank you very much. Thank you. Any question, please?
It's a very nice presentation from you. We would like to ask you several questions.
Yes, sir.
If our audience has any question, we can begin with the audience.
Anybody has a question?
Sir, I made it
just a
very
minute,
short.
sir. 1 minute, sir. Sir, here.
ನಮಸ್ಕಾರ ಸಾಹೇಬರಿಗೆ ಈಗ ಟ್ರೀಟೆಡ್ ವಾಟರ್ ಸ್ಮಾಲ್ ಅದು 20 ಯೂನಿಟ್ಸ್ ಅಪಾರ್ಟ್ಮೆಂಟ್ ಕಾಂಪ್ಲೆಕ್ಸ್ ಎಲ್ಲ ಮಾಡ್ಬೇಕಂತ ಹೇಳ್ತಿದ್ರಲ್ಲ, ಅದು ಮಾಡಿ ಮತ್ತೆ ನಿಮ್ಮ UGD ಇದಕ್ಕೆ ತಗೋತಿದ್ದೀರಾ ಅಥವಾ ಜಸ್ಟ್ ಫ್ರೀ ಫ್ಲೋ ಹೋಗುತ್ತಾ?
So you please translate that in English, then answer.
Sir, namaskara. Sir, the question is 20 MLD, 20 flats and above apartment should make their own STPs. This is a compulsory one. Without that, BWSSB water connection cannot be given to them. Okay. The question is whether after having the STP, BWSSB is going to take that excess water to our UGD system. Is not, or is there, or any system is there like that? He is asking. The question is, once it is treated from the apartment people, it has to be reused, because this rule has come to make the popularity of the reuse system. Okay. Otherwise, the entire the utility wise 20 and above flats people used to treat their own sewage, and they will not have the bindings. And again, they will let it treated water, they will letting into our UGD system. Again, we have to invest. Treated sewage again come to our raw sewage, will enhance, once again will burden BWSSB with respect to our capital investments and O&M investment. To avoid that, the sanitary connection will not be given to that area, that buildings wherein they are having a 20 and above flats STP system.
Oh, very nice. Any other questions? No.
So please.
Okay, so the other advantage is that if they let out the treated water into the drain, there is a possibility of they will not treat it further. Yeah. So I have a question for you.
Yes, sir. Yes.
Most of your treated water is utilized in irrigation. So how do? You build pipeline and pump them, or how it is done?
Sir,
and
the BWSSB
and who pays for those costs?
Yeah. See, it is a BWSSB is also government organization, and minor irrigation is also government organization. It is a government organization taken up schemes. Minor irrigation will lay the pipelines and the pump houses
from your STP.
From our STPs. Okay. And we are giving it is an undertaking, and we are giving the treated quality water as per the Karnataka Pollution Control Board norms to minor irrigation. They will take the water to the other city. 10, almost previously it was 20, now it has been brought to the 10.
So
10,
this is,
10.
this is a secondary treated water.
Secondary treated water.
You're taking it at 10-10.
Yes.
Have you done any improvement in your infrastructure, the existing infrastructure at the plant?
See, this 10-10 was, we are talking about right from 2016 onwards. Even though our norms are at 20, BOD 20 and other things, but the quality of the construction, quality of the operation and O&M what we are taken in BWSSB, and especially the KNC Valley and the Bellandur Manikane plants wherein the outlet itself is coming with 10-10. We are monitoring that.
And what are the technologies?
So BWSSB, we have right from GURG book, what are all the technologies are there in the GURG book, entire technologies are there. Very recently, we are going with activated sludge process with A2O process, and we are having SBR also, bigger scale SBR also. We are having extended aeration also.
These 6 plants which are feeding the 2 districts.
Activated sludge, majority of them are
So
activated.
basically what we are trying to tell you is that with ASP, with good management systems which Bangalore has,
Definitely.
which you can learn from Bangalore, it will be possible to get a 10-10 BOD and TSS value.
Yes,
That's what you're
yes,
trying
yes.
to. It's only that the management has to make sure that things work.
Sir, our one specialty here is any plant built in BWSSB under DBO contract, design, build and operate with the 7 years of O&M. So there is no
So that is
deviation.
the JICA norm, I think.
No, BWSSB
Also,
norm.
you have the
Yeah,
same
yeah.
norm.
JICA adopted that.
And one final question. Still then, you have done a lot of work in Bangalore. Still then in press, we find your lakes are polluted and sometimes foaming and all those things. What could be those reasons?
Yes, yes. That's the reason I shown the first slide. Bangalore has, as a BWSSB, we has 250 square kilometers during 2000, then added with another 330. This 110 village pocket, wherein BWSSB or BBMP not having any scope of work. It has been guided by Gram Panchayats and Gram Tanas planning sections, wherein episode development has happened without having proper infrastructure. They are having, some of them are soak pits. Till today they are having, we are removed all those things. Now we are laid the sewerage lines. And many of them are letting the raw sewage into the stormwater drain. Bangalore is having a 3 drainage area, wherein all the sewage coming from the drainage area, which includes unsewered network area also. This raw sewage enters into lake, series of the lake, one lake, Bellandur Lake suppose, then Vartur Lake suppose, like that. These sewages caused the greatest hazards. That's what government has given more emphasis now to cover unsewered area to sewerage area. That is why the Bellandur Lake contamination is also getting reduced. By another 1 year time, under 14 STPs are under construction. Yeah.
I have a question.
Thank you, sir.
Just one. No, this is a very important. You said that you have this system where all building blocks with more than 20 residences will have their own system. That's very nice. But are they using this water? What is your sense with BVSP? Are they using this water for landscaping, or are they using it for toilet flushing? Because toilet flushing seems to be something which we want to be really very sure about before we start to
Yes.
the potential
Sir,
of toilet flushing.
Yeah. Toilet flushing is whatever. First, I will answer toilet flushing. Raj Bhavan, Vidhan Sauda, or any other MS building, if you flush the toilet, that is our treated water, sir.
Okay.
Toilet flushing will not hamper any of your plumbing utensils just because of the treated sewage. If the treated sewage quality is not good, then only it will cause the effect. One thing. Second thing is with respect to the apartments wherein they are having portable STPs, big minor scale STPs, and are also there. Most of them are using it for the flushing and gardening purpose. And that much quantity of water, Kaveri water, they are reducing consumption. They are reducing. Third thing is we are announcing every year some prestigious awards to the apartments wherein they are implemented this reuse water from their own STPs. We have seen n number of apartments are using with the dual pipe systems, and they are utilizing the entire treated sewage for gardening and dual pipe system for flushing. So big STPs, more than 500 flats and other things, they are making it very effectively. Otherwise, their water bill will come in terms of lakhs. To avoid that, they are going for this.
Are they using it for the landscaping?
Landscaping, gardening, washing floors, and also for dual pipe system for flushing. Sir, anybody wanted to talk to me with respect to any of the issues, please free to contact me, sir. Okay.
Just for your information, tomorrow we are visiting one of the project in Burma, where we will explain them.
Yes, yeah. Please visit that plant. That is also one of the best plant, 20 MLD only, smaller capacity. Please visit. Thank you, sir. Thank you.
let's give a big hand to him.
So, in the interest of time, actually, I know that many of you have prepared the presentation as we have already a little bit delayed. So what we have done is we have put these 4 questions. You can see this for a minute. I think, I hope based on yesterday's discussion, you would have prepared kind of a presentation or your talk in this regard. So I think we would like to call on states now, one by one actually. So where you can talk about these things actually, pertaining to your states.
But if somebody is comfortable presentation,
Yeah, if you want to make a presentation, let it be, you can make it, but let us try to cover these points if possible, actually, rather than talking something else, actually. That's the only request. Yes, I think the presentation, if anybody wants to do it, let's try to limit that to 5 minutes. Yes, sir, please come. Sir. Uttar Pradesh, can you please put a...
Yeah, I'm H.K. Kansal, Chief Engineer from UP Jal Nigam, and looking after the urban affairs of water supply and sewerage in UP as a whole. So as far as UP is concerned, all are aware that we are 1/6 population of India, and it is a huge state in terms of population. So I have been given 5 minutes, but I will like to tell something that in Amrit 2, we have gone through a concept that the universal coverage of water supply to all ULBs is a mandate. And there is one more word in that mandate, that cities are to be made water secure. So cities to be made water secure will simply mean that we have to stop the exploitation of water, and we have to reuse the water. Here from the word come itself, that we have to manage the water aquifers and exploitation of water and reuse the water. Only then cities will be water secure, because water demand is increasing in a very rapid pace in urban areas of the country because of industrialization, more agriculture demand, and so many things. So my state is having 8,200 MLD sewage generation, and we have installed capacity of 3,400 MLD. That is around 42%, which is slightly below the national average of 44%. So here from the we can see that used water management word is used for all ULBs below 1 lakh population. Here we have seen that used, I don't need, I think. Here we have seen that used water management word is used, not the used water treatment. Here comes the meaning that we have to reuse the water essentially, because otherwise it would have been used water treatment, because it is the mandate that no single drop untreated will join the river or any water body. But we have to manage the water, treated water. So that is the reuse of water. I think I have just summarized in the, can you give me that? I think we have summarized just the guidelines and then 4 or 5 slides what we are doing in UP. So this is due to time constraint, otherwise I would have taken a lot of time. So in first phase of SBMU, there were no funds earmarked for wastewater management for towns. Based on learnings from the 7 years, use water management for towns less than 1 lakh population has been newly added as a component under Swachh Bharat Mission Urban 2, as we all know. So all used water is safely collected, treated, and reused to feasible extent. In urban towns of less than 1 lakh population, 1 lakh sounds to be very good, but it is sometimes 10,000, 15,000. So in such type of towns, we usually have the agriculture use in most of the cases, because industries somewhere we can find, but in most of the cases in agriculture. And as per the CPHU manual chapter 7, we have not very stringent norms to use in agriculture for water, treated water. So we can, in most of the cases, we can use treated water in agriculture. So on this term, component of used water management system, sewage, that is used water, septage, collected liquid from septic tank, and conveyance. I think we are hearing about it since 3-4 sessions last date to up to this time. And conveyance is the off-site system, that is sewage conveyance and management. And this sewer network, this is the thing which was emphasized since yesterday, that in every town that is called walled city, old city, or whatever, so 20-30% area is having minimum 50% population. Here, usually the density of population is more than 4,000 per square kilometer, and optimized sewer cost is achieved. So here we go for offline sewage treatment and sewerage, and this has eventually to be funded by the concerning states. And in the fringe area, we can go for different type of on-site treatments, which we have already discussed. This is the on-site treatment and treatment, recycle and disposal. So in my state, not much work has been done in urban area for recycling, but we are using about 400 MLD of water in different towns, different cities, Amrit cities, for agriculture purpose. And recently we have made a tertiary treatment plant at Kanpur for 30 MLD capacity, which will serve the requirement of BHEL under Uttar Pradesh Rajkiya Vidyut Utpadan Nigam Limited. So we are just trying to give it in January or February. It will be completed work, and it is we have got it on deposit basis, and 30 MLD STP after tertiary treatment ROUF technology, we are serving that water. So the water can be used for agriculture, horticulture, industrial purposes. But as far as SBM towns are concerned, I think most of the water can be used in the agriculture and horticulture purposes. This is the scene. My state is having 763 total number of ULVs, in which 60 towns are the Amrit towns, which are more than 1 lakh population, and 703 are the towns which are having less than 1 lakh population. And the total population as of 2011 year is 1.77 CR, and in the base year of 2026, it will become 2.43. So this is the broad classification, that 50,000 to 1 lakh, that is 61 towns, which are categorized as class 2 towns, and rest class 3, class 4, class 5, and class 6 are 642 towns. So total 703 towns I have just classified, and that is the maximum limit of per capita allocation for STP and IND from the central government as mentioned in the guidelines. That is 3,000 per capita for class 2 towns and 2,000 per capita for other class of towns. These are the progress we have made so far. So far, we have got approved from our SHPSC of the State Apex Committee, that is CSAP approval of 139 projects. And we are planning 100 more CSAP to be got approved in November 20, and DPRs are already started to be prepared. And we are doing this in-house, just hiring some surveyors and some software engineers and that's it. So 10 DPRs we will be completing in November, and accordingly 66 in December, 163 in January, 150 in February, 314 in March. And we are planning that all the DPRs we will made up to March only, that is 6 months after launching the program. And DPR approvals will take time, and it will be completed by June 23. And tendering process will start from February 23, and we will be able to start at least 20-30 ULBs works in May 23. So that is our plan. I think I can share that much. And we have calculated our cost estimation also. For 139, we have fair estimation of cost because CSAP has been submitted. So this cost is coming. For IND works, it is around 1,550 crores. And central share and state share I have mentioned. And for sewerage network in the core sanitation area, we are having around 2078 crore rupees of investment. So total comes 4081 crores. And central share against the total scheme, including the sewerage, it comes to be 776, which works out to be 19%. And we have forecast about RES 564, for which CSAP has yet to be approved. So this is the cost worked out, and the total cost comes out to be 14,000 crore in terms of 703, including sewerage network cost and IND cost. IND works cost comes to be around 5,500 crores, for which we will get 50% central share. And this is the breakup of the cost. So this is our strategy to complete the SWM CSAP work. And I think I am running over time. Thank you very much. Thanks.
Thank you. Thank you.
Any questions, sir? Sir, questions over.
Any questions from audience?
Anybody has a questions from the audience? Great. Sir, please.
I have one question for you.
Right.
You have so many towns in UP. So what is the institutional arrangement that you have made to execute all these works?
Sir, we are in itself, UP Jal Nigam, the paracetal agency, is equipped with lot of engineers, and we have for survey and estimation, we are not giving it to consultants directly as a whole. We are getting survey done in our supervision directly. We are getting the estimate prepared. And for that, some amount we are giving to them also, but not on the percentage basis that this much is the cost and you do the work and we will give the cost. So I think we are a bit less in number, but we are overburdening ourselves, and outcome we will have to give, and we are giving in time, and we are committed to give in time. That I can assure from the side of my state. No issue in that.
Okay. Thank you.
Thank you.
Anything, any
Yes.
constraints? Yeah, any suggestions?
Sir,
Or
constraint
any
in
experience
UP,
you can share.
in UP, mostly we are having plain terrain, and we have visualized that whatever guidelines have been given by that CPHU or the guideline of SBM2, they are quite close to fit into the site. I mean, once we go to the old area, it is really containing some 50% type of population in that portion. And we will definitely go for IND works and co-treatments. And I don't think that there is such big challenge which we have encountered so far. Although there was a question I asked yesterday, there is slight issue that for which, up to which stringent parameters we should take the treatment options. Because today it could be okay, but in coming time, if there is some, so we are not very clear, although we will discuss after preparing 2-3 DPRs, we will go to CPHU and we will like to discuss with you and take your guidance. Are we going in the right direction? Because the work done in 703 ULBs as of now may have some unforeseen complication, which we couldn't even visualize this time. Because the effluent parameters are day by day going stringent. So we will, I think, discuss, but by the time we can go with the technologies we are learning here also, and with the as per the discharge and as per the sufficiency. And I think state share is a bit higher in our case because it is a big state, it can handle the revenues as well. But
Thank you.
I think
Can
we
you
can do it.
just
No such
reply-
challenge as a technological intervention. We have no challenge.
Thank you
Thank
very
you.
much. Thank you. Can you give any answer to his query? Like he is seeking clarification from CPHU on treated standards and all.
I think
Okay.
Sir ka session hai
Okay,
next. I think he will
ठीक,
cover in
ठीक.
that. Sir, thank
It
you
will be
very much, sir. That looks very good actually. Big loss, yes. Next presentation, whoever is given, can I request? Or should I just? Yeah, please, yes. So I think let's try to make it quickly. I know that you have so many things to share, but in the interest of time, let's stick to 5 minutes and maybe 2 minutes for the question and answer. Thank you.
Much time, knowing that there are time constraints. Good afternoon. I am feeling privileged to be here amongst this August gathering, sharing the information that we have, what we have done up to now and what we are up to in sewage management. I'll be firstly taking you through how much sewerage generation we have. Our sewerage generation as on date is 523 MLD, while the installed treatment capacities are of the order of 140 MLD. Number of STPs are 15, all are operational and compliant. Gap in sewage treatment currently as on date is 383 MLD. Treatment capacity likely to be added by 2023 is of the order of 92 MLD, which will reduce the gap to 291 MLDs, which will be met through the proposed projects. The proposed projects, we have 21 projects with 28 STPs, aggregate capacity 122 MLD. And in addition, there are 4 STPs with aggregate 4 FSTPs with aggregate capacity of 520 KLDs in our 3 main cities, Srinagar, Jammu, and Anantnag, that are over and above this 1 lakh population figure. In Amrut 2, we have envisaged schemes having the capacity addition of 30 MLD and 28 MLD, aggregating to around 60 MLD. And we had one problem, major problem in Jammu region. That was underutilization of the capacity, for which we have built in the Amrut 2, and we have gone for 2 schemes for exclusively house connections in the Jammu area. If we see our urban structure, we have 2 municipal corporations of Jammu and Srinagar main. We have 2 cantonment boards. We have 59 municipal committees and some 57 municipal committees and 19 municipal councils. So aggregating to around 80. JMC capacity utilization is an issue that I have told you. We have, and SBM, we are targeting 74 ULBs. All ULBs, 76, minus Anantnag and Udhampur. Anantnag, we have done under this Amrut above, Amrut 2, and Udhampur, we have a Devika project. There was an issue of pollution around this Devika river in Jammu region, which would pollute the Tavi main also. The sites were identified, it's one of the identified sites of 501 polluted stretches in rivers of India, identified already by CPCB. And we have worked on this. It was a 176 crore rupees, 186 crore rupees project. So we are handing it over along with the house connections and 3 STPs, one 8 MLD, another 4 MLD, and the smallest 1.6 MLD for the entire 3 zones of district Udhampur. Then we have the future projects for 75 MLD sewerage scheme of Jammu and 125 MLD sewerage scheme of Srinagar. We have proposed it under JICA funding. 1,250 crore rupees is the estimated cost on 2022 price level, and the 1,302 crores for 125. So these have almost been in principle agreed, but we are now preparing the documentation and doing it. We are hopeful that in coming days, these proposals will see the light of the day. Then we have the centrally sponsored schemes out of this most polluted river stretch in India. Udhampur, I have told you that what we have done, that in addition to this, what is the facility that we have? It's a disadvantage also our cities have. If we see the Jammu region and the Kashmir main urban local bodies, main urban centers, those are on the two banks of the rivers. I mean, River Tavi and River Jahlim. On the right side, there is some development, or the other side, there is settlement. So what we have done zonation of these, and simultaneously what has happened that in Srinagar, we have been able to saturate zone 3. We are now focusing on zone 1 and zone 2. And similarly in Jammu, we have divided into 3 divisions like zones, and zone A and zone B are almost saturated. Now we'll be focusing on zone C. This is the layout of this Jammu and Srinagar cities I had just given, but I have already. So, but just now, I'm just making some suggestions now. That's this, and then in NRCP, National River Conservation Plan, we have been able to push 4 projects. One is interception and diversion of 13 nalas. It will go for a capacity addition of 10 MLD. Vanganga River, it's a holy river in Katra district. Well, we go to this shrine Mata Vishnu Devi. So then Chuntikol and Gaukadal, these will also add some 8 MLD. And these are at various stages of technical appraisal. Either they are at IIT Roorkee or they are with the Delhi Technological University going for the final phase of approval for this technical appraisal, and then it will be put forth for the final the sanction of the Government of India. So regarding this Swachh Bharat Mission 2, I would just have 2 suggestions. Just I was thinking, in order to handhold states' duties, especially on matters related to choice of technology and design of sewer networks, there needs to be a centralized or a decentralized appraisal mechanism put in place by the National Mission Directorate, so that the disparities, I mean, we are still thinking what type of a technology to be used and what is the cost of a sewage network that befits our pockets, our these resources, and so as to address these issues, we need to have an appraisal organization, appraisal authority, who will appraise our DPRs and see that these are as per operational guidelines, and the coverage is the maximum out of the minimum funds available under SBM. And second is that since these missions are always time bound, there must either be preparation for the missions at least 2 to 3 years in advance, or first 2 years of the mission should be preparatory. Before launch of mission, all exercises with city sanitation action plans, gap analysis, design works, DPR formulation, including appraisal of DPRs, standard bid documents and amendments or refinements of the operational guidance to suit the requirements of each state UT should be in place. This will ensure implementation of ISHA on ground in a time-bound manner, as also the achievement of desired outcomes of the mission. With this, I thank you all. Thank you all.
Thank you very much.
If there are any questions,
your two suggestions are very valid, and points are well taken. Especially point number 2 is also very important, that you need more time for planning than execution. So plan, do the survey. Yeah.
All states
प्लान नहीं है फिर एग्जीक्यूशन करो और पैसा भी लेके जाओ और पैसा लेके क्या करेंगे. एंड और एक चीज मैंने देखा, आपका जो पावर पॉइंट जो किया है एकदम सही किया, एक इंजीनियर का काम जैसे किया है, वेरी क्रिस्प.
Because we didn't get time for making it, I just yesterday, we went home and
Yeah, this
it just,
ये तो पूरा एकदम पक्का है जो काम किया है वो ऐसे ही लिख के दे
it took us some time yesterday only.
Great, sir. Thank you very
And
much.
for the
Thank you,
first
sir.
point, I think CPHO you also handicapped. They cannot, appraise your DPR. So it has to be at the state level, I believe, and you have to develop the
No,
capacity. at
state
the
level decentralized, it's also, but somebody has to do it. I mean, if mission directorate identifies 2 or 3 organizations.
No, that is
who
the
can
reason
look out,
why
who
we
can
are
handhold us.
No, that is the reason why we are having this capacity building workshop.
Yes.
So that we build our capacity and we go back to our state
Absolutely.
and then we implement. So it is our own.
I am basically drawing this experience from my being a nodal officer on this, what's said to it. There was one program. Then what we had consultants in Delhi. They had identified 2, 3 JN Europe. They were sitting in the ministry. We would submit our DPRs to them. They would appraise it there. And then we would come to know where we are wrong. They would take decisions there, small decisions, and tell us that you refine these DPRs, these lines. Even the draft DPRs also sometimes they would share and
very correct.
JNRM was only 63 towns. Now we are dealing with 4,500.
naturally,
So
that is
be
your
at,
scope is.
That's why this was devolved to the states कि आप अपने आप ही करके, and you can engage the IITs and others. But
Absolutely, but there is-
definitely the time जो चाहिए, even for the IITs to understand what is the concept, what is how to, so that time needs to be somehow given to. Very nicely.
So nice of you, sir.
Thank you very much.
Thanks for-
Sir, there may be some kind
So
of a
let's give a
guidelines.
big hand to him.
Give a big hand. Any kind of a guidelines are there how they should proceed, sir, actually, or you say that you please handle at the state level? I'm just.
We have, in fact, during the last 2 days, at least, I think I have given you some pointers.
Okay.
Now, if you want me to put it on, on a paper, which without actually knowing the state, because we can give you a general guideline, but I can't give you exactly what is the technology required by you. I can only suggest based on my experience that, okay, see, look what Bangalore is doing with ASP, which are well established around the world. These thousands and thousands of such plants are there. You can do with it. They are cheaper than the other competition. But I just can't, prescribe to you anything because
I think the treatment approaches we discussed today. I think in the next session, Chaurasia sir will talk about the technology. Let's see, sir. I think we have to find the way. Okay, so thank you very much. And the next one actually, which presentation we have? Goa, would you like to do or we want to talk? What do you want to do? You want to present? Please come quickly.
Yes. Okay. I also didn't get time for this presentation. I prepared it yesterday itself. So my presentation will be short on the status of the sewage scheme right now. What is there in Goa? So next, please. So as you know, Goa is a very small state, a coastal state, just above Karnataka. The total area is. So total area is of around 3,700 square meters. Population is 14 lakhs as per the census 2011. But if you see, the floating population is so much, it becomes almost up to 80 lakhs. So it's more 5 times the actual population of Goa. So there are just 2 districts, North Goa and South Goa. There are 14 ULBs. In that, one is the Corporation of Panji and 13 municipal councils. And there are 12 talukas. So this is the actual position of sewage treatment plants in Goa. So there are 2 divisions, one for South and one for North. And as you can see, there's a 2 MLD plant in Panji, Talegaon plant of 12.5 MLD. In Madgaon, Naveli, there's a plant of 20 MLD, and Ponda, 15 MLD plant. There are, okay, in the next. In this, you can see which are the actual operational ones and which are under different stages of implementation. So if you see Panji, 12.5 MLD plant is there, where you also code treatment is also taking place in the plant, and it is catering all the nearby villages also. So these night salt tankers have been treated in the STP in Panji. So a 20 MLD plant is in Vasco and a 20 MLD plant in Madgaon. So basically, there are no STPs on the western part of Goa. So the Western Ghat area, if you see Walpoi, Sakali and Sange, there are no STPs because of the hilly terrain. And normally these are the semi-urban areas. And in these areas, what they do is they prefer having STPs rather than STPs or septic tanks in the bulk waste generators or the hotels which are there. So this is the scheme proposed by the Sewerage Department of Goa. So in areas where there are no STPs, a network has been laid, and these are the proposed networks. One is in Savarde, one is in Mapsa, Kandolim, Pororim, and Sankli. So the general background of sewage treatment in Goa. So before 2004, PWD was managing only 3 schemes, that is in Panjim, Margao, and Vasco. After that, a sewerage corporation was formed, and it is in operational since 2008. And JICA funded schemes in Madgaon, Mapsa, and Baba Kalangut have been, some are completed and some are in progress. So sir told me to talk about the challenges in Goa. So major challenges is since land is very costly in Goa, its availability of land to set up a STP and pump house is a major issue. Second is there are local oppositions because nobody wants STP in their backyard. So then since in the western area, as I spoke, it becomes very difficult to set up a STP. So far off location, STP network is financially unviable. Sewerage network infrastructure is capital intensive work and needs huge budget allocation for a small state like Goa. Per capita expenditure of sewage treatment is very high in Goa due to the less population and more of tourist influx. And reluctance of citizens to get a house sewage connection. That has happened, and people are very reluctant. They prefer having a septic tank rather than having a sewer network. And we have a monsoon season of almost 6 months, and due to heavy rainfall, we would just get 6 months period for implementation of the sewer network. And high floating population of tourists puts pressure on the sewage infrastructure. So the action plan would be, this was discussed in the state level technical committee, wherein the Sewerage Corporation, the Urban Development Department, and also the PWD department were involved. And a plan is being laid considering all the schemes of the state and the center. So to review all sewage infrastructure of ongoing scheme and under construction schemes in Goa, to create strong sewerage division, subdivision, OM and existing sewage schemes, and to maintain sewage assets. To review all ongoing sewage projects and try to complete full or part sewage scheme. Capacity building of PWD, Sewerage Corporation, Urban Development Department by imparting training. Awareness among citizens to take the house sewage connections, sewer connections. Review of the Goa Sewerage System, Sanitation Act. And as per that act, there was an amendment wherein in 2010, the direct discharge of water was prohibited by the Goa Pollution Control Board. And also any new project above 40 houses should have a STP and in their own premises. Without that, the construction license was not issued. And under SBM2 and Amrut 2, we are considering new projects. So my request is the Goa should be allowed small STPs of 40 KLD, 60 KLD or 80 KLDs, so that the population of say 1,000, 10,000 or less than 10,000 can be considered, and that influent can be treated at a smaller place. Because due to non-availability of land, what happens is that we are forced to have a STP at a MRF treatment plant, nearby a MRF treatment plant where the population density is very less. So because of the population, because of the opposition from the locals, so we are forced to have a STP in these remote areas. So having a STP and will help these nearby villages to cater their night salt tankers, which will come from the septic tanks. And rather than having a sewage sewage network for this scattered population, it becomes very difficult to lay a sewage network because it becomes very cost intensive for the state, and SBM is not funding the sewer networks and just the STP. So our request is to give us preference and not considering like any other state, and given some preference for STPs or small capacities. Thank you.
Very, very nice presentation. And I think the challenges, what you have mentioned is common in all the towns.
Yes, sir.
The challenges remain same, but you, because of the hilly terrain, you have a typical situation of
Yes,
sewer network.
the scene in Goa, sir, is we have these Western Ghats and all the water flows and eventually reach the coastal belt. We have a long coastline of 110
And the
kilometers.
coastal belts are tourist destinations.
Yes, sir.
So you have to solve the problem, otherwise tourists will not go. But anyway, they
Correct.
will go. But you have to solve the problem as well.
Yes, sir.
So even in our plan, what we are saying, all towns which have got a population of less than 20,000, you need not at this moment try to go for a network.
Correct,
Right?
sir.
That is one. But when the population exceeds a certain threshold, right? If it goes above 50,000, we expect that there will be a core zone in which 50% of the population will be covered. That too is possible, right? Isn't
So
it?
there are just 3-4 towns which
So
exist
that. So 3-4 में ही करने के लिए हम बोल रहे हैं through this
So,
mission.
लेकिन वहाँ पे बहुत tourist influx
Now,
बहुत है sir.
now comes a point that space is not available. That is slightly difficult to, you said 3,700 kilometers and 14 lakh population. Delhi is 1,300 kilometers and 2 crore population. We were able to find space in Delhi. You will definitely be able to find. Because finally, short-term benefits जो होता है of an individual or a group of people.
Sir, वही issue वही है ना sir. They consider our actual population. The tourist population is 5 times more, 80 lakhs का population.
More so the reason that you set up infrastructure so that their pollutants which are brought in by the tourists, they do not damage your health, at least in those concentrated towns on the coast. Right. So the bigger towns will you can definitely manage it. And everybody's been to Goa, so we generally understand what is the terrain and what is happening along that coast.
Yes.
Second, among the towns which have got a population of 20 to 50,000, which would be around 6 or 7 of your towns, we are giving you a choice whether you want to go for a network and become a, you could say, progressive town, like the bigger towns, or you want to remain those, on site wala thing. That choice, 50% towns may is given to you. So only 50% of the class 3 towns and the class 2 towns may we want this kind of a system to come up so that, see what is happening. If you don't do it, okay, theek hai, society is one part. But if I want to settle in Goa, tomorrow I purchase a plot of land and settle in a town in Goa. And if there's no network, then I am also forced to make my own arrangement, make my own septic tank. It is something like in Delhi, if you don't give us a metro rail, then everybody will have to buy his own scooter and this thing. But this cannot continue because this is creating a lot of pollution. And after a certain threshold, a town has to go in for at least some portion of it has to be covered. So that is
okay, sir. Thank you, sir.
You can also try some more advanced technologies like MBR and all.
So we have tendered the works. We are thinking of setting up a ETP wherein the waste of so the toilets as well as the market complexes can be accommodated in that. Along with in markets, what happens with the fish waste, what is there, that also goes to the drains, stormwater drains. So that can be collected, and we are using, I think we have proposed the MBBR technology.
Okay, thank you very much.
Thank you, sir. Sir, there is one point, as he was mentioning, which was his concern, that smaller KLD plants, they were asking, please allow. I think everybody has a question.
Especially for small towns. I got this scheme from Goa to wet abhi jo aapka aaya tha, and they were around 12 or 13, 20 KLD plants they wanted. And most of them were saying fish market, meat market, this. So we are saying that we are a municipality. We make an arrangement around the fish market, the municipality, municipal areas, domestic areas also feed in their waste, and the fish thing also comes in out there. So at least make it to a 1 MLD plus. And 1 MLD means just about, if you say around 10,000 people. So uske liye kar sakte,
So for 1 MLD, it will require at least 1,000 square meters of land. So that is not possible. 1,000 square meters land is not possible, sir.
No, let us hear from some of the other senior engineers out here.
इसमें क्या problem is whether सुबह जो बात हो रहा था centralized versus decentralized. So because of land constraint, they want to do a lot of decentralized small STPs. I think CPHU should consider
Yes,
and
sir.
take.
Yes, sir. Thank you.
I
Thank you,
think
sir.
this may be the question, especially in such places, sir. Yeah,
Yes, sir.
okay.
Thank you, sir. Thank you.
Thank you very much. So I think, can you all give a
Okay, I'll skip this one, Mizoram at a glance. I hope so you know Mizoram very well. This few snapshot of Aizawl. This is our present status. ODF in 2017, and we have constructed or developed by the digester tank and EMI facilities for Aizawl City. I'll be elaborating this one. And also under ADB funding, we have constructed 110 MLD SDP. And as we said yesterday, all houses in Mizoram, we can say in urban areas, are with septic tank and sanitary latrines. And 90% of the fecal sludge are dislodged through private dislodging operator. This is our present status. We are largely dependent on private dislodging operators. Yeah, this is the septage management plan, and AMI and biodigester manufacturing unit. Well, we give a presentation in this particular project. Some people does not believe it. We are using DRDO technology, and we found that this is let me say that this is constructed under the previous AMRUT, the earlier AMRUT. This is quite successful according to us. Although the BOD level is maintained at around 50, but the thing is that it is very good for a hilly region having a septic tank. The thing is that this now also they in a sense like the PhD people are operating. They sell the AMI, that inoculum, that bacteria at the cost of rupees 12 per liter. Like if a person's bought around 10 liters and what to say, give it to the septic tank, the sludge level goes down at around, let's say like it reduced at around 10%, no, 90%. Only the 10% left. In that way, for the reduction of the sludge, it is very useful. We have experienced it. And this is the sewerage treatment plan, which we have in Aizawl. As I said, we only have one treatment plan, and it is 10 MLD, constructed under this ADB funding through Mahua. In this slide, I want to stress that yesterday also we talked about, as we see it, the sewer line connection comes to be around 57 crore out of 80 crore. And the construction of SDP, it comes out to be 27 crore. That means 30% of the total project cost, only 30% of the total project cost is used for the SDP. And at the same time, 70% of the project cost is for laying of the sewer line. This is the special nature of hilly region. I think so. Other hilly cities, our neighboring states, as well as some hill cities also, they will be like this only. This is the picture of that STP. Yeah, this is our special nature. As you see in the slide, yeah, to maintain a good gradient, at some places we have to elevate the sewer line, and at some places we have to dig very deeply. Some sewer lines, I was told by the project director last night that it may be around even 5 meters deep below the ground. This our special nature. Yeah, going to the issues and challenges. As I said, laying of sewer lines is an issue in hilly terrain. Everywhere it will be. Also, as we discussed yesterday, land issue and narrowness of road in a hilly area is a problem. Yeah, most of the places we have to follow the alignment of the road. We have to dig a sewer line along the roads, at the side of the roads. Since the existing roads in hilly areas, we cannot have a wide road. Therefore, this laying of sewer line is a real issue. And also, I discussed with some of our CPA CEO officials yesterday that due to topography, I think so almost all the hill cities are a combination of small hills. In between hills, there used to be a low-lying area or a kind of stream. Streams are there. Therefore, like in Aizawl also, as per our calculation, to have 100% what we call sewer line connection, we need to have at least 4 or 5 STPs. This is our our peculiarity. And this is our plan, our strategy and plan. Under Swachh Bharat mission 2.0, it is proposed to take up FSTP for 28 urban towns in Mizoram. We have 28 urban towns. It will be addressed through SBM 2.0 so that they will be having FSTP. And at the same time, for AMRUT cities, there is a provision as per the AMRUT guidelines. We have to have sewerage and septic management project. For that, we propose to construct small ball sewer system, which we listen in the morning, with a capacity of 3.5 MLD for the western parts of Aizawl. That the STP, the existing STP which we have, is for the eastern side of Aizawl. And this coming AMRUT, under AMRUT, of course, the capacity is 3.5 MLD. It will be installed or constructed in the western part so that it will cater the western population. And also at the same time, we will be constructing FSTP of 0.3 MLD at 2 sites so that our private dislodging operator could bring their sludge and it will be disposed of in a scientific manner. Yeah, and that is all my presentation. I hope so. I won't be spending more than 5 minutes. Thank you.
No question. Let us. अभी थोड़ा सा. Thank you very much. Actually, JS ma'am has already arrived here, and she has some other engagement also. So because of that slide, we have to we are readjusting her time to interact with you people and get direct feedback. So what I am suggesting, we will arrange all these things like that. We will break for lunch. And after lunch, maybe we will give 45 minutes. Within that, this time, please take lunch and come quickly. Exhibition ke liye we are giving 1 hour time so that it will be a guided and you people can get direct feel and interact. Within that 15-20 minutes, it may not be possible. So 2 to 2:45 pe I will be starting my presentation. So before that, please be seated. Otherwise, some portion will be missed and we have come from such a long distance, we have to utilize. After that, 3:30 to 4, one very important presentation from Israeli embassy is going to be done on online. So that is 3:30 to 4. and 4 to 4:30 JS ma'am will interact. So some of you who have matlab aise credible some of the points where it appears ki okay fine and that level of help is required, that can be raised. If some of you can share your experiences also how this has gone, another thing. And after that, after our interaction, Mr. Rajesh will be briefing you tomorrow program 5-7 minutes, and we all go and they will arrange on every that exhibition what they have put there, and they will guide. So this is program for today. So we request for a break for lunch.
Yes.
And be seated by 2:45. We'll start sharply.
So please come back by 2:45. As I said, the exhibition will be there till actually in the night. So we will get a good amount of chance to interact there. So you're all requested to quickly have your lunch. Thank you very much.
Sir, right there, please, sir. What is, sir? Hello? Hello? ಬರ್ತಿದೆಯಲ್ಲ? ನಮ್ಗೆ ಕೇಳಿಸ್ತಾ ಇದೆ, ನಿಮ್ಗೆ ಕೇಳಿಸ್ತಾ ಇದೆ? Hello, mic testing. All right.
Sir, up please. Whoever has finished your lunch, you are all requested to come back.
Yes,
Sir,
that's
we can
good.
start, sir. Thank you, sir.
So, very good afternoon in this post-lunch session. Given the tight schedule, I think we don't have any other option but to start the next presentation because maybe few people who are just about to finish their lunch, they will come and join. So again, I will greet you all in this post-lunch session, and this is presentation on one important aspect to specifically guide our ULBs and other stakeholders and those who are implementing this used water under SBM2. This ready reckoner is on municipal used water treatment for small and medium town and fully aligned with SBM2 guidelines. So this is going to be very important because the treatment is very crucial part of this used water management. And the more that challenging thing is what is how to select appropriate technology which is suitable to given local ULB's condition, their health and geographical and other requirements. So these things I will be quickly covering that. Next slide, please. Yeah, here itself I would like to give you a feel that what all we have content here. If you see that content, the trend of adoption of used water technology, some glimpse we have given nationally and internationally how these countries has developed, because ultimately at some point of time we will also be aspiring, and regarding standards also. Okay. No problem. Here I would like to mention that apart from that, why the necessity for ready reckoner was there and how we have customized, giving all those salient features so that not only engineers, even all those people from the even PMU, from other agencies, or even from, let us say, administration angle, they can understand. So it has been kept very crisp, and as a form of fact sheet it is given, duly giving that layout, and also that even standard designs are also given in some of the cases. So that will be a very good guiding factor. And apart from that, as far as technologies are concerned, we have segregated in three parts. Some nature-based technology which will be, we are recommending, that will be good for smaller towns, like let us say waste stabilization pond and even constructed wetland where very minimum energy is required, and even in low piece of land also some of these constructed wetland and other thing can be done. So that is one thing. Then regarding that mechanized treatment technologies, here aerated lagoons, activated process, extended aeration, SBR, all these technologies are kept there along with all silent features, that they are what is primarily land requirement, cost, and what is time of construction, and even the power consumption, all those things including O&M cost is given. And then the important thing that is included here is combination of technology. This is, I find increasingly that we have to work on that. This minimizes the whatever the available whatever the revenue required, or whatever, let us say, fund required for implementing and maintaining that. So combination of treatment technology we have put. Apart from that, these three options, as we mentioned, there may be a number of drains also some places, and other options are also there. Everywhere treatment plant may not be feasible. So even on-site treatment facilities and related technology also we have put, whether it is in-house or maybe for a small community or even in decentralized manner or even centralized. All these options we have given. So even from a 5% in a house to even 100%, 200%, yeah, 1,000, yeah, 10,000, 1 lakh, all options are available here, and you can get that. Even in few cases where let us say in intervening period it is taking time, or very little pollution is there because drain has flown along for a long time. So this inline treatment of drains also it is mentioned, but it is a incomplete. But till we are not doing complete solution, at least let us reduce pollution, because that objective is still met with. And when we are ready with robust system, that we can do away with that. So there is also some guidance given. And apart from that, this important angle of core treatment, I think usme lot of clarity is there. Usme I need not to tell much. Simple things, whatever options are there, that is also given there. And criteria for selection of technology, that is an important thing. And after that, followed by some actual case study we have given. Some of them are obtained from ULB, some of them are obtained from vendors. यहाँ आप लोगों को थोड़ा सा while adapting, we recommend that 1 or 2 can be let us say do piloted in 1-2 cities, and after that report and further let us say visiting some of the plant and discussing, decision can be taken, because their supervision monitoring sometimes may not be so extensive that we become 100% confident. So element of things is there. Next please. So these 2 things are there, as I mentioned: provide guidance on STPs, especially suiting to a smaller ULB, and selection of suitable technology. And also this will help in preparation of DPR. In many cases, we have included design also, cost also, even that can be put. And since those cost and other thing we have taken by collecting information on executed whatever plants are there, it is not only on schedule of rate. So it will be definitely on higher side, and more I think will be matching the requirement or whatever the contractors are going to quote and see that. So that option is there. Next please. Yes, here different technology that is being used, that is also mentioned, but here I wanted to highlight here that most of the treatment technology has come in larger cities, and from last 4-5 years when that things arise out of honorable NGT order, more and more people are taking these mechanized sort of things. So that was there, especially in larger cities. So alag share and other things are there, that is given for feel. So ready reckoner total it consists of only 50-60 pages. So I recommend, even if you are moving in flight, many things technologies may fact sheets are repetitive. All need not to read 1 hour, 2 hour you can read, even you can download here while returning you can read that. It will give ample idea. So that is one good thing. Next please. This is one slide we have taken from CPCB report, that is regarding that operational and utilization. The very thing that we have been mentioning, that earlier we were telling that let us project for 15 years and then prepare STP, and later on we find that houses are not connected, flow is not coming, and keeping all these things and also the priority, we are now suggesting that to optimally utilize resources and capacity, prepare, set up STPs at most as current population, or even where you find it is more flat and it is distributed, even 70% of current population you do. And after that, wherever requirement arises, we are also there, state is also there. I don't foresee in near future shortage of funds the moment we are proceeding towards that. Next, please. Yeah. In this case, many times we have explained, and again I would like to mention, like you heard here in case of Bengaluru also, that 20 BOD their norms they are following. Still for the time being you follow 1986 standards, except where the State Pollution Control Board has given some direction, and if they have certain suggestion, of course that can be sorted out. But मेरे को ये लग रहा है कि if sincerely these things are taken and pollution load reduce, in between lot of discussion and efforts are going on to rationalize level of treatment, so that issue will not be there, that problem will not be there, and I don't think anybody is going to penalize for that. Only it is a matter to take in confidence and tell that which way we are proceeding and how we are optimizing whatever the resources are there. Plus after treatment, we are not going to pollute water body. We are reutilizing here and there, or whatever agriculture field or whatever things are there. So I think this thing is not problem. Even you can take BOD up to 30, and that TSS and other whatever is 1986 things are there. So isme meri समझ से, and always take in confidence State Pollution Control Board, that will give you strength. By properly discussing with them, they will realize, and even you mentioned what ministry is telling, what things are going on. I think, and at point of time, even we are also thinking that with the State Pollution Control Board, some point of time, if become feasible, we will also hold a meeting with them so that we try to align with them. Next, please. This one slide I wanted to add because whatever the things we studied in case of Brazil, that is on same climatic condition. If you see 0 to 2000 population, even 25% of total STPs are set up there. Matlab total 2800 STPs they have set up. Out of that, 25% is 0 to 2000, 2000 to 5000, another 23,000. So less than 5,000 population ke liye total 1400 STPs are already set up in different. So as yesterday also I mentioned, it is not that small or big, it is that out of available resources, how you are prioritizing. Everybody need pipe, sewer, and close conduit to convey their health, welfare being. All these things has to be taken care. If you see in case of more than 1 lakh, only 4% are there. So keeping in view and the trend that is originating and where we want to go, this is the right time to plan and accordingly provide all the things. You think in a 20-30,000 population, if you are going to provide STP and these things is going to be collected in a controlled manner, and all road and everything is, let us say, not wastewater or level and no mosquito and other, how people will be happy? What is the level of positivity? That will be a great thing. Next. This one thing again from the Brazil, if you can see of your own how these things have been distributed. Most of the thing, if you see USB plus different combinations they are giving, all these things, this is telling that to within available resources, how we can utilize maximum and what type of things we can set up. And of course, city to city, there are somewhere constraints, somewhere other thing. Those things have to be properly seen. Here we are giving doesn't mean it is bounded for each and every city. All the final decision is in hands of local engineer as per local site condition. These are all guidance thing and providing you with options that see these options are there. Out of that final decision you have to take on the real front at the ULB level. Next. This one thing we have put for Germany also, where they have reached. If you see from 2019 to 2017, from 72% to 94%, they have reached to tertiary, and 95% their houses are all connected with sewer network. So they are at next level, but next level someday they might have started. And since we are making a thing that how the developed people have done and where they are there, so I think it will help because step by step we have to increase. So let us have robust planning and accordingly proceed with a vision. Next. These are the information we have kept for each technology: general description, fact sheet, process flow, photographs from site layout, unit sizing, combination of these things, and case study from different parts. These are the things that we have given. Next. This is general description, like in case of what the process, suppose a administrator is there or we don't have time or somewhere. So only by reading you will understand what activated such process do. Rest detailing the engineer will do or whoever required to do in detail. So it is giving a clear picture what this ASP is doing. Like in principle, ASP consists of main ditch component, aeration tank. So you will get a feel what it is there. Next, please. Yes. Now this type of fact sheet we have given where not only process and units are mentioned, also land requirement is also given, then energy requirement is also given, capital cost range is also given, then O&M cost range is also given, effluent quality be how much and where it can get. Of course, case to case, it is depend on influent, and then advantages, disadvantages, then what are the O&M related requirements and the challenges, then plant ka examples also some are the given, so that it is not mere some suggestion. Any one of you can make a plan, visit that and visualize ki yes, this is the thing working there, and we can get a feedback and then implement. And sludge generated, those aspects are also there. So such type of this fact sheet is created for each of the technology. Next. These are some of the photographs are also built so that we can visualize how it look like. Next. And then this important process diagram is also given, right from, if you see bar screen, then equalization tank, then this aeration tank, and this clarifiers and other things are there. So wherever, even in the morning there was discussion, and because of paucity of time we could not mention, wherever this fresh sludge and most of the cases from septic tank it is coming, that will be able to take care. If you put in equalization tank, that will be fine, or even if you find that on regular interval somewhere it is being done, even that can be put directly also. That impact will not be there, but it has to flow slowly. It is not that because I have to pick up cover another house, so immediately dump and went. No, rationalize that flow over half an hour or maybe something. You just decant that and go directly. It can be feed. Then for that another infrastructure is not required, but it should not be put in one go, putting shock load, and then for a small capacity there may be some problem. Larger capacity ke liye there is no issue at all. Right. Next. This similar type of layout is also given, that let us say from that this screening chamber, grid chamber, partial flume, settling tank, then aeration, then secondary, and these things how it is settled sludge drying bed. So you will get a feel of the picture ki how this thing will look like, and in the ground how is going to be done. Even that dimension also some point of time there we have given tentatively. We have summarized that what type of land requirements should be there. This thing is also there directly, you can see, and it can be accommodated. Next. This is some of the things. Unit size we have already designed also with help of experts, like primary treatment, screen chamber, grid chamber, partial flume, they are all standard. Secondary, another thing, maybe dimensions, another thing we have given, so that you can get an idea that how much land requirement will be there and what different unit they account for. So this sort of help will be there. That is something like between manual and what we are implementing. That sort of help we have tried. Next. Yes, and similar line, other technology and documents I will be mentioning. Yes, go to next one. Let us say the nature-based technology like waste stabilization pond. This is already given. Then similarly, root zone. In each of the case, whatever I have told about ASP, similar all information is given in case of all of these, all technologies. Next. Then some of the mechanized things like ASP we mentioned. Next. Yes, this extended aeration and sequencing batch reactor, inke baare mein bhi these photographs are given, and similar all information is available there. Next. So this mechanized treatment again, moving bed bioreactor and trickling filter. One thing I would like to again emphasize regarding these 4 technology, whether it is a waste stabilization pond, abhi constructed wetland, aerated lagoon, and trickling filter, they have been the very basis where these treatment things emerged. But somewhere we were not disciplined to properly operate and maintain. So we put blame on this and went to higher end technology, or somewhere it is, let us say, influenced by, or let us say aggressively marketed by, or whatever information might have come, we ceased to that. For smaller towns, these things with proper SOP ke saath, if you implement and monitor, they will be giving fairly good result, less land requirement, and also the used water and other things they can be used. So these things do not leave as it is as a obsolete or old. This is a very important foundation stone, or let us say first step in moving in this direction. And this is what we can easily afford and do that. Over and above, if somebody is confident and they are giving with a contract apart from implementation 5 year, 10 year, they can go. Usme absolutely, there is no such restriction, right? Next. This is another USB. Like similar thing, even USB ke case mein many time I read that it is not performing, but what we could see, and if it is properly maintained, it is working and properly working. If you go in Gujarat, they are there from Baroda, and almost of the cases it is available after polishing tank. Even they are generating power also to meet that requirement. But those where finances is a problem, in those cases they want high-end technology, because they are not disciplining or aligning their work that how we should do in disciplined manner. So that is one thing. Next. This is standard layout of that. Again, if you see, apart from screen chamber, this parcel flume, USB and polishing pond and other things are there. So like that it can be done. Yes, next. This example of USB plus polishing pond, how a combination works, that design is also given. Next. Then this is an important comparison that is given in one go, that apart from waste stabilization, root zone aeration constructed technology, then extended aeration, their land requirement is given hectare per MLD, capital cost is given, O&M cost, electricity, and then effluent. Of course, influent we have taken there 200 and something, 200, 250 we have taken. So if you see, it is already, if diluted, which is in most of the cases, these things will be giving even less than 10 BOD. Like in the morning, the very basis for this, let us say, higher end technology was that even ASP is failing, USB is failing, oxidation pond is failing. But in city like Bengaluru, where you are sitting, you are finding that ASP can give even less than 10 BOD. So none of the technologies are like that. Let us say, hum kah sakte hain ki very inferior. It is only a matter that you create an institutional thing so that it is properly operated, maintained. Result will be there in all the cases. Next. Then this decentralized treatment systems, they are also there. Somewhere, if really there is a constraint of land, those sort of options are available, even below that park, even below that parking, those sort of technologies are also available. But those things definitely, if we are doing some concrete structure, other thing will come, it will cost will go up. But you have to trade off whether taking a land is economical and constructing, or going below and with RCC and even whatever public land is available, within that we have to construct. These sort of things are there. Even some of the technology below the road, below the parking place also it can be done. So all sorts of available, all sorts of options are available. Land is not a constraint. You have to only select out of that, prioritize, and go ahead with that. Next. Then these on-site sanitation, many options are there, but one thing that was very widely followed in Japan and here in India also, it is coming in a let us say significant way. This aerobic on-site sanitation or Jokaso sort of system that can also be put for individual house or a group of houses, and this can also provide exactly just like treatment plant. So where land ka issue is there or somewhere, these options can also be seen. Next. Then on-site sanitation system, as I mentioned, especially suitable to SBM2, where main drains 2, 3 you are let us say intercepting and treating, that is fine. Over and above, the natural question comes, what to do with smaller drains? Smaller drains, two things. Okay, those who are having very let us say little flow, they are not potentially polluting. Even if you live somewhere, it is going percolating, it is working as a soak pit. If you wish, as a proactively some community soak pit and other can be provided. If some more flow is there before community flow, community soak pit, even just like a graded filter can be provided so that in between it further get purified and do. So this sort of options can be done, and definitely it will give pleasure to city. Nobody will find that used water is lying here and there and mosquito and all other problem. It will help to do, and these things will not cost much. I request all of you, prepare standard design and circulate in 10,000, 20,000 towns. That can be taken ekdam in a standard manner. Usme need not to do any engineering. Simply they can take and do that. Even capacity is slightly more or less, absolutely it is not going to make any change. But it will save a lot of time, and there will not be any room to further deviate and think over it and waste time. Next. Next. Yes. Please go back, slightly go back. Yeah. This was some of the other things also we are mentioning. Wherever required some innovation, also this is the time, like we have been in case of solid waste. Here also I request you do some innovation wherever the smaller drains are there, and these even inline systems also wherever long drains are there, they can also be helpful in reducing pollution. So those sort of decision you have to take at the ground. Next. Then this co-treatment already we have mentioned. Next. This is the criteria earlier I mentioned. So accordingly, while selecting a technology, these are very simple things you consider and accordingly take decision that will be helpful. Next. Yes. Then some of the case studies are also included there. You can see that list: 1 MLD, 3 MLD, 500 KLD, 30 MLD. They are all on different technology and suiting to that. They are only in 1 or 2 pages. So they will be giving you very clear idea just for making an understanding. Out of that, of course, you are going to do your due diligence and going to take it for further implementation. Next. Next. Similar, these steps are also provided. You can check that in a planned way. If we are planning in our city, what are different steps to be followed, and accordingly, if you plan, I think that will provide a basis foundation to let us go ahead. And in this case, I would like to suggest, often in state government also there will be urgency, pressure that we have to show what progress we are making, other thing. So this thing can run parallel for some time. In between, something deliverable also should be done, and later on it has to be aligned. But in no case in very hurry it should happen some in haphazardous manner we are doing, and later on it is creating trouble. So this will be giving clear idea that what all should be done for these things. Next. This one slide we earlier collected from Gujarat Chief Engineer Sahab BC Patel ji is here. We collected information. Yesterday we could saw that it is in construction of STP, somewhere it is taking 6,000 to 18,000. Then in case of today, we see 4,000 to 7,000. Mr. Rajesh Pai was doing. This was the information we collected from the state, especially Gujarat. If you see whatever the 7-10 projects have been done, it was coming 6,274. But in this case, another catch is there. They are going on whole city basis in many cases. So that will also be one reason. Otherwise, if properly planned, what Mr. Rajesh Pai mentioned in the morning session, that according to requirement, plan in a combination, these things will come less than 5,000 per person. This is my gut feeling. So accordingly, properly planned, I don't think here also cost will be a problem. Next. These are all same thing we have collected from them here also. Another 2030 we have taken in 30 plants, 6,875 is coming, and STP it was coming around 3,002. This is similar to what we have adapted here. But one thing here I would like to highlight. One thing we have to keep in mind that I am telling example of Varanasi. And that is going to save your cost. How it is going to save your cost? In 2008-9, we sanctioned plant, STP. Then because of some political reason, somebody was telling, no, it should not be here, or somebody is changing land from here. Then because of land non-availability of clear land, It took them 7 to 8 years, 10 years, then things were lingering on. Cost went double. But when administration intervened, earlier engineers were running here and there and some of the departmental people, but things were not materialized, it was in dormant stage. But when administration took into charge urban development department, things went to minister, honorable chief minister, then things just like in a sprint way, everything settled in only few months. Even court cases, everything also settled because things were pursued. And the thing which was pending for several years, within 8-9 months के करीब में 1 year के अंदर में these things were constructed. So only alone engineering support and even these let us say all other support is not enough. Administrative support is also very, very important. That has to be aligned and they have to monitor. Otherwise, delay on this part will cost on state revenue, because whatever project it has to be completed, so ultimately state has to result in paying. Next, please. Another thing is very important. When we do in disciplined way, you see, this is the case of Gujarat. When sense of that much urgency, I don't think the sewer network and STP 15 month, 21 month, 18 month. So all these our towns are smaller. These things even can be done 6 months to 1 year to 1.5. There is no reason. Isliye proper plan, proper select technology, and these things can be done. If there is apathy, okay, I have sanctioned, you do that, it will take 10 years also and still will not be completed. So that sort of things we have to see. Next. Yes, so this is all, and I think now I should stop. Question answer we will do later on. I think Mr. Leo will be there, or 1 or 2 questions. अच्छा हाँ तो 5 minutes. Yes, ठीक है. If yes, right. In case of in situ treatment, we studied what NMCG has got it done let us say study on 144 drains, and also CPCB has come out with certain suggestion. It was submitted in honorable NGT also. In that case, it is very clear that whatever this bioremediation through culture and other things are being done, their effectiveness is not as per desired level. It is ranging from 15% to let us say 55%. In best case, 55%, 50%, normally 40%, and in worst case, even 15-20% it is giving BOD load reduction. Apart from that, even the sludge and other thing that is settling, because it is some sort of working as a coagulation also, in between it is falling. That sludge is still depositing, and beyond the limit it will again start coming there. So that is something only for those areas, like some mela is there, something immediately we have to do something. Wahan to theek hai, but on regular system as a replacement, I feel that it will end up as a let us say fund spending program. Because it is very difficult to have control on those people who are doing. One day in front of you, they will put culture, and these are all, let us say, bacteria, another they will eat up. The day after that, they won't do. And so many things, even what they are going to put, all those things are not clear. So only in case of emergency somewhere, these things should be considered. Otherwise, many systems you might have seen, they can be done in 6 months, 1 year. So what is, when we are working sincerely, this is more than enough, and we can go ahead with that. So I suggest that this is the time to focus on these things, so that we start in new direction, new path, where robust systems are we are going to put, rather than doing this ad hoc system and only experimenting. Even I suggest such type of vendors को do not entertain. मेरे को ये लग रहा है ना, क्योंकि उस situation में ना, उस situation में they went and go and confuse. I have seen they are getting payment 2 crore, 3 crore for culture. What culture they are doing? The moment they leave, everything comes to the same place. And in the same money, if we have aided and provided a robust system, that would have last 20 years, 30 years. So these things को you have to keep in mind, and state पे अपना setup थोड़ा सा करके बढ़ाएं. I again request that 2-3 think tank people should be there, so that the goof up that has happened in the past, that should not be there. And let CPHO, your state think tank, and even at ULB level be connected, so that we develop year long and keep on evolving and guiding each other. And similar type of one conclave, I think we will definitely propose to ministry. If it is agreed, every year we'll try to do that. So this is there, and in this case, this is also there, that ample guidance is given how to do core treatment and other. And this is the reason, because if you give that option, people after a lot of persuasion, they don't understand in many cases, they want to perform or whatever the pressure is there, they go for FSTP. You do fecal sludge management, but stand alone ki jagah pe when option is there, why to do that? That's why under SBM2, we don't allow any funding. That is not there. If you want to do from your state government fund, absolutely there is no issue. So I hope this will be helpful, and you people can take a lot of help from that. So, yes, it is there. I will forward, or you can download also. It is available with me.
इसी थोड़ा ऊपर और ऊपर
Third
slide.
Sludge reuse may only I will mention that under this circular economy, we are working on that document, and now it is going to be taken at higher chief secretary level also to promote circularity. There, these standards and other thing we are in the process of developing, and already CPCB and NMCG, they have given to IIT Roorkee some task on its characterization and other. That I think is in final stage. We are constituting a committee also. So regarding sludge utilization and other, we will be very soon will be coming continuously. On many area we are working, but so many other works are also coming. So somehow in time bound manner, things are not happening, but we will try to help whatever possible, and whatever things have been discussed in each and every area, we will try to handhold wherever required. So with this, I thank, and I think yes.
Sir, very nicely puts the point about this people coming and trying to confuse. Yeah, bilkul pehle they'll come to the central government, they'll try to sell something to the central government, then they'll go to the state governments, wahan nahi chalega, they'll go to the ULB, and every time they're trying to confuse. This is not a too high technical requirement nahi hai. Hamara jo sewage management hai, it is very clear that 2 or 3 things have to be removed, and they can only be removed through physical, chemical or biochemical processes. और वो every engineer understands कि उसको आपस में क्या उनका symbiosis है, कि अगर हमारे पास हम पहले क्लोरीन डाल देंगे तो मास्किंग हो जाएगा उसमें, क्योंकि देयर इज सो मच सस्पेंडेड सॉलिड्स एंड सो मच बीओडी, तो क्लोरीन जो है बीओडी जो ऑक्सीजन के साथ रिएक्ट कर जाएगा, और क्लोरीन विल नॉट एक्चुअली किल द ऑर्गेनिजम्स, तो वहां पे है. इन केस देयर इज टू मच मास्किंग, so the polluting that is the pathogens, they will hide behind the solids, और उसके बाद वो हम वहां से हटा नहीं पाएंगे. तो एम इज वेरी क्लियर, पहले सेडिमेंटेशन करना है जिससे सॉलिड्स कम हो जाए, फिर एरेशन करना है जिससे कि हमारा जो those things can react in presence of specific bacteria, and finally once everything is removed, then we put in chlorine so that pathogens can be killed. तो वो जब सीक्वेंस होगा वो बहुत सस्ते में काम हो जाएगा. सर ने जो कॉस्टिंग दिया है, मे बी इट्स द मार्केट कॉस्ट, आई डोंट थिंक, बिकॉज वी मे हैव टेकन इट फ्रॉम द एक्चुअल टेंडर्ड कॉस्ट. कई बार क्या होता है, टेंडर्ड कॉस्ट में वो कहेगा मैंने इसके साथ बिल्डिंग भी बनाया, रेजिडेंसेस 2 कमरे भी बना दिए, रहना भी बना दिया, उससे कॉस्ट ऐसे ही बढ़ जाता है. अदरवाइज अगर आप स्ट्रक्चरली देखो तो क्या बना रहे हो, 3-4 कंटेनर्स बना रहे हो जो 2-3 घंटे का स्टोरेज करना है सबने, उसका आरसीसी का कॉस्ट कर लोगे तो आपको पता चल जाएगा एक्चुअल कॉस्ट कितना होना चाहिए एक ट्रीटमेंट प्लांट का. और दूसरा पॉइंट जो सर ने डाला है, ये जो हमारा दी स्टैंडर्ड्स हैं, ये 1986 के स्टैंडर्ड्स आर वर्ल्ड रिनोन्ड, मतलब इक्विवेलेंट टू द बेस्ट इन द प्रैक्टिस इन यूएसए एंड इंग्लैंड. अगर हम इसको फॉलो करा पाए तो हमारा कंट्री कैन ग्रो टुगेदर. इन केस वी गो फॉर वेरी स्ट्रिंजेंट स्टैंडर्ड्स, तो क्या होगा, दैट वी विल नॉट बी एबल टू स्पेंड द मनी ऑप्टिमली. मैं जरा एक पॉइंट देना चाहता, फीकल कॉलीफॉर्म का इसमें जहां नहीं लिखा है ना, तो बहुत अच्छा सिस्टम था. दे यूज्ड टू बी समथिंग कॉल्ड अ बायो एसे टेस्ट. मतलब सिंपल से था कि 96 आवर्स अगर फिश सर्वाइव कर जाती है 96 आवर्स तक, दैट मींस दैट इज सेफ फॉर डिस्पोजल. कितना अच्छा सिस्टम है भाई. मच्छी अगर जी सकती है उस पानी के अंदर, तो अब आपको उससे अच्छा पानी क्या चाहिए. मच्छी वेरी सेंसिटिव. आई गॉट एक्वेरियम, मैंने अभी 5 दिन पहले वो मच्छी का पानी एक्वेरियम साफ करने के लिए मच्छी को बाहर निकाला एक बाल्टी में और वापस डालने की कोशिश की, 10 की 10 मर गई, because they are so sensitive to any of these things. So just imagine nothing is going to happen to the environment in case we can do the bioassay test, but suddenly somebody says FC 1000 100 ये वो कुछ नहीं. So that is how these engineers have evolved over a period of time. Hopefully we can get it done in the cheapest possible manner, and the country can
Hi, hello.
कर देंगे sir. Sir, thank you very much, sir. I think Sasanka, I would request you to give a small token of appreciation to Russia, sir. Thank you very much for excellent inputs. Rohit sir, आपको भी ये please. No, you excellent input, sir. Thank you very much, sir. थोड़ा देखिए ना sir. Yes. Thank you, sir. Okay, so we'll go to the next session. I would request Chaurasia sir to briefly introduce Mr. Lior.
Yes, Dr. Lior, good afternoon and very much welcome. I hope I am audible.
Yes, you're audible. I hope everybody hear me.
Why? No, that.
Can you talk? Okay.
Yes, very good. So I firmly welcome you and thank you also because you accepted our request. And I remember the time we spent in Israel learning all those things and the energy level that you have shown and explained all the things. I do not wanted to miss at any cost that whatever things we learned, our people should miss in any way. So you are going to find a very interesting presentation. I would just give in a minute or two that brief. It is, as Israel, many parts of the country is having, let us say, very harsh condition, and even some of the things are water starved and similar type of problems are there. But with their vision and with their hard effort and given priority to the sector, they have been able to collect entire used water and then do those details he will be explaining. But please see this, or your thinking will be changed that in many parts of our area where we are thinking there will be there is no remedy. After each presentation you will find a solution. So these things ke liye I will welcome Dr. Rior and I request you to please go ahead. Thank you very much.
Okay, this the presentation is showing on the screen now. The presentation is on the screen.
It is visible.
Oh, excellent. Okay. So good afternoon, gentlemen. My name is Dr. Lior Asaf. I'm the water attaché in the Israeli embassy in New Delhi. My role is actually to working with the government of India in various level, in the central level, in the states level, and in the ULB, and to build a cooperation between the two nations around the water sector. I'm coming from more than 20 years experience of water project around the world. And today I would like to speak about what is the Israeli model, how we become sustainable in our water system, and what should be the application of the lesson learned that can be applied here in India. So first start with the need. So India is currently the biggest nation and the country on earth. And by 2050, you will be more than 1.6 billion people. And the big question and the big challenge is how India can supply the water needs for domestic agriculture, industry, and energy production, sustain economical development, and while doing that, do it in sustainable model. So right now, if you look at the big number, India, of course, is a larger continent than Israel, and still India, the freshwater resources in India are more than 4,000 BCM. However, the current waters that are within the system is almost 1,100 BCM a year. If we compare that to Israel, when we speak in only 1.2 BCM, so the big question lies what we can learn from Israel if the Israeli model is applicable to India. And my answer is to this, yes, the scale is different, the challenges are different. Of course, India is bigger, but some of the method and some of the, let's say, the management of water resources that we are doing in Israel can be applied here, even if the scale is different. So we need to look that what we do in national scale in Israel can be applied here more on what I would call area or states scale. So if we look at water uses in India, it's still most of the water are applied in agriculture. And if we look what is the contribution of India, so 18% of world population, but only 4% of its water resources. So doing that, India is still going to be a stressed water country. If we look at the actual reports that produced by NITI Aayog and another governmental agency, more than 50% of India faced high to extremely water stress. And this stress is going to be only bigger in the future because climate change predicts that we'll have less water available in the future. India, if we can look what's the water level in the groundwater change around the aquifer of this country, that sees that there was a negative impact. So in the last, let's say, 30 years, water table reduced in many of your aquifer, in many of the groundwater system. That means that if the water level are reducing, there is ongoing over sustainable use. That means that you use more water, the natural replenishment of this aquifer, and this process is only going to continue. And the predictions are not good for India. By 2030, that is actually almost tomorrow, India water demand is projected to be higher than the available supply. So all the issue of water shortages that are now, let's say, episodical, can come later on to be a very much problem for the entire country. India water sector is complex, and I will talk later on the Israeli water sector. India water sector is complex, divided by the central government in Delhi that control some of the long-term planning and some of the allocation, but still from the project per se, this is a state's level. And this is actually divided by several ministry. For example, the Ministry of Housing and Urban Affairs is under Amrut mission, is in charge for water supply and sanitation in urban area, while the Ministry of Jal Shakti have another mission to provide water for agriculture and rural area and for like other mission like the National Mission for Clean Ganga. So there is a divide both in the level between the states level and the federal level, and there is a divide between different sectors that influence the water sector. However, India is going to be a very large investment of money in upgrading the infrastructure of this country. If we look at the projecting 5 years project for the next 5 years under Amrut mission and under the Jal Jeevan mission and other mission, we can see that India will invest over $100 billion in government investment in the next 5 years. That means that hundreds of new STP will build, many cities will get tap water, many rural area will get tap water. For example, in Jal Jeevan mission that carry on in the last few years, until now, 96 million new households have been connected to tap water, and the projection that is we need completing the mission by 2024, almost 190 million households will be new connected to tap water. That means that it will be large investment. But I think the issue lies not only in the investment in new pipes, in new pumping station, and new water wells and connection, but how this system will be operated in sustainable manner. And if we look about comparison between the Israeli water consumption, we'll see that India, the factor is about 170 per area and 150 timefold by population. But if you look at the usable fresh water per capita, Indian in the urban sector use 3.5 more water, and in the agriculture sector, it's more than 8 timefold. That means the efficiency in the both urban and agricultural system in India are much less than in Israel. However, in Israel, you have a fresh water connection, a reliable, fresh and good water connection to every household, and it's safe water that you can drink from the tap 24/7. This service does not exist in India. I would like to speak more about our models. Israel have a small country, and we have a very big challenge because our supply of water, natural water, is very limited. most of 60% of the country have less than 200 millimeter of rain, and 50% that have rain, we don't have as much rain as in India. About 500 millimeter is the average. That means that it's a lot less water, and we are actually in a desert. So making the desert bloom was a vision of our Prime Minister David Ben-Gurion, and the limited factor for always was water. And what we did with water, so basically the most, I think, important aspect that the country water resources are public properties. That means that all the water, above ground, below ground, spring, stream, river, lake, reservoir, sewage, and stormwater are all the country properties. That means that even if I'm living in a house, I cannot drill a well and pump the water for my supply or for my field without the fully permission and control of the government. Second is that our water authority is since 2007 is one table for decision making, taking account all the stakeholders. The Ministry of Agriculture, the Ministry of Water Resources, the Ministry of Interior, the Ministry of Environment, all of them sitting in one room, taking the decision for the entire country, for the design, for allocation of the water, for pricing of the water, everything done under one roof. What we did in Israel, so we tried to solve our water problem, and in the initial stage, we were following steps of India, that taking the water from one part when there is supposed to be surplus of water in the north part of the country, from the Sea of Galilee, and bringing to the south in what we call the National Water Carrier, very similar to the interlinkage project. However, this method find to be that is not supplying all the water that we need. And we move to some other new system that include building a new system for reuse of wastewater, a new system for desalination water. If we look on the valuable water in the Sea of Galilee, that was a source of the water for the National Water Carrier, in the last 40 years, it's always diminished. That means that if today our national water system was supposed to carry on the Sea of Galilee water, we were bankrupt. We could not deliver this water. So if in regular years in the past it supplied 450 MCM, today it's only delivered 20 to 50 MCM. That means that the water are not there anymore because of climate change, because something happened to our natural resources. How we can come out for this kind of solution? So what we did and what you can see in this graph, this is how the total water allocation for change in the last 60 years. And what you can see that the average natural water recharge was around 1500 MCM. This water, for many years, we pump out from our aquifer, from the Sea of Galilee, more water than what was natural replenishment. That was, in fact, become a water crisis. And for many years, we have summer after summer, a lot of concern about how we can supply the water for the next year. Our level in the groundwater aquifer were getting lower, and it was a major risk for the livelihood of the country. So from the 19th onward, we decide that we need to take another direction. We need to take a direction to use every available of water and create main source of water, man-made sources. So in the beginning, we start from effluent. And effluent as a source of water. That means we took all our wastewater and start to treat it, and later on allocate it for agriculture. From 2006 onward, we start to supply water from seawater by desalinated as a major source from water supply for drinking water in our cities. And today, you can see that our 50% of our water allocation come from man-made source. That means that the states of Israel is not depending on the climate anymore. And even if we have drought, and even if we have dry years, river will be flowing in our tap water. And our field will be irrigated, because it will be irrigated by recycled water, not by water from nature that could be changed from year to year. How we did that? In addition, we have something very unique in Israel, the model that encourage that campaign for water saving. Public knows water are scarce. So we reduce our water consumption by two things. First, by campaign and education of the public and awareness. Second, by actually raising the tariff for water. Israeli public pays the full price for water. I don't sure that this will be the solution in India, but I think when people pay for water and the payment is allocated based on their consumption, there is awareness and there is reduction and the water are used more in the same adequate manner. So today, half of our water are coming from man-made sources, allowing us not only to supply water for our needs, but supply water for the Palestinian Authority and supplying to the Kingdom of Jordan. So we can still supply water to our neighbors, allowing us more political stability. So what was the policy? The policy was to take wastewater use as a national policy, call for the gradual replacement of wastewater allocation to agriculture by recycled effluent. And this done by water technology, by standardization and regulation, and by creation as infrastructures that allow the wastewater to go to the end user, to the farmer. And similar to that, we build another infrastructure that we used for desalinated water. And today, we are using the water twice. The first cycle in the urban center from desalination, and the second cycle after treated the water, taking the water for the agricultural field, sometimes 150, 200 kilometers away. And for example, this is the largest scheme in Israel that take all the water from the metropolitan of Tel Aviv. It's about 18 different municipalities, 2.5 million people, about 400 MLD today, and they're going to extend it to 600 MLD in the future, taking this water by a series of lines, separate line and separate reservoir that allow to irrigate the entire Negev desert by this water, allowing the farmers there to have a year-round agriculture that is not depending on natural water. Part of it is we called soil aquifer treatment. We treat the water to tertiary level by injecting them first to the subsurface and then pumping out the water, using the subsurface both as a reservoir, as a part of the treatment system, like a huge filter that perform both physical, chemical, and biological treatment. Municipal wastewater treatment today, we are counting about 540 MCM. 99% of the sewage is currently collected, 97% is treated, and is not 82%, today is almost 87%, that is almost reached 90%. We achieved this new standard that we based on a regulation by organic pathogens, metal and salt removal. We have a very strict regulation allowing us to divert the water between waters that go for irrigation that might be contained some phosphorus and ammonia and nitrogen that are very crucial for plant. And when we release the water to environment, we are having a more strict regulation on nitrogen and ammonia and phosphorus. And other regulation for agriculture is very important that we have all the different standards from heavy metal because they are going to through the food chain. So we use them as treatment as the source, at the point pollution source that are treated very efficiently in the source of them, mainly in the factory. So Israel built infrastructure. Israel built regulation. Israel built a vision that incorporates the reuse of wastewater on very large scale. And how this method could be a solution for India. And my vision and my answer to that is yes. Yes, you can. It's not a matter about technology. It's not a matter about resources. It's not a matter about very educated and successful managers and engineers. you have all them in India. What this country needs is a vision and how to implement this project on the ground. And I think one core principle is the efficiency of this water system. In Israel, there is no 1 acre, 1 meter of land that is under irrigation that is not with micro irrigation. In India, it's 20%. And this is a big, big difference, because when you continue to irrigate under canal system, so in canal systems, the efficiency is around 40%. In Israel, when you move to the change of pressurized pipe network, command and control system, you can achieve 90% efficiency. That means that either you double the area under irrigation on the same amount of water, or either you reduce your water consumption by 50%. And another key factor is that when you're speaking about reuse of wastewater, you allocate the water for agriculture by drip irrigation to the root zone. So that means there is no direct contact between this water to the plant or the crop itself. So allow you a very strict and very controlled health regulations that allow this water use for any kind of field crop. We grow capsicum, we grow tomato, we grow cherry tomato and tomatoes and a cucumber on this and lettuce on this water. So you can irrigate any kind of plants by using this source of water. So what is the way forward? I think the way forward is the connecting directly the STP to the farmer. It has to be by a network. It has to be by design and regional perspective. So it's not enough just to build a good STP, and you build a good STP in this country. You need to build the infrastructure and the vision to connect them directly to the farmer. And while doing that, you eliminate the uncertainty in generating stable, knowing water availability at the farmer level. And then, using smart agriculture and smart irrigation system, you can make sure that the farmer not only use good additional source of water, but they have agriculture year round, and they can achieve the vision of Honorable Prime Minister Modi to double the farmer income. That means that building the new infrastructure of India across the water sector, specifically in the wastewater, could achieve sustainability and could achieve economic developing on very large scale for the farmer. Yes, the farmer can never gonna pay the full price of this water, but they don't pay the full price of this water when they come from interlinkage project or from micro or big irrigation project. This is still will be the source of the government. By doing it in sustainable manner, with sophisticated technology, with allocation not only of EPC part, but ongoing support to the farmer, you can achieve and change how this ability is changed. And today, India reuse wastewater is very low, less than 5%, depend on the states. And even the reuse scheme are not always in the right track because you treat the water, and in many instances, and this, for example, from Rajasthan, when I was visiting a few weeks back, in Sawales, that is in around south of Jodhpur. It's a city of 1.5 million people. The wastewater go after treatment directly to the stream. They're not going to reuse. The reuse is done by farmer along the stream while by taking contaminated water from the river. So you put a lot of money to create a new water source, but then it's mixed again with contaminated water and go to the farmer an unsustainable method. So this is not a good reuse scheme that have to be followed. And this is how it's looking in the field. You can see that the water are very dirty. And after putting so much money in creating a good STP, I think it's a little bit of waste of funding to put back the water back into the river. Of course, it's better than not to treat the water at all, but still you can do the extra mile and connect directly the STP to, so for example, this is another place that we might want to push a new water supply for a farmer in Ahmedabad. So the long-term vision of the city is the reuse of entire wastewater, taking almost 80% and bringing to agriculture land across the city. We probably start with a demonstration project on 100 MLD or 50 MLD, but the vision is to create how you can irrigate in large scale and create and connect the farmer community in a belt around your major city in anywhere in India to a safe and continuous source of water that allows the farmer community to flourish anywhere in this country. So I think what is important that we look in a way to achieve sustainability. Sustainability is not only by efficiency, it's about the way we can mitigate climate change and shortage of water across India. And I think this Israeli model that we apply for 30 years shows that this is achievable. You can do it in a sustainable manner. You can do it in a good practice. And it's need to be considered that every new STP of this country should have to plant a reuse scheme. And when it's done, today you're treating only the total capacity of the wastewater in India is 67,000 MLD. Today, about a third of it is being treated. Reuse, very limited. If you can look at as a way forward to uplift farmer community, you will be in a position not only to build a better water-saving mechanism, but allow the community of the farmer across this country to have a sustainable future, have a secure future that is not going to be dependent on the outcome of climate change or water shortages. So I think the big challenge, how we can transform technology. Yeah, I will finish in 1 minute.
Conclude now.
Yes, I will finish. So it's include technology transfer, private sector, and some ways to build this in sustainable economical model. And I think when you look at some of the models that already finance model here in India, I think the HAM model, hybrid annuity model, and design, build, finance, operation transfer model should be adopted, allowing a long-term stability for this kind of project. And it has to include both project finance, capacity building and long-term supporting for the agricultural community, and project developing in the best engineering practice. So I'm sure that this could be achieved here in India, and Israel and the Israeli company are here to support the government of India in all these verticals. So looking forward, thank you very much for this opportunity. Thank you.
Thank you, Dr. Leor. Just for your information, I will repeat here all senior officers, especially chief engineers, state mission directors, and senior people who can influence that policy making, they are present here, and they have listened you that message and all other things, especially that long-term vision for the city. That is very important. Climate resilient, even in that harsh climate where scarcity of water is there, they are growing, increasingly becoming, let us say, water resilient. Nature pe their dependence is reducing, and they are making like their cities like that. Apart from that, even through proper restructuring in form of a water authority, all decision making and everything has been expedited, priority and other things are taken in a very, let us say, efficient manner. Plus, their used water sometimes is recycled 6 to 7 times, and ratio or rate is 82%, and I think they are planning to reach up to 90%. We are less than 2-3% as a things. So as Dr. Leod mentioned, that many areas are there where we can start and get, let us say, we cannot be dependent on water, only these used water, like cities like Jodhpur and other things are Bundelkhand Bundelkhand. This will be very, very helpful. And I got more, let us say, impetus and confidence because I visited and with my own eye, I see the way they have transformed, and the thing where I was thinking everything they may be importing, whether vegetable, food, and other thing, but it is otherwise they are exporting vegetable, they are exporting food, these fruits and other thing. So thank you very much for making time. All our city officials, states at some point of time will definitely be in touch with you, seek guidance, and wherever your experiences will be helpful, they will do that. So with this, I welcome. We would like to hear you even more, but some JSMM ka tight program is there, so you have to live right now for some time. That's why we rescheduled. But in between, if some of the officers, if they are willing to have any query or question from Dr. Lior, so just introduce and you can ask 1, 2, 3 questions we can take. Okay. Thank you.
Thank you.
Anybody, if they have any query, any question, they can raise. 1, 2 questions we can think.
My name is Prasanta Mahapatra. I am the engineering chief in Odisha Water Supply and Sewerage Board. My question is related to the agricultural use of treated wastewater. We are struggling to find the reuse of wastewater in agriculture sector mostly, because we have abundant of canal water and groundwater. So what can you suggest to us so that the use of treated water in agriculture can be enhanced?
Okay, I think the main issue here is that yes, canal water are there sometimes, but usually the canal water are very seasonal. That means that you get them only for certain amount of time. And usually the canal water come to villages maybe 1 and 2 weeks, 1 in 3 weeks. So that means that water allocation is not year round and it's not sustained. And in many regions, the canal water sometimes change and are not there anymore. I think that in long-term vision, yes, wastewater cannot replace all the agricultural demand in India. Of course, you will need to supply still through traditional system of groundwater and surface water. But I think at least in around the urban area and at least the urban community, wastewater could be the alternative to build sustainable approach for water management. And second, I think when it will come, the project should come with advanced agriculture. So that means the benefit is not only assuring a safe water source, but coming with advanced agriculture that can be the change point for the farmer.
One more questions.
Yeah, good afternoon, sir. My question is, what is the general capex part once after the treatment till it reaches to irrigation? And second, what is the tariff you are charging to farmer?
Okay. So in Israel, there is a tariff that is quite high, and there is a difference between the tariff of fresh water and the tariff of wastewater. The difference, sometimes it's quite sustainable. That means that the farmer pays 2/3 of the tariff of fresh water. And once again, the tariff here in Israel is a lot more expensive by comparing to the India. But I think this is not the breakpoint. The breakpoint is that you invest in infrastructure. You build irrigation system on very large scale that cost a lot of money. Farmers are not paying for this infrastructure. So that's in the same way, it's more about augmentation or making together different sources of revenue from the subsidies of drip irrigation, from the irrigation budget for micro irrigation, and from the budget of wastewater. The issue here, how you combine and build it in sustainable approach. And I think if you take into account the angle that it's not how you pay for the water, is more about how you reach a stable farmer income. And I think in this regard, this is the right approach, because the farmer will never pay the full price of these services.
Thank you, Mr. Lior. Thank you very much. And definitely we'll be in touch, and whatever technical support guidance will be required, we'll keep on taking that. So thank you very much for sparing time and coming and interacting with our people. So thank you very much. Now we will start with other program. You can leave. Thank you.
Thank you very much. Namaskar. Wish you all luck in your.
Thank you. Thank you.
Thank you. Bye-bye.
You would like to.
Okay.
No, it is done only. Yeah. वो चीज में एक बार करके बता दें। Ma'am, formally I welcome on behalf of all participants. These 2 days has been extremely useful. Even I remember many times in between, I remember that initially it was planned as a regional for 6-7 states. Later on, as per your visualization and intervention, it was made for let us whole country. Everybody came, and the duration was also such that they can intensively discuss. The deliberations result, I can see it is more than our expectation, what we see. And it is not only I am telling, you will get definitely they are going to interact, and they will tell at any point of time, whomsoever I am discussing, they are finding that many doubts, many things, and even to firm up their view how to take sewage management in a city. All these things, they are getting lot of clarity. Even many other things, components like even cost-wise technology selection, then planning for that city in a long-term vision, sustainability, all these things, they are getting even I will say the detailed SBM related approach that we are following, that was discussed in very detail. I made a detailed presentation and interaction was there. After that, Mr. Sasanka made a presentation based on that and in a very questionnaire form. It was an interactive one, that what you need, where, means only it was coming, if you want to do this, what you have to do. So it was putting pressure on their mind to think that if I am going to complete this task, then what I'll have to do. Apart from that, in the morning today, Mr. Rajesh Pai made a very comprehensive, customized presentation that was related to in a city, how to plan so that it is economical and it is doable also. Normally, either people don't do or they do on whole city sewerage system and STP, so that is very cost ineffective. So he suggested out of 4 options available, in some part it may be sewer, other part it may be IND, other part it may be on-site system, and like that. So this combination and these other on-site, this fecal sludge management, everything combination of that. After that, just to clear doubt in very detail, this fecal sludge management, how it can be done in an economical manner, that thing was also very clearly explained, and at very forum here and there also we have been doing that. Apart from that, this online or IMD based system, which is a component of our mission, that is also taken care very well, that Mr. Ganpati, they made one presentation. And after that presentation, we have interaction with the states. That is extremely useful. Many things you will also see that just now we have seen this Lior presentation. We were not aware Haryana is doing as good as Lior. Matlab Israel is doing, because they have policy to properly collect, treat, recycle, reuse, and none of the things will be going sustainability. All sort of good things they are doing. Similar other states also presented. They will be interacting. Apart from that, on that ready reckoner, we brought a customized document to guide them technology selection and other thing that I presented. And this was another Mr. Lior, a long-term city vision, and then many times recycling it, making these institutional setup, then authority to let us say faster decision making, fund allocation. All these things have been done. So now we have come that this is time they will get a chance to interact with you and give direct feedback. And after that, we will be taking them in an organized manner to exhibition for 1 hour we have keep and brief about tomorrow program that how they are going to do field visit. So this is all about, ma'am. If you permit 3-4 states, they can tell their experiences. And after that, you can ask also anybody also. So maybe 3-4 states like let us say Jammu Kashmir, Haryana, Odisha, or UP, or any particular one of them can come and tell that yes experience.
Good afternoon, ma'am. Ma'am, I'm Shailendra. I'm Chief Engineer from Haryana Public Health Engineering Department. Ma'am, first of all, I'll welcome you and congratulate the organizers. It was a very extremely knowledgeable and wonderful seminar that is conducted over here, and we have learned a lot. First, I'll briefly tell you about Haryana. Present generation of sewage in Haryana is about 1500 MLD. And we have 170 STPs and CTPs of 1900 MLD capacity approximately. So we are surplus in the treatment capacity, and we are for future also we have taken consider. Then, but the sewage reaching our STPs about 1300 MLD. So there is a gap. All the sewage generators is not reaching our STPs. And we have done good work in using treated wastewater. Like we have our treated wastewater policy has been notified in the year 2019. We have targeted some small targets like by 2022, we had to achieve 25% of the wastewater to be reused. And then by 225, we have targeted to use about 50% of the treated wastewater, and by 2030, 80% of the treated wastewater. Presently, we are using 15% of our treated wastewater for reuse. And it is basically in agricultural sector or in construction activities also, like in the city of Gurugram, where a lot of colonizers have come up. So we have made it mandatory to use the treated wastewater. The things which we have learned, ma'am, first, there was a lecture on nature-based technologies, and IIT Bombay, the professor, he told us about the incremental approaches which can be taken for nature-based technologies. Then we had a very good insight. Yes, surely, ma'am. Ma'am, for Haryana, like 80% of our canal water is being used for agriculture purposes. So what we are planning is that we have divided our STPs into 3 phases. In the first phase, which has to be completed by end of 2024, we have identified 35 STPs, and we've conducted the feasibility survey, and about 27 STPs have been found to be feasible. And we have done the tendering also, and about 16 STPs, the work has started. And 3 STPs we have already commissioned, and we are using treated wastewater from those STPs to the agricultural sector. And we have constituted wastewater user associations also amongst the farmers who are using that wastewater, and they are using it through micro irrigation, like drip irrigation, and sprinkler system have been installed. But in Haryana, ma'am, generally because canal water is being used, so they are habitual of using flowing water for irrigation. So it is a challenge for us to make them use through drip irrigation and sprinkler system. Then in the second phase, we'll be taking about 58 STPs, and the project has been is under consideration, is under development for those 58 STPs, and we are targeting it to be completed by 2025. And in the last phase, ma'am, remaining STPs will be taking up. So this is, we are primarily targeting to use it in the agricultural sector. Then in major towns, like in Panipat, Hisar, where thermal power plants are available nearby, we are targeting to use that water in the thermal power plants and in the construction activities as well. These Ma'am, we are interacting with them. No, they are not very much keen to use our treated wastewater, but we have hired a consultant and he'll be preparing a DPR and we will be consulting them. Ma'am, they generally say that because using this water in the boilers and all, the treatment standards are to be very strict and very high. So they may use our water for cooling towers, but for using it in the boilers and etc., we have to adopt very high standards of treatment, ma'am. That's all, ma'am. Thank you so much.
Thank you, sir.
Thank you.
So now I would invite Mr. Nazir Ahmed Kakuru from J&K. He is the Chief Engineer, Urban Development.
Good afternoon, madam. Welcome to Bangalore. Thank you very much. So, good afternoon, ladies and gentlemen. I'll just give an overview of what we are doing in the sewage sector and what we are up to. In fact, our sewage total generation is at 523 MLD. Installed treatment capacities are of the order of 140 MLD. We have 15 operational plants that are fully compliant. Gap in sewage treatment as on date is 383 MLD. Treatment capacity likely to be added by 2023 is of the order of 92 MLD. And with this, we'll have a total deficit of 291 MLD. We have proposed projects under different schemes. Our 21 projects with 28 STPs aggregating 122 MLD are under CAPEX. Amrut 2, we have also tried to have two schemes of 30 MLD and 20 MLD capacity addition. And we had a problem of underutilization of some of the plants in Jammu region. We have tried to bridge that gap by having two schemes in the Amrut 2 of house connections. Our urban sector, our urban structure is like that. We have 2 municipal corporations, 2 cantonment boards, 57 municipal committees, and 19 municipal councils. It all means that we have 76 urban local bodies that are to be covered through SBM Urban 2. And in that, we have already covered 1 Anantnag district under Amrut 2 and 1 Udhampur district having Devika, this pollution abatement. So consisting of around 13.6 MLD through NRCP, National River Conservation Plan. So this is going to be completed, this scheme, by March 2023. Our future projects for bridging the entire gap is through JICA. 75 MLD of sewerage schemes in Jammu and 125 MLD sewerage schemes in Srinagar are going to come at a cost of 1,250 INR in crores and 1,302 INR. The centrally sponsored schemes, we have this Udhampur town, 13.6 MLD is coming up, and 60 KLD STP is also coming up for this. And then this scheme had also one of the components as the beautification of Devika Ghats and creation of modern crematoria also. That is over, and we have already handed over the municipal committees. The beauty of our 2 cities, main capital cities, is that these are founded on the banks of rivers. Like the Srinagar is on the 2 banks of River Jhelum, and Jammu is on the 2 banks of River Tavi. Yeah, we are just to give an overview that where we stand. So we have tried to do zonation for these areas, major to urban local bodies, and these zonations have been. We have attempted core service areas. They have been attempted, and usme hamara we have almost completed that. The balance on the left side of these banks has been proposed under bigger this funding modalities like this JICA. Under NRCP, we have 4 number of projects that are expected. One is in Jammu region, The second is the Banganga Katra town, and 2 others are in Srinagar city. Then there we have a program for installation of OCMs also for our operational and compliant days as per CPCB directives. Then just I want to have 2 or 3 quick suggestions here based on the experience that we got in dealing with the preparatory towards this SBM2 and the deliberations that have taken place since yesterday here. I would like to suggest 2, 3 suggestions. In order to handhold states' UTs, especially on matters related to choice of technology and design of sewer networks, there needs to be a centralized or decentralized appraisal mechanism put in place by the National Mission Directorate. States' UTs are still struggling with primary basic issues and the removal of doubts. Number 2, since missions are always time-bound, there must be either preparatories for these missions at least 2 to 3 years in advance, or first 2 years of the mission should be preparatory. Before launch of missions, all exercise with capacity with preparation of city sanitation action plans, gap analysis, design work, DPR preparation, including appraisal of DPRs, standard big documents, amendments, and customization of operational guidelines to suit the requirement of each UT/state should be in place. This will ensure implementation of mission on ground in a timely bound manner, as also timely achievement of desired outcomes of the mission. The third one is that there is a huge deficit in capacities of small ULBs. A lot of hand-holding is required, more than funds in successfully implementing SBM in a time-bound manner. So nice of you, sir. I am grateful for having called me to speak here. Thank you so much.
Now I would invite, thank you, sir. Now I would invite Chief Engineer UP Jal Nigam, Mr. H.K. Council.
Good afternoon, ma'am. We are refreshing our knowledge since last 2 days here. And because we all are engineers and experienced one, so getting refreshed is a wonderful experience by all the learned people and speakers. As far as UP is concerned, we are a big state, definitely. And we are having 703 ULBs, which are below 1 lakh population. So far, we have submitted 139 CSAPs, and we are planning to submit it by March, all the 703 ULB CSAP. In engineering, it is usually perceived that there are certain things which are dependent on certain things. For example, we are dealing with the ULBs from, say, 5,000 to 1 lakh population. And the capacity of STPs, it will range roughly from 0.6, 0.7 MLD to 7 MLD, because we are treating 70% discharge. So 7 MLD will be the maximum we will be handling. So all we know that it is dependent on the availability of land, energy resources, and OPEX and CAPEX values. So my suggestion by learning is that it is a subjective matter to decide which technology to go for the state like UP, because we are almost similar topography and similar type of domestic sewage is concerned. So characteristics are almost same, ranging in 10-20% variation. BOD, COD, TSS, the main pollutants, we are almost same. So I had a opinion after that much hearing and that much things, that CPHO, Government of India, should, if they can, issue an advisory type of thing that for such type of such capacity of STP, this technology will be better, because all field engineers are of different subjective matter, different subjective understanding. So they can opt sometime a cost-effective technology as of now, but it could be very difficult to maintain. And we all know that the ULB's capacity is what, and what they will do in future. So my opinion, I mean, I would like to have a opinion of the Government of India or CPHO that this type of technology in this type of MLD capacity will be better. So because technology selection is the biggest criteria. The rest of the things I think we can handle, and whatever is written in the guidelines, they are fitting quite a bit. 50% population is living in 20-30% fringe area. So far 139 CSAPs we have considered, we have analyzed. So they are quite fair. I mean 10-15% variation is always there. So if you can have a view over it, I will be thankful to it. Thank you very much.
Thank you, sir. Now I would invite Mr. Prashant Mahapatra ji, is the Chief Engineer, Orissa Water Supply and Sewerage Board.
Good afternoon, my friends. Madam Namaskar. These 2 days have been a very wonderful experience for us. So it has been very quite refreshing. First, meeting all our colleagues. Second, the vision and mission of the Government of India. And to put in context about Odisha's situation, Madam, as you know, we have 70 lakh population residing in urban areas. And we have around 106 towns where the population is less than 1 lakh. And 50% of the population live in these towns where the population is less than 1 lakh. So far in the last 5 years, we did a lot of work on-site sanitation, fecal sludge management. Out of 105 towns, we plan to build 119 FSTPs. And as of today, we have built already 108 FSTPs. So the vision of the state is that we will be dealing this black water and gray water separately, though we understood that there is nothing called pure gray water, it's all mixed water, mixed wastewater. So therefore, since we have already achieved the black water security, so our vision is that in these small towns where the population is less than 1 lakh, we will be taking off gray water management separately. So what it means that our approach is very in a decentralized manner, in line with Government of India vision. Dr. Chaurasia was explaining how to deal with this gray water or the wastewater in on-site. So we have the vision of treating that at the household level, at the land level, at the community level, and at the city level. So it is a step-by-step approach. And to do that, we have already piloted in 2 towns, one in Jatni, the other in Dhenkanal. We have got very good results. And all our wastewater management, this black water and gray water, is built on the capacity of our community partners. We are building the capacity of the ULBs and also the community self-help groups, women self-help groups, transgender groups. So they help us in planning. For instance, while we plan the grey water management, we do extensive survey of the households. We look at what is the type of system they have, whether they have septic tanks or not, whether they are the polluters discharging directly into the drains, and whether the space is available in the household to have any on-site structures. And also they are involved in mapping the drains. The one Mr. PG was talking in the morning session, that if you have to do IND, any intersection diversion work, you also need to understand the typology and the hydraulics of the drain. So we are also involving the women self-help group in collecting all those information about the type of roads. So once we have all those information, then we plan what is feasible and what is not feasible. So we're also developing a toolkit which will tell us what kind of structure is feasible where, what do we need to do in household. So how many houses can have those kind of structures, and what we can do at the land level. And finally, once we have secured some treatment or some management at those levels, so the quantity of grey water or the wastewater that will flowing at the outfall would be significantly reduced. So that also would mean that the land that we require and the volume of wastewater that needs to be treated would also be reduced. And I am also thanking Dr. Chaurasia once again. He also shown a slide of cold treatment of Puri. So Puri is the first STP we built. In Odisha, we have 11 functional STPs and 2 are under trial run. So one of the STP in Puri, there is a 15 MLD capacity STP, where we did the cold treatment of fecal sludge in that plant. So that has become a model, and I see those slides which I shared with you. So constantly showing, so that also is an inspiration for us. So I am thankful to you for projecting that model as the best suited model. So madam, we are on track. We have already prepared city sanitation plan for 78 towns. So as our colleagues mentioned, so it requires a lot of capacity building for the ULB and also training and also IEC campaign to carry this mission forward. So we will be definitely needing time in planning all those things. And finally, I also would like to draw your attention. Today, we don't have any standard for sludge. In the STPs or FSTPs, we produce a lot of biosolids. We dry it and it contains pathogens. So to make it suitable for reuse, it also requires how to handle that SOP or some kind of mechanism would be necessary. And Dr. Chaurasia mentioned that with the experts, the CPHO is working on that. So that document also would be very vital. The other point of concern for the states is about the standards of treated water. So we are still confused whether we should follow the 1986 standard or the 2019 NGT standard. And our pollution control boards, they also prescribe very stringent standards when it comes to the consent to establish and consent to operate. And we are told that we should follow 1986 standards. So if that communication comes to us, or if that gets resolved quickly, so that will be also used. Since we are investing hugely on this program in building FSTPs or STPs, co-treatment and IND works. So these two would also be very, very helpful for the states. Thank you, madam. Thank you for giving me a chance.
Thank you, sir. Thank you very much. Now I would invite Mr. Sunil Kumar. He's in Mission Director, Bihar.
Good afternoon, everybody. Good afternoon, ma'am. At the outset, let me extend my sincere thanks to Madam for immediately agreeing to our request to send the experts to Patna for preparation of our CSEP plans. Within a short notice, within a day's notice, when we requested the Madam to need some help in hand-holding in preparation of CSEP plans, she was kind enough to send Dr. Chaurasia and Mr. Satish at the Patna, and they are of great immense help. Madam, as far as Bihar is concerned, it has the highest population density, so highest in the India. So it has a very typical typology also that river Ganga bisects Bihar into exactly two parts. The southern part, Bihar, is a water-stressed area. It's highly water-stressed area, while the northern part is having a lot of rivers which are flowing from Nepal, and the other tributaries of Ganga, they join Ganga, so it's flood-prone. Most of the time, it's flood-prone. So selection in the kind of technology and what all things we need as far as the processing and treatment is concerned, there are two different aspects are there. Numbers, I'm not that aware, like how many numbers liters of MLD is treated, is generated and treated. Few of the STPs are coming up from the Amrit scheme. We have constructed few of the STPs, mostly in Patna, but still what I am being told by the engineers that we are still short of the number required. We are, I think, able to process some 50% of water only till now. So the great work has to be done. Here, I came here just 1 month back. I've joined as a mission director directly from the field. I was not aware about it, ma'am. So I myself came here knowing what exactly is the used water. I was not till aware I Googled before coming here what exactly you mean by the used water. I have heard of only the sewerage, like this needs to be treated. So here when I came to know that used water is a very wide dimension, like I'm really going with a very enriched experience, and a lot of work has to be done that I came to know here. A lot of best practices which are being followed by other states. So being a late starter has one advantage, that you have examples. You don't have to, create the wheel. You don't have to create the things. You can simply adopt and modify accordingly to your needs. So after 2 days here and after 2 more days to go, I think the experience which I gain here will be of immense benefit to us in Bihar. Thank you, ma'am.
Thank you, sir. Now I will request
Yes. So thank you very much. Since ma'am have another engagement, I request ma'am to just encourage us so that we can.
Thank you so much. It's really heartening to see all of you come here in one forum from different parts of India to speak about small cities. All of us stand here at this very proud moment when India is right now having the presidency of G20, when COP27 discussions are going on about environment, climate, water, health and sanitation, of course. And we have all come out of the COVID pandemic where the lessons for us as a community and fraternity has been incredibly significant. So having said this, if we just look back at 75 years of India's journey, we will see that every time there is a large mission, things somehow get pushed because India is a very unique structure where water is a state subject. The 73rd Amendment has delegated it to the local self-governments, and the government of India kind of plays the role of an enabler and facilitator. So all these three coexist in a beautiful symmetry. And we have seen that every time there has been a large national mission or program, you look at it across sector, starting from millets mission to health mission to sanitation mission to water mission to anything, everything, all these institutional mechanisms start collaborating and putting their energies together. And in COVID, if we have seen that if at the end of it, anything finally made us succeed, it was because we stayed together as a community, irrespective of department, irrespective of missions, irrespective of the hierarchy of or the levels of government or institutions that we were operating in. So today, I say this for a simple reason. I'll explain that in the next 2 minutes. We are looking at water as a resource. We are looking at climate change as a subject. We are looking at environment as an aspect. And we are looking at this entire subject as a whole. All of us sitting here in this room have enough understanding and experience to appreciate that we cannot look at this subject as a subject of engineering solution. It is a social, it is a managerial, it is a socio infrastructure, which will require engineering solution as one aspect of it. I have heard state representatives speak of various dimensions. You spoke of capacity, you spoke of funds, you spoke of policies, you spoke of tariff, you spoke of land availability, you spoke of rural-urban convergence, you spoke of decentralized mechanisms and the role of partners. So there, you spoke of community behavior. So all of it is not engineering solution alone. So having realized this, I would request one more step forward. We have to look beyond missions and programs. We have to break this barrier that this is under Amrit, That is under National Clean Ganga Mission. This is under Swachh Bharat Mission. That is under World Bank project. This is under so and so project. All of you are leaders in the state. In fact, that is the reason we said that this particular capacity building program is for the highest level of engineers and decision makers in the state. You must have seen we were a little selective when we were receiving your participation. Because we want that when you go back, you look at it as a subject beyond mission, program, rural, urban, departmental boundaries. Otherwise, very soon we will have a time when it will almost be non-reversible. Therefore, I would request that we start looking at all the aspects that you were just mentioning. First of all, what is the overall policy of the state? You have a state high power committee for Amrit. You have a state high power committee for Swachh Bharat Mission. You have a state high power committee for something else. Have we started using Chief Secretary's Forum, where Chief Secretary is there, secretaries of different departments are there? Have we started using the SHPC as a forum to discuss the broad aspect and approach of the state for used water or for sanitation? It is time we start doing that, because it needs involvement of the Pollution Control Board. It needs agriculture's onboarding. It needs industries participation. It needs forest and environments cooperation, Panchayati Raj, rural, urban development. Please start using SHPC as the apex body of policy making and not just using it for approval of your proposals, which is very, very small. That becomes a very narrow approach to dealing things. And each of you is a leader who has the capacity of changing it right next month in this next SHPC. Number one. Number two, take your leadership. Many of you are senior engineers here. You can create a core committee of senior engineers of these departments without depending even on your principal secretary and chief secretary to first brainstorm on what approach we should follow for sanitation and used water management. And when I say used water management, you should not forget about the kind of approach, investment, and the effort that we are currently putting in the piped water supply projects as well. These have to be looked arm in arm together. We cannot afford to think of this is an Amrit city. We will do the drinking water supply because this is the fund, and I will start cracking my head as to how I do grey water management through something else. When you are planning for it, from the planning stage itself, we have to look at it differently. And that time of looking at it as a subject and time of looking at it beyond boundaries is right now. A friend from JNK said that the first 2 years prior to a mission should be planning. I wholeheartedly support it. Let us take this year as the year of planning. We still have 3 more years for project completion. Maybe somebody would be 70% complete, somebody would be 60% complete, somebody who has great speed and progress would be 90% complete. Absolutely no problem. But the beginning is now. I would request each one of you to go back to your states and use these first 2 to 3 months now. And I will ensure that we meet back again in a similar forum in 3 months from now to plan properly for your state and plan for the future. Today, you look at any drinking water supply system in your city. I come from the city of Bhubaneswar. My friend, Mr. Mahapatra just was mentioning about Bhubaneswar. Each of you look back. Your water supply project was done when? 30 years back, 40 years back, 50 years back, 20 years back. Engineers like you did it. They thought 50 years into the future and they have left behind legacy, which gives service even today. So today, when you all are in the driver's seat, you cannot think of only 1 year. You are thinking of the next 20, 25 years is our joint responsibility. And when we look this, that is when at SHPC level, principal secretaries level, we need to take a discussion. If this were the approach, then what is it that we will take? That is reverse planning. First is what is it that we want to do in the state? What will be our approach? Then we do a reverse planning of which ministry, which department, how do we bring in DMs to give on an absolutely mission mode basis the responsibility of land identification. Because if you leave the cities to identify your land, it will never ever happen. So, and what is the rural-urban convergence? Is there a possibility of clustering somewhere? There is even a possibility of clustering Amrit and SBM. Amrit and SBM cities also can be clustered. Nobody has said no to any of these. So break these mental boundaries. Think of it in a futuristic manner. I completely take the point that there is a lot of a requirement for us from central level and the state level to give very solid support to cities right now, and also even to the state missions to plan DPR, do the bidding documents, choice of technology, where maybe, try and see which option would work out best. You would want some kind of an expert advice. So I would request CPHU to please work out on 3-4 things. First, please create a network of senior engineers, all from different states, and try and see how in a bi-monthly manner, we at least touch them on a regional basis, because that will give a little more depth. When we have a regional discussion, field level engineers will be able to participate in the discussions. So how do you have a continuous, the way you have chapters in different organizations? So used water management chapter similarly should be curated so that there is continuous idea and knowledge sharing at regional levels, which is down below. Second, we have already spoken to the Principal Scientific Advisor's Office to be helping us for this core committee for technology. I think we need to start triggering it very quickly, but that is for validation of new technology. Even for existing technology, they will need some kind of a hand-holding. So please create a formalized committee structure, having representatives from different states also on that national committee, which can actually give advisory guidance to any state or city whenever they ask. We can give them advice. After that, they can weigh the solutions. They need not even go by that, but at least they'll get 3 different ideas. So try and pull in different people and create that kind of a structure which will help them for technology choice. The third thing, they will need very solid support for their procurement. And procurement should never be looked as a standalone exercise. From my little experience in administration, I have seen that procurement works well when many things are taken into consideration very well from day one, especially in such projects. First, the nature of the place, the usage, the growth patterns, the possibility of development authorities and periphery areas, any kind of a prospect of industrialization, the general natural topography, terrain, and the natural conditions of the area, the actual availability of land, all of it are to be looked at while preparing your base planning. And once you do that, I think the procurement per se with due participation of private sector is a very, very important exercise. For that, whether they will use a clustering method of tendering or they will do single tenders, because it is the responsibility of urban local bodies, state mission cannot also take it over. In some places like UP, where they have a very strong parastatal of Jal Nigam will be in a position to possibly give that kind of a support with some augmentation from outside if required. Many states might not even have that kind of a parastatal. So who gives the implementation support to the state, and what is the capacity of that mechanism, whether by way of empaneling few organizations so that that kind of becomes like a short tender base for them and reduces their time of procurement, we can explore that. That's a strong possibility. Or else we prepare a few model documents, papers, and share it with them. That again saves time. So I would say that we have a very strong role of national support to be given to both state missions, parastatals, as well as cities. So is pe thoda sa you all do a groundwork. And my last point would be, today is a time when at every forum, Prime Minister has been challenging us with this thought of how do you bring circularity in different sectors, be it on e-waste, be it in dry waste, municipal waste, be it in tires, batteries, rubber, textile, or be it in used water, both domestic and industrial. The idea is water being a limited resource and fresh water being a limited resource, we will have to look differently. The time has already come to look differently, wherein we treat water as a resource. And in our usual day-to-day government activity that we have done, we many times don't monetize it. We don't monetize it. We end up spending a lot on treatment. We will just give water for free. Somewhere some nominal charges are there. Somewhere there are issues of quality. And let's say we were talking of power plants who were not very keen to take it because of the nature of the treated water which is there. So given whatever it is, how do we, from the point of planning, how do we bring in circularity so that you as the senior most policy maker should know that when I am doing all this, finally, what is it that happens to the treated product that I have? Dr. Mahapatra raised the concern about standards for sludge. That is something that we must have a look at. Standards for treated water, that is something which at the Government of India level we must look at. But in terms of utilization, in terms of network, where are the pipelines? How does it go? How is it planned? What is the revenue model out of it? There are very few states today in the country that have a policy for monetizing treated water. So what is it that we will need in our respective states? Because 3 years, 4 years, you will have treated sludge, treated water, all of it. So what is the kind of agricultural requirement? What is the kind of horticulture or let us say other municipal requirements that you have, construction requirements, industrial requirements, and what is the state approach? Maybe today you will not come to a consensus for policy because it will also need political leadership. But once you start flagging the discussions, and of course, we will be taking it up with the state governments also, maybe in 2 years, maybe in 2.5 years, maybe in 1.5 years, different states at different levels in this journey will start coming towards the policy approach for circularity in used water. So these are the few things for which we thought to make a beginning. We'll bring all of you to one forum. You brainstorm. Not every question of yours is expected to be answered in this particular workshop. But the expectation was all of you come, you meet each other, your colleagues, you create friendships amongst each other so that you co-learn from each other and you go back with 10 ideas. And try those ideas. We may fail. We are all together in this journey. So let us try and work out with this approach wherein we think long-term, we think holistic, and we think very futuristic. However, the solution must be economical because it is public finance and we are answerable for it. Also, it must be environmentally viable, sustainable, and very important, every project must have some kind of a futuristic view into it as to how is the O&M going to be taken care of once these national missions are not going to fund it beyond 5 years. We will not say that by that time my successor is going to take care of it. We will not think of that. So planning for the O&M of the project is our responsibility when we conceptualize projects. And trust me, there was a time when there were no roads in Gram Panchayats. There was a time when there were no roads in even cities. We brought in roads. There was time there was no telecom connectivity in different Gram Panchayats. We brought in telecom connectivity. There was time when there was no banking network in these places. We couldn't ever imagine how all these places will get on to banking. Today, every person is connected through digital banking. So everywhere, boundaries have been conquered. Everywhere, projects have succeeded, because behind every project lie people like all of you. Once we decide that this is our approach and we are going to work together, we will be able to do it. The beginning of this journey for small cities has been embarked upon under Swachh Bharat 2.0. When I say Swachh Bharat 2.0, I limit myself only for the purpose of financing and funding. Again, I would like to reiterate that the approach is beyond mission boundaries and beyond funding provisions. I wish you all the best, and I really hope that these 4 days here at Bangalore is going to recharge you, re-invigorate, re-energize you, and you will go back with bright ideas as to how to approach your different unique problems and challenges that you have in your states and cities. We stand with you in every step of the journey. Thank you very much.
Thank you, ma'am. Thank you very much. With your introduction, I think states are definitely feeling very much charged, and they are going to now work. Already 2 days we have discussed on futuristic, plant-based, and the constant, many of the things you have mentioned already, they have also discussed. For want of time, we could not present in that way, but in a form of report, we will bring to you. And all the points that ma'am has mentioned, we are going to one by one take an action plan, and we will be creating a network and periodic meeting. One standard related matter, one confusion is there, it costs money to country and all ULB. Usme separately, I will again put up some point of time, I briefed also, but now it is a time we have to take a phrase that will help a lot, because a lot of confusion is there, and technology selection under pressure, even if they select that, operation maintenance become a problem. So some of the issues are there that definitely will do. With encouragement, they are doing fine, and we definitely wish ma'am, और जब भी होगा आपका guidance ले.
I would like to place on record our sincere appreciation from the Ministry of Housing and Urban Affairs to our partners, WashEye. The WashEye team has painstakingly worked out all the details of this program. They started off, of course, which was initially thought that it will be a regional workshop for a few states, and then they moved to regions. We said, no, let's start off with a national, and then we will go through regions. And after that, bringing together speakers, trying to take steps to make your stay comfortable, liaisoning with you for your logistics. This team of WashEye has left no stone unturned to make this a success. I would request all of us to just give a round of applause to thank you for your efforts. And I would also seek that there is scope for each and every partner who is working in this sector to join hands with us. This is a national priority. This is a national agenda. And we will be shortly empaneling knowledge partners who will be working with different states for action plans, for DPRs, for tendering. And I take this forum to call upon each and every partner, each and every technical institutions that's interested in this sector. Somebody may like to do research papers, somebody may like to do ground assessments, somebody may like to do rapid assessment, somebody may like to do a case study analysis, somebody may like to do just a pricing study, somebody might just like to come up and help with action plans with the city, somebody may just like to do training programs and knowledge dissemination. the sky is, I mean, the area is unlimited. So through Sashank, through Washai, Kalimuthuji is also here. I would request you to spread the message to all partners. Partners should come and formally approach states and commit their effort and time so that there is a understanding between the states and the partners that from here on, we are married for the cause of used water management. Okay, thank you very much. Thank you. Garbage free city mein ye plastic cover use nahi karna, right? Yes. I would also like to request that our target is ODF++ for every city by 2026 and 50% of the city's water plus by 2026. I would want to hear from each one of the states in the next meeting that we have, what are your own targets and your timelines? Somebody may say that it is difficult when you put targets like that. I would look at it differently. Our road becomes very structured once you put your targets. So if you are to say that 1 year prior to the national mission, I will make my state ODF++, then your entire approach will be different. Your implementation plan will be different. Your energies will be different. So please make your own planning of how you will make every city of India ODF++ and at least 50% of the cities water plus. And all of it is under the garbage-free city mandate, right? Okay. Okay.
This is a GI tagged product from Karnataka. It's made by self-help group.
So I got this beautiful thing. I hope they have given you something also. Very nice. This is made out of?
It's called Bidri art. It's a very famous art.
Very nice. Thank you so much.
Thanks to Government of Karnataka, ma'am.
Thanks to Government of Karnataka. Thank you so much. Thank you.
You get it back.
Thank you. So all of you, please carry on and please consider it a personal invitation from my side to join us on the 19th for the World Toilet Day. Starting from 2014, India has created a history and a heritage in the arena of toilets and sanitation. 8 years of this incredible journey are over. Now, all of us have been given the responsibility to take the 2.0 journey ahead. So in the aspect of access to toilets, functionality, operation, maintenance, collection, and management of the sludge, each of us will have to think of the 2.0 vision. So 19th will be the forum when we will come and reaffirm our commitment for Toilets 2.0. So request each one of you to join us on the 19th, and I'll see you there. Thank you very much.
Can you hear me? Thank you. So I'll request the live streaming to stop because you can stop the live streaming. Yeah. So there are certain announcements regarding tomorrow's field visit. So I'm assuming that you have all seen your names or at least